common formulation, which does more justice to the core of the matter, is the term the observable universe, whereby the speed of light plays a major role here. Since we can only see things when the light that they emit or reflect reaches us, we can never see further than the greatest distance that light can travel in the time that the universe has existed. Cosmologists estimate that the oldest photons we can observe have traveled a distance of 45 to 47 billion light years since the Big Bang. This means that the observable universe is about 93 billion light years large, plus or minus a few light years. These approximately 93 billion light years contain all the quarks, quasars, stars, planets, nebulae, black holes ever recorded by a telescope, and everything else that we might be able to observe but have not yet seen. But the observable universe contains only the light that has had time to reach us. This also means that the observable universe is getting bigger and bigger. However, the universe is also finite. The limited amount is also called the Hubble volume, after the telescope that has given us the most distant views of the universe so far. We will never be able to see beyond this limit, so it's basically the only universe with which we can ever interact. However, we know with a probability bordering on certainty that there is more universe beyond that limit. Astronomers believe that space, invisible to us, could also be infinite, with matter, energy, galaxies, etc., distributed pretty much exactly as in the observable universe. Beyond the Hubble volume, we will not only find more planets, but also other planets very similar to our Earth. If we go far enough, we will find another solar system with an Earth that is identical in every respect, where you had cereal for breakfast this morning instead of eggs, and another world where you skipped breakfast, and yet another world in which you got up in the morning and then robbed a bank. In fact, cosmologists believe that if you go far enough beyond the boundaries of the universe, you will find another Hubble volume that is completely identical to ours. And in those other Hubble volumes, there is another version of you out there that reflects every possible action you might take. This may seem unlikely, but then again, the infinity of the universe is very hard to imagine, because it's simply beyond human imagination. To break this down, according to the theory of relativity, objects that are close together cannot move against each other faster than the speed of light. However, there is no such law for objects that are extremely far apart when the space between them expands. In short, it's not that objects move faster than the speed of light, but that the space between the objects expands, causing them to fly away from each other at amazing speeds. Ultimately, this means that we could only reach the edge of the observable universe if we developed a transport method that would allow us to either 1. Travel faster than the speed of light, a theory that most physicists believe to be impossible, or 2. Transcend space-time by wormholes or warp propulsion, which most physicists also believe to be impossible. Dark flow. In 2008, astronomers discovered something very strange that they had not expected. Galactic clusters were streaming in the same direction at immense speeds, over 2 million miles per hour. New observations in 2010 confirmed this phenomenon known as dark flow. Scientists discovered the phenomenon by studying some of the largest structures in the cosmos. Giant galaxy clusters. These clusters are collections of about 1,000 galaxies and very hot gas that emits X-rays. By observing the interaction of X-rays with cosmic microwave radiation, or CMB, left over from the Big Bang, scientists can study the motion of clusters of galaxies. The X-rays scatter photons into the CMB and shift the temperature in an effect known as the Sunyaev-Zeldovich kinetic effect. This effect had not been previously observed as a consequence of clusters of galaxies, but was first noticed by a research team led by Alexander Kashlinsky, an astrophysicist at NASA's Goddard Space Flight Center, when it examined about 700 clusters that were up to 6 billion light-years away, halfway across the universe. They compared these clusters with the map of the CMB taken by NASA's Wilkinson Microwave Anisotropy Probe, WMAP, satellite. The motion of the clusters defies all predictions about the distribution of mass in the universe after the Big Bang. One possible cause: massive structures outside the Hubble volume that exert a gravitational influence. Scientists are almost certain that the source of the suction lies outside our known universe. This would mean that the structure of the infinite universe is not uniform beyond our point of view. As for the structures themselves, they could literally be anything, from accumulations of matter and energy on almost unimaginable scales to bizarre fault lines that conduct gravitational forces from other universes. Infinity bubbles. Talking about things outside the Hubble volume may be misleading because it is still the same universe, only part of it we cannot see. The same physical laws and constants apply. In another version of the story, the expansion of the universe after the Big Bang led to the formation of bubbles in the structure of space. Each bubble stopped expanding together with the rest of space and formed its own universe with its own laws and physical constants. In this scenario, space is infinite, and each bubble for itself is also infinite, because a single infinity can contain an infinite number of infinities. Even if you could somehow break through the boundary of one bubble, the space between the bubbles would still expand, so you would never reach the next bubble, no matter how fast you move. Black holes. A theory proposed by physicist Lee Smolin, known as the theory of fertile universes, states that every black hole in our universe causes the creation of a new universe. Each universe will have slightly different physical laws than the previous one. In this way, Smolin suggests a kind of natural selection for universes. Since laws and physical conditions that lead to the frequent formation of black holes are also the reason for the formation of other universes, while universes that do not form black holes become extinct. The theory has since been disproved by Smolin himself and others. Infinitely many parallel universes. There are innumerable theories about parallel universes, but the most valid theory today involves a further development of the ideas of the string theory. This involves so-called membranes that oscillate in other directions. It would go beyond the scope of this video to go into too much detail about string or membrane theory, but the core of the theory is that the rippling membranes beyond the worlds in the 11th dimension are completely different universes, and when the ripples collide, a new universe is formed. The effects of the wave motion help to explain the observed distribution of matter in our universe. One of the strangest elements of the theory is the notion that all the gravity we experience in our universe actually enters this universe from another universe in another dimension, which explains why gravity here appears so weak compared to the other fundamental forces. The InSight Mars lander touched the surface of Mars for the first time on November 26, 2018. In the course of the nearly 4-year mission, NASA finally discovered what scientists had been looking for on Mars for so long. But what is it that researchers have wanted to know about Mars for so long? And what will this discovery change now? Are you curious? Then follow us now on this journey to the last secrets of the Red Planet. InSight's launch to a mission of the century. Mars probes and rovers have been many in the history of planetary exploration to date, but InSight was different. The unusual lander was designed and equipped like no probe before it. Scientists involved in the project eagerly watched the launch of the Atlas V rocket that would carry InSight into space. On May 5, 2018, the time had come, and the spacecraft lifted off from the Vandenberg Air Force Base and set out on its journey. At NASA, the launch of the mission was viewed with mixed emotions. At that point, more than half of the planned Mars missions had failed. Either they had never launched, or they had failed when they arrived on Mars. Millions were lost as a result, and no one knew what InSight's fate would be. InSight also began with a problem. A previous launch attempt was delayed for several months due to a vacuum leak in the SEIS instrument. But all went well. In Earth orbit, InSight slowly detached from the rocket stages and then floated freely in space. The lander was in space for 6.5 months. The technical device covered 484 million kilometers until it entered the thin atmosphere of Mars, 125 kilometers above the surface, on November 26, 2018. The probe, which weighed just 700 kilograms, hurtled through the atmosphere at almost 20,000 kilometers per hour, having to withstand temperatures of around 1,500 degrees Celsius. To ensure that the fine measuring instruments on board the probe and all the other expensive gimmicks could withstand this extreme stress, InSight was securely packed in a kind of protective cover. The probe covered the last few meters hanging from a parachute, and its own small rocket engines provided the necessary counter-thrust to let the probe land safely and softly on the Martian soil. As soon as it arrived, InSight began deploying its solar panels and taking initial measurements. Thus began some 4 years of exciting Mars exploration. Past Mars missions. InSight was the first high-power seismic measurement station on Mars. NASA had previously sent 2 other main missions to Mars equipped with seismometers. However, the technology of Viking 1 and Viking 2, which were launched in the 1970s, cannot be compared to the technical capabilities of InSight. Moreover, the Viking missions were quite a bust. The seismometer of Viking 1 did not work properly during the landing and could not be used at all. Viking 2 was able to take measurements, but the instruments were so poorly calibrated after landing that it has always remained unclear whether the probe's measurements were due to seismic activity or wind. InSight's mission and challenges. InSight was intended to make up for this failure of the Viking missions after many years. The probe's main objective was clearly to survey and explore the interior of Mars. For this purpose, the lander, which was about 1 meter high and 6 meters long, was equipped with a seismometer, a windscreen, and a highly mobile robotic arm. The necessary power was provided by the 2 solar panels that gave this probe its distinctive appearance. In addition to the seismic instruments, InSight had a complete small weather station on board and a robotic arm called the mole, which the probe would use to dig deep into the Martian soil to take temperature measurements in the upper layers of rock. First data fascinated. Even during the landing approach, and with the solar panels still folded in, InSight began collecting data. At NASA, scientists and technicians alike were beside themselves. The lander picked up vibrations from Martian winds and, for the first time, filmed clouds of water ice passing directly overhead. Tapes of the sound of Mars have been thrilling millions of people on the web since the mission launch. The secret of seismic activity. Seismic signals are any vibrations or intrinsic sounds that a planet experiences or produces. Like Earth, Mars is not silent inside. Or at least we know that now, and thanks to InSight. Before, it was not so clear to scientists just how alive and active Mars still is inside. Today, the planet appears to be a desolate, rocky world with stunning rock formations, sweeping mountains and deep canyons, but traces of life or vegetation are completely absent, as is evidence of liquid water. There are several references to dried-up lakes and even entire oceans and river courses. But where has all the water gone if Mars was once a mild-water world? In addition to monitoring seismic activity such as Mars quakes, InSight was designed to scan the interior of Mars. Over the months, a perfect map of the Martian interior emerged thanks to the recording of internal waves. On these interior maps, researchers hoped there should also be evidence of underground lakes or water deposits. But first, the scientists' main interest was the activity of the Martian quakes. InSight has recorded about 450 seismic tremors. These Mars quakes are usually very fine and uniform. The strongest of them have magnitudes of 4.0 to 5.0, although the vast majority of quakes stayed well below that. The sound of Mars's interior was surprising, as researchers detected tremors with a repetition frequency similar to the human heartbeat. It almost seemed as if Mars was more alive inside than scientists had previously thought. Each of these tremors also tells a unique story about Mars's geological activity and its ongoing evolution. As the fine waves travel through the Martian subsurface, they encounter different layers of rock, cavities, and strata within. Each of these layers interacts with the quake waves through its own vibrational patterns. Based on the changes that the frequency patterns undergo as they travel through the planet, researchers can find out details about the planet's internal composition and makeup. Lucky meteorite impact. The questions scientists have long sought answers to were whether Mars still has an active core in its interior, and why it evolved to become dust-dry and desolate today. By a lucky coincidence, both of these questions were answered. On the other side of Mars, a meteorite had hit and had caused vibrations, which went at once across the planet. These waves measured Mars virtually once in its entire cross-section, and thus finally provided scientists with the answer to the question of the core. Researchers were able to perceive for the first time that Mars does indeed have an active core. The surprise was that this core, which is about 1,830 kilometers wide, must be liquid throughout. Our Earth has a core of nearly solid iron, surrounded by liquid materials and a crust, creating an optimal, stable magnetic field that protects us from influences from the cosmos. Mars's weak magnetic field was almost certainly responsible for leaving the planet almost defenseless against the bombardment of solar particles and cosmic rays. The magnetic field specifically protects us from radiation from the sun. The magnetic field lines catch the myriads of particles that hit our planet daily from the sun and guide them along their course lines into a kind of protective bag. On Mars, this protection may never have been as well developed as it is here. Solar winds and radiation from space hit our neighboring planet much harder. The atmosphere probably became thinner and thinner, water escaped into space, retreated underground, or froze. If Mars really once was a world similar to Earth, it became desolate because of the lack of protection. In the course of the InSight mission, evidence actually also grew that Mars really was once a world with water, a mild climate, and perhaps plants or simple living things. Deep beneath the dusty surface of Mars, the Mars lander found evidence to support these theories. Measurements there showed another magnetic field 10 times stronger than scientists had previously thought. This ancient magnetic field, trapped in the rocks of Mars, provided evidence of a time when Mars had a denser atmosphere and possibly liquid water on its surface. The Song of Mars. While InSight was unraveling the seismic mysteries of Mars, the spacecraft encountered another unexpected sound inside. The mysterious hum that sounded almost like a ditty. After the heartbeats of Mars and the gentle whistling of the wind, it was now almost as if Mars was casually humming away. Astrogeologists describe this humming like a melody of Mars waiting to be understood by us. Compared to the barren and rocky surface, which has so far held few surprises except for endless landscapes and lots of rock, the sounds of the planet are a veritable treasure chest of new discoveries. No plates, but a crust. During its 4-year observing period, InSight's seismic experiment for interior structure surveyed nearly the entire interior of Mars. Like X-rays, the seismic waves ran through the planet and revealed, among other things, that Mars has no continental plates like Earth. Rather, the surface appears to resemble a single solid crust. Planetary scientists had long suspected this, and thanks to InSight, confirmation finally came. The crust turned out to be much thinner than expected, but regionally, it has 2 or even 3 sublayers. The thickness of the simple crust is usually around 20 kilometers. Where there are 2 or 3 sublayers, it is up to 37 kilometers thick. In addition to all these discoveries, InSight has studied Mars's volatile atmosphere, recorded hurricanes and real tornadoes, and collected thousands of data on wind speed and direction. Thanks to this information, scientists now have a comprehensive picture of the weather and climate on Mars. This data will, of course, be of paramount importance in preparing manned missions to Mars. Dwellings for humans, who will one day study Mars on the ground, must be optimally adapted to the weather conditions. No human being can survive on the planet for long outside a protected shelter. The harsh Martian climate was also felt by inside. After surviving numerous sandstorms, so many deposits had formed that the solar panels were increasingly failing. After 4 successful mission years, the end came for InSight. The power supply was simply no longer sufficient. In December 2022, NASA announced the official end of the mission. NASA is the largest and most powerful space organization in the world. Time and time again, rumors abound that NASA has information about space and aliens that it does not want to share with the ordinary people of the world. Time and time again, whistleblowers have leaked suppressed images or made public statements about what is really going on at NASA. We have to ask ourselves, why are certain photos being hidden from the public? What explosive information do these photos contain? Stay tuned as we investigate these mysteries and uncover banned NASA files. From backyard to world organization. In 1958, NASA was founded as the National Aeronautics and Space Administration in a backyard office. The goal of the then insignificant organization was to oversee the U.S.'s just emerging space projects. A short time later, NASA became an official government agency. If the importance of space travel increases in the future, and if humans even colonize space, NASA's power will continue to grow. This all sounds fine and dandy so far, if it weren't for the rumors that NASA, as well as the US government, the Pentagon, and the CIA, are not entirely kosher. The rumors say that NASA was also founded from the beginning to pursue a cover-up policy against the quite normal population. In the late 1940s, a missile had crashed over Roswell in the US, described by eyewitnesses as a large, silver-colored flying disc, and quite a few eyewitnesses even claim to have seen 2 lifeless bodies of non-human entities being recovered at the site. During these times, sightings of aliens and UFOs increased. The government, as well as later the still young NASA, always claimed that these reports were hysteria or optical illusions, until secret informants appeared on the scene, claiming exactly the opposite. One prominent example is Donna Hare, a former NASA employee who allegedly retouched thousands of photos on behalf of the space agency. But let's get our own impression of what's really going on at NASA. Is NASA hiding something on Mars? We owe a lot to NASA, that much is clear. Without the US space program, we probably wouldn't know as much about the universe. We never would have seen fascinating images of cosmic nebulae, black holes, and quasars. But could it be that the agency has more information than it shares with the public? Maybe. We certainly can't judge images and impressions we may never have seen. We don't know what all NASA is keeping under wraps. These images, which have certainly become public, are among the points of contention between NASA's critics and the space agency's official spokespeople. Many of the images are from Mars. In part, this is simply because Mars is now the most studied and photographed celestial body outside of Earth. Humans are expected to land there with spaceships within the next decade and establish the first research stations and settlements on site. But is this really justifiable in view of these photos? In 2015, space enthusiasts discovered this circular formation on officially released images of the Martian surface. Which, well, did you guess? That's right. This formation reminds us somehow a little bit of the terrestrial Stonehenge, and accordingly, the almost circular arrangement of rocks got the name Marshenge. Besides the arrangement of the stones, the almost hexagonal appearing foundation of the monument is also surprising. On Earth, Stonehenge has been identified by scientists as a prehistoric stellar observatory. But what could this formation have served for? And above all, who built it there? It's all just coincidence, says NASA. These stones were formed there only by wind, weather, and erosion. But can we really be so sure? It's exactly this security with which NASA scientists repel each reference to the working of higher life forms outside of the Earth. Besides, NASA searches officially for exactly such traces. People are confused about this behavior of the space agency, and more doubts arise whether NASA does not play a gigantic confusion game around aliens on Mars or elsewhere. Until today, nobody knows who had the forces, and also the mental ability thousands of years ago to establish structures like Stonehenge on Earth. So how will any Earthling know for sure who might have once lived on Mars, and if this formation is really just due to chance and erosion? Mars Pyramids. Since the 1970s, NASA is said to have kept photos of Martian pyramids under wraps until they too leaked out. The number of pyramid-shaped structures on Mars is almost frightening. Not only, the pyramids photographed in the 1970s are astonishingly reminiscent of the phenomenal structures on Earth. NASA's Curiosity rover has also captured brand new images of pyramids. The Curiosity rover is a car-sized one that has been traveling in the Gale crater on the surface of Mars for more than 10 years to study rock formations. Actually, the main goal of this space robot is to study the climate on Mars and its geology. The Gale crater may have once been filled with water until Mars mysteriously dried up. Computer simulations have found that several million years ago, our neighboring planet was a water world with a mild climate and possibly life. So how do we, or better, NASA for sure, know that there was not also a higher civilization there, whose former structures are now buried under thick layers of Martian dust? Allegedly, the habitable period had not been sufficient in order to let develop life, according to terrestrial yardsticks. But exactly here the mistake could lie. Very probably we cannot compare the evolution on other planets with the development of life on Earth. Everything only optical illusions? When it comes to clearing up alien rumors on Mars, opponents of such theories like to bring up the example of the Martian face into play. This formation, discovered in the 1970s, resembles a human face. For decades, the image was the focus of speculation surrounding Martian humans. Then, the image was demystified in the present. The impression of a face was caused only by the play of light incidence and shadow, as well as a mental effect known as pareidolia. Pareidolia occurs when the brain suddenly sees things that resemble human structures in barren environments such as rock and boulder deserts. Then impressions of faces and buildings suddenly appear in the rocks, and the Mars pyramids are also thought to be such illusions or miscalculations by the brain. The underground theory. As Mars geologists found more and more evidence that water on Mars might have retreated underground, some UFO enthusiasts and science fiction lovers developed the theory that creatures still living on Mars today might have retreated underground as well. To be sure, even renowned researchers admit that the Martian subsurface could be a possible habitable environment for settlers in the future. However, this is far from speculations that there are already underground settlements of an unknown civilization on Mars. Further evidence for the underground theory is said to be this photo. This rectangular door was discovered by the Mars rover Curiosity in a rock formation. The resemblance to a gateway or portal into underground rock worlds or cities as we know them from Earth is really convincing. At this site, who can't imagine a Martian quickly disappearing underground to avoid prying eyes? If we take a look at the dimensions of the door, however, a slight doubt arises, even among the most die-hard alien friends. Because with only a little more than 30 centimeters in height, this gate is not much bigger than a XXL cat flap. If this is really a portal to an underground Martian city, Martians must be very small people. NASA keeps this secret about Apollo 11. Finally, let's move on to the photos and secrets that came from astronauts. A great mystery of space travel is the Apollo 11 mission, in whose astronauts Neil Armstrong and Buzz Aldrin landed on the moon in the late 1960s. Since then, there have been rumors about what really happened on the moon. Already during the landing approach, there were problems, because the contact to the two astronauts was interrupted for minutes. NASA almost thought they were lost, but then Armstrong and Aldrin reappeared. Instead of landing on a flat part of the moon, the two had to land their Eagle landing capsule on a very rugged part of the moon. This phase of the flight was not televised, nor did NASA acknowledge the faux pas after the mission. But far stranger things are said to have happened on the lunar flight. Armstrong is reported to have said verbatim, "These babies are huge, sir. Enormous. Oh my God, you wouldn't believe it. I'm telling you. There are other spacecraft out there lined up on the edge of the crater, watching us." Bender went public with his information after he resigned from NASA. NASA denied, and at best labels people like Bender or Donna Hare as blowhards or disgruntled ex-subcontractors who wanted to get back at NASA by going public. But for the most part, people at NASA simply remain silent. The organization can afford to do so because it's accountable to no one but the US government and other governments and space agencies involved in its projects. In the nearly 50 years since the moon landing, again and again, sensational statements of Armstrong and Aldrin in private circles about sightings of extraterrestrials and speech prohibition imposed on the part of NASA have apparently been expressed. Therefore, the report about a bizarre finding after Armstrong's death in 2012 caused a sensation. The most famous astronaut of all time had apparently kept some suspicious objects from the Apollo mission in a casket in his closet, and not even Armstrong's wife knew about these things. As for what was leaked, it was claimed to be a photo camera and some smaller technical parts of the Eagle landing capsule. A fierce wave of speculation has again broken out about whether there was still film in the camera and what these photos might have shown. What did Ivan Wagner photograph? Russian cosmonaut Ivan Wagner was on the International Space Station, ISS, in 2020. While there, he filmed a series of 5 lights, which he spontaneously referred to as visitors. Unofficially, information is being traded that unknown flying objects are constantly appearing around the ISS, and once again, astronauts are said to have taken a vow of silence about these things before they are even approved for the programs. The term visitor is supposedly as normal for astronauts on the ISS as it is for us on Earth, except in this case, the visitors are not people or a neighbor's cat. Wagner posted the photo on social media, commenting that he had reported his discovery to the Russian Space Agency. They classified the incident as interesting, but that was it. What do the recently declassified photos of Venus that the Soviet Union hid in the 1970s reveal? Why are these photos causing an uproar among scientists? Long considered a former water world, how did it transform into an inferno of toxic gases and extreme heat? Venus, often called Earth's evil sister, holds secrets that could revolutionize our understanding of her. Join us now as we explore these questions and discover why the fate of Venus concerns us all. A hellish furnace. Popular U.S. astronomer and planetary scientist Michio Kaku said in an interview that Mars and Venus are strange planets of contradiction. Actually, both could still be in the sun's habitable zone if they had atmospheres and strong magnetic fields. It's possible that that was once the case, but something has caused these planets to change in such a way that they are now inhospitable places. It remains our Earth as the only lonely, habitable, and life-friendly planet. But Earth is also changing, and we need to find out more about that change. Venus lies farther from the sun than Mercury and is much hotter than the little planet. Temperatures approaching 400 degrees Celsius would melt even lead on Venus. Nevertheless, people have managed to place probes on this inhospitable world. The Soviet Union succeeded more than 40 years ago. So far, it's the only nation to have more accurate information about the surface of Venus, and important photographs may have been misappropriated. World-renowned physicist Michio Kaku now recalls these missions. The scientist cited the Soviet Union's remarkable photos of Venus as groundbreaking and important sources of information, even if they were taken some 40 years ago. More recently, Kaku gave a riveting presentation on our neighboring planet at a conference of astronomers and futurologists, sparking new enthusiasm for Venus thanks in no small part to the photographs released by the Soviet Union. Among other things, Kaku showed how to explain the volcanic activity on Venus, its lava flows and craters. The presentation offered impressive insights into the planet's past and illuminated its turbulent geologic history. In addition, Kaku showed evidence of signs of water erosion in the form of strikingly polished rocks and channels cut into the ground. This finding prompted researchers to speculate again about the planet's original temperature and the possibility of water on the surface. The race for Mars and Venus. Mars may one day be colonized by humans. If models of terraforming prove viable, Perhaps the red planet could be transformed back into a world with an atmosphere. This is not the case with Venus. The planet is much too hot and too toxic. One may wonder why the Soviet Union invested vast sums to visit the planet and did not fly to Mars. Experts like Michio Kaku suggest that it was because of the competitive situation between the US and the Soviet Union at the time. The Soviets' plans to explore Venus with probes emerged around the time the US announced it would send the first humans to the moon and then send humans to Mars. Before that, the Soviet Union had successfully put the first man into space, and at that time, Soviet spacecraft were also ahead of those of the United States. NASA stepped on the gas and pushed ahead with the Apollo missions. Fortunately, the Soviets turned their attention to Venus, and the tense Cold War rivalry between the two did not carry over to the moon. The Soviet Union sought its own target with which to shine, and that was Venus, knowing full well that it would never be possible to send humans there. The probes that the Soviets built from the 1960s to the 1980s are now legend, as are the photos of Venus. The successes made the Soviet Union the first nation to put a probe on a planet. Before that, only orbiters had been in use. The fact that it succeeded on an inhospitable planet like Venus gave the Soviet Union the prestige it was looking for at the time. The Venera missions. The Soviet Union made history with its first successful landing of a spacecraft on Venus in 1970. Before Venera 7, several missions missed Venus. Others landed, but the technology failed, so no data was sent. Regarding these failures, it must be honestly said today that it's almost a miracle that the seventh probe landed successfully and sent data at all. For Venus, despite its similarity to Earth in size and mass, is an incredibly hostile environment. The challenges begin with Venus's intense atmospheric pressure, which is about 92 times that of Earth. This is roughly equivalent to the pressure of nearly a kilometer deep below the surface of an earthly ocean. A human being would have had his lungs crushed here long ago. Then, there is the extreme heat and toxic gases on Venus. Venus's atmosphere consists mainly of carbon dioxide, along with traces of sulfuric acid and other gases. The pervasive greenhouse effect on Venus leads to heat retention, making it the hottest planet in our solar system. Its average surface temperature reaches a scorching 460 degrees Celsius. Venus's strong magnetic field, which protects the planet from the constant onslaught of the solar wind, can also disrupt or cause technical equipment to function differently than on Earth. In fact, to this day, Venus remains a formidable challenge to all who seek to explore it. Its unforgiving environment and extreme conditions make it the most difficult target for landings in the entire solar system. Nevertheless, even after the initial failures, the Soviet Union continued its efforts and succeeded. The allure of conquering Venus's nastiness through technological know-how was the perfect target to prove the Soviet Union's superiority in space travel. The Venera 1 to 14 probes. Venera 1 was an extraordinary and very large probe, weighing in at around 700 kilograms. Like its successors, this probe had a carefully insulated interior. The purpose of the thick envelopes and layers was to ensure optical functioning of the instruments and to maintain a stable temperature inside them. The first Venera 1 probe is still considered a true testament to the ingenuity of our scientific endeavor. It would have been nice if this masterpiece of engineering had met with immediate success. But Venera 1 fell victim to the daring mission and flew past Venus. But the Soviet Union did not give up because of this. Already on February 12, 1961, the second attempt was launched. Unfortunately, this mission encountered an obstacle on its way to Venus. Despite its valiant efforts, it too failed to reach its intended destination. However, it came within almost 100,000 kilometers of the fascinating planet. Venera 2 was already somewhat adapted. Outwardly, it resembled its predecessors, but the probe was lighter and provided better navigation capabilities. On February 27, 1966, this probe completed its flyby and came within 25,000 kilometers of its target. But then fate struck again, and Venera 2 succumbed to the challenge of overheating. The spacecraft's signals fell silent just short of the target, And again, the Soviet Union did not give up. Venera 3 was the first successful landing on our sister planet, although not very successful, crashing on its surface. Venera 4 sent over 90 minutes of data collection as it descended through Venus's thick atmosphere on October 18, 1967. It found that there was no global magnetic field and that carbon dioxide levels in the air were quite high, as might be expected. Soon, it melted under the oppressive conditions of the planet's surface. In January 1969, Venera 5 and Venera 6 launched 5 days apart. With identical designs, they were able to make precise measurements of ambient temperature, pressure, and composition as they penetrated Venus's atmosphere. The spacecraft looked like Venera 4, but were much more robustly built. Finally, Venera 7's descent module was much more advanced and was designed to provide a soft landing on Venus. The flight, which launched on August 17, 1970, was largely successful. The probe safely touched the surface on December 15, 1970, after about 30 minutes of freefall. Only, for some reason, the probe then flipped over. Although it was initially assumed that Venera 7 had failed, it surprisingly did provide usable data. The lander determined that the surface was over 482 degrees hot, roughly equivalent to a pizza oven. Unfortunately, the pressure sensor failed during the descent. Nevertheless, scientists were able to use the data provided to estimate that the surface pressure in the region was about 92 bars. Venera 8 landed on Venus on July 22, 1972, just as Venera 7 did, except this time the spacecraft did not flip over. Venera 8 measured the ambient light levels on the surface in order to adapt future camera systems to the environment. Venera 9 through Venera 12 were then even more finely engineered and had cameras on board. The weight of the probes increased again to about 650 kilograms. Between 1975 and 78, these models landed, but the cameras failed during the first landings. This was not so much because of Venus itself, but because the lens covers would not open. However, some managed to transmit some fragmentary first images of the surface of Venus. There is something eerie about the first images taken by Venera 9 and 10. Sharp, detailed, and somewhat distorted in all directions, thanks to the wide-angle lenses that they used, they show a rocky, alien terrain stretching far into the distance. In addition to showing the surface, parts of the probes are also visible in the images. The first perfect panoramic images were finally provided by Venera 13 and 14. Launched in 1981, these missions went down in the history of space travel, and the measurement data as well as the images are still considered the best that we have of Venus. The photos showed a landscape devoid of vegetation, consisting mainly of rocks and soil. The dominant color of the scene is a yellowish-orange hue created by the dense atmosphere. The spacecraft also collected data on air and ground temperature, pressure, wind speed, and the chemical composition of the atmosphere and surrounding landscape. Venera 15 and 16 were orbiters, not landers, and had state-of-the-art radar-based imaging equipment that monitored and mapped the entire planet from a safe distance and from elliptical orbits. Although Pioneer 12 was the first spacecraft to use radar to produce a map of Venus, the resolution of the maps produced by Venera 15 and 16 was superior by nearly 2 kilometers per pixel. These probes sent back fantastic, detailed photos that showed large portions of the harsh environment, with impact craters, high peaks, and basins flooded with lava. Several international space agencies have sent probes to Venus since the Venera missions, including the ESA and the Japan Aerospace Exploration Agency. The US left its mark on Venus exploration with missions such as Pioneer 12 and the enormously successful Magellan program. Nevertheless, the Soviet Venera program was and remains the most intensive and successful Venus program of all time. Despite its enormous success, the Soviet Union never released all of its photos to the international scientific community. Only a few were released to the public, intended to depict the Soviet Union's triumph over the United States. The rest of the research, as well as the majority of the photos, were considered state secrets by the Soviet Union, and we're left to wonder to this day what the Soviets really know or knew about Venus. The state has long since perished. Today, the secrets may be held by Russia, or they may have been lost in the turmoil of the revolution. Two mysterious objects have entered our solar system in quick succession, causing chaos. To date, only one of these visitors has been clearly identified. The other remains a mystery and may even be a threat that is difficult to assess. But what is so unusual about these objects? And why could one of the two strange visitors even put us into great danger? We're investigating the matter. Stay tuned and join us for a look at the most amazing discoveries of the last decade. Never-before-seen objects. We know of many objects in our solar system that are not planets or moons. These include smaller celestial bodies, such as asteroids, comets, and even meteorites. These objects all have one thing in common. They fly on relatively irregular courses through the solar system and can become thereby a danger. However, these objects originate without exception from our solar system. They're even exciting relics of the earliest hours of our solar system. When in a fast-rotating dust disk our star was born, mass potentials were formed, from which later planets were born, and some parts of matter also simply remained. These objects we know today as asteroids or comets. They are bundled in an asteroid belt between Mars and Jupiter, and in the outer edge of the solar system in the Kuiper Belt. Every now and then, an asteroid or comet shears off and then flies towards the sun. It's probable that gravitational shifts between the planets and the sun are to blame for this. These objects can become a hazard if they get on a collision course with Earth. For this reason, NASA and other space agencies are constantly monitoring the cosmos around Earth and throughout the solar system. Huge telescopes do nothing but protect us every day. They try to detect every object around the Earth, no matter how small, and determine the orbit and the origin of the object. The astronomers were actually sure they had the situation pretty well under control. But then, something shocking happened. Oumuamua. On October 19th, 2017, the Pan-STARRS Space Observatory in Hawaii reported finding an asteroid that had narrowly missed Earth. The shock was great because the object had only been discovered after it had already passed Earth. If the chunk had been on a collision course, we might have been unaware of it, and the impact would have hit us as if on a dead run. With an estimated size of 1,000 meters, the supposed asteroid would have been big enough to cause widespread devastation and possibly even to trigger a global catastrophe. This shock was not yet digested properly, and the peculiarities began to go further already. The object that had passed so close to us could not be traced to an orbit that led into the Kuiper or asteroid belts. This part was also traveling much too fast for an asteroid. Calculations showed that the object had come to us from outside the solar system, making it the first interstellar object ever recorded and observed by humans to visit us. The shocks about this object did not stop there, because what was it? Where did it come from? And was there any danger from this thing? The object was given the Hawaiian name Oumuamua, which means first messenger from an alien world. Borisov. On August 30th, 2019, Gennady Borisov, a Russian engineer and amateur astronomer, was looking into the twilight of the night over Crimea. While doing so, he noticed a moving object that resembled a comet, but was moving in a very unusual way. The direction of motion was opposite to the usual trajectory of comets from the main asteroid belt. Borisov's curiosity was aroused, and a little later scientists were faced with the second sensation. Comet Borisov had also clearly come from outside the solar system. Thus, Borisov was the second object which had penetrated from outside into our solar system. However, the Borisov object made it much easier for scientists than Oumuamua. The flying lump of rock was quickly and reliably identified as a comet. Comets, unlike asteroids, are composed of organic matter and often polluted water ice. They release dust and fine ice particles into the environment, forming the comet's distinctive tails. Nevertheless, Borisov remains a source of fascination. This comet had come to us from an alien solar system, or after a long journey through the infinite reaches of the cosmos. It could be the relic of an ancient star-forming region, come from a star system millions of light years away, or be a messenger from a neighboring world. We don't know at this time, but because Borisov is made of organic materials, it could give us clues about water elsewhere in space, or it could even piggyback on bacteria or microbes from another world. Borisov's orbit is currently being monitored, and who knows, maybe in the coming years, there will be a probe that flies to the comet to study it more closely, much like Rosetta Philae, the ESA probe that landed on comet Chury-Gerasimenko in 2004. One thing is already clear at this point: Borisov poses no danger to us. However, the situation is completely different with the object that was discovered in Hawaii. The mystery of Oumuamua. The orbit calculation had quickly revealed to the scientists that the object with the name Oumuamua originates from Vega, an alien star 147 trillion miles away. Initial measurements of Oumuamua had yielded confusing data. At times, it was shaped like a cigar, and at other times, it appeared disc-shaped. At its longest diameter, the object measured about 1,000 meters. That's not very large for a comet or an asteroid, but would be enough to really cause trouble in an impact. Oumuamua could destroy a major city. In particular, the speed makes this object a mystery and a threat, as Oumuamua races through space at an incredible 95,000 kilometers per second, much faster than any known comet or asteroid. Next, the object's unusual flight behavior set astronomers on edge. When it had already passed our sun, it made a sharp turn and accelerated in a completely different direction. It almost seemed as if Oumuamua had a will of its own, or as if the object was being steered in some mysterious way. Asteroids or comets move along fixed lines that have to do with the gravitational pull of the planets, the sun, and their interactions with each other. Therefore, the orbit's velocities and collision probabilities can be predicted very well and safely by scientists. An object that is hurtling, and moreover, hooks in ways that are unpredictable, poses a danger that is difficult to assess. Harvard astronomer Avi Loeb was the first to suggest that it might be an artificial structure created by an intelligent extraterrestrial civilization. Before Loeb, hardly anyone had the courage to say what everyone thought, for the rules of physics could not explain Oumuamua. In fact, an artificial origin would best explain the object's many peculiar properties. Oumuamua approached Earth once again and has been moving away from the solar system again since late October 2017, and has been heading toward the Pegasus constellation ever since. All attempts to close in on Oumuamua and unlock its mysteries have strangely failed. Surveys yielded confusing data, and attempts to figure out the object's composition also yielded data that didn't quite fit the picture. The object itself emitted no light and reflected almost no sunlight. According to this, Oumuamua would have to be made of a type of rock that absorbs light almost completely. But color scans showed that Oumuamua must be dark red to brownish. This is true only for some objects in the Kuiper Belt. But those are colored reddish by dust, and Oumuamua did not give off a speck of dust. The surface appeared rough and yet almost artificially polished. Scans had also revealed that Oumuamua's interior must be made of unknown compositions of metal. A new study suggests that it could be an alien spacecraft with a light sail. But what could extraterrestrials want with us? And that too, when they are more than 300,000 light-years flight time away from us. The Vega System. Vega is a very bright star, which is only 25 light-years away from Earth. Alternating with some other stars every few thousand years, Vega becomes our northern star, or in other words, the star which appears most northern in the firmament. For this reason, we call this star the past and future of the North Star. These shifts occur because the Earth's axis wobbles over a period of 26,000 years, so our perception of north gradually shifts to different stars. Vega was the North Star many millennia ago, and it will resume that position in about 12,000 years. In early 2013, astronomers discovered an asteroid belt surrounding Vega, suggesting the presence of exoplanets in the Vega system. Studies of the system show that there are two regions around Vega from which Oumuamua could have originated if it is a natural object. An outer region contains icy asteroids and comets, and an inner asteroid ring contains warmer space rocks. However, if the theory that Oumuamua is an object that did not form naturally is correct, we must ask, then what is it? A probe? There would be a theoretical possibility, but all attempts to contact the object failed. A probe would have to emit, according to our understanding, some kind of signal or electronic radiation, but neither was the case. We don't know whether we're possibly dealing with a technology, since we don't currently know how probes of other civilizations might function. In this case, the question would further arise whether Oumuamua could have been sent with a malicious intent. We certainly cannot rule it out completely. However, calculations have shown that Oumuamua was on its way to us for about 300,000 years. If an extraterrestrial nation had sent the probe to explicitly spy on our solar system, these species would either be very long-lived, or the endeavor would make little sense. Of course, it's also conceivable that Oumuamua was and is a probe, or other technical device similar to our Voyager probes. After its actual mission goal, the probe flew on and on. Just as Voyager 1 and 2 will reach first neighboring star systems in many thousands of years, Oumuamua has just appeared with us now. Whether or whenever aliens will catch sight of our probes, they will find a golden disk inside each of the Voyagers, which gives information about what the probes are and who sent them. Maybe Oumuamua had something like that on board, only we didn't find it because we weren't able to capture and examine the object. Oumuamua was the first visitor from an alien world, and now it slowly disappears again from the solar system. At its current position far behind Neptune, it's no longer visible to our telescopes. Will we now never know what Oumuamua really is? Or will the object possibly return? Join us now as we share the latest findings surrounding this event of the century. The mystery of Oumuamua. It doesn't happen every day. In 2017, the Pan-STARRS Space Telescope in Hawaii sighted an object that no one had ever seen before. Oumuamua was initially thought to be an asteroid that narrowly missed Earth. Then, it quickly became clear that this object had come to us from interstellar space, making it the first craft of its kind. For 11 days, the alien kept the world of science on tenterhooks. Then, Oumuamua moved away at breakneck speed, without researchers really managing to unravel its mystery. Now, Oumuamua is gone. It has passed beyond Neptune's orbit and is so far away that no telescope will ever be able to study it again. Oumuamua emits no light at all and also reflects light very poorly, making the object hard to spot at this distance. Because of its small size of just under 1,000 meters, its strange shape, and its furious speed, even our best telescopes cannot detect the stranger so far out in space. The last investigations had shown that the new orbit will carry the strangest celestial body of all time, directly in the direction of the constellation Pegasus, or Oumuamua will hit a snag and come back again. Such an unusual, and for an ordinary asteroid or comet, completely impossible maneuver, Oumuamua had already shown once, shortly after it had passed the Sun. Oumuamua first braked, then turned in a sharp angle, accelerated, and came back towards us. This strange behavior cannot be explained until today. The origin of the object and its true nature remain a scientific question around which a fierce dispute has broken out. Is Oumuamua a fragment of a celestial body, such as a planet or a moon, that was hurled towards us from a distant star system? Or is it a piece of alien technology that was sent to our solar system, either accidentally or intentionally? Scientists found plausible explanations for both theories, and we'll look at them now. Not an asteroid and not a comet? Oumuamua's unusual nature makes it impossible to classify the object unambiguously as a comet, an asteroid, or anything artificial. However, it would be important to know what this piece was. Among other things, 6 new objects that allegedly have similarities with Oumuamua should provide information. Among the most extraordinary capabilities of the unknown is undoubtedly its unusual ability to accelerate. Asteroids and comets accelerate through chemical processes or the interaction of gravitational forces in space. The acceleration rates can be explained and understood with the formulas of physics, but not so with Oumuamua. Information about the true nature of Oumuamua could be provided by a completely new category of celestial bodies called dark comets. Facts about Oumuamua. For all of you who don't know Oumuamua yet, we now share the most important facts again. Oumuamua was initially named A/2017 U1 or C/2017 U1 Pan-STARRS. The object was discovered on October 19, 2017 by the Haleakala Observatory in Hawaii. The Pan-STARRS project uses the telescope to protect Earth from asteroids. After it was clear that the object came to us from interstellar space, it was then given the name 1/Oumuamua. The 1 and / combinations stand for the first recognized interstellar object to enter our solar system, and Oumuamua means first scout from an alien world. The size between 100 and 1,000 meters fit first to an asteroid. The form, however, not so much. Sometimes it appeared as an elongated cigar, then more like a flat disc. Its trajectory and speed made it clear that this object was different from anything that had come before. Probably in truth, Oumuamua is not the first interstellar object to speed through our solar system, as there are potentially billions of possible objects that also did the same thing. It's just that we humans didn't notice these objects in the past, or we simply did not have the technology necessary to do so. Even normal asteroids are extremely difficult to spot, as they do not emit any light themselves, and depending on the material, can absorb all the light that hits them. Comets, on the other hand, are usually brightly glowing objects that can often be seen with the naked eye from Earth when they are in a near-Earth orbit. When Oumuamua was discovered, it had already sped past Earth and was about level with the Sun. Then, Oumuamua suddenly accelerated by about 17 meters per second. This seems small, but this kind of acceleration violates all known laws of physics. In any case, it was enough to cause a stir in the world of science. In physics, objects can only accelerate and change their trajectory as drastically as Oumuamua did when pushed. And so, scientists began to seek explanations for the pushing force. Some initial hypotheses that solar winds pushed the object were quickly discarded. The force exerted by solar particles is not enough to explain Oumuamua's acceleration, assuming it was some kind of rock. Even the best photos of Oumuamua showed only a tiny speck, giving little indication of what the object is really made of, or what it looks like. Most theories about its shape came from the variations in its light curve, whose brightness rose and fell uniformly as Oumuamua traveled around the Sun. The results were absolutely not in favor of a round object, but rather showed alternating evidence for an irregularly shaped object, such as a disc or a cigar. Dispute about Oumuamua. Scientists searched strenuously for comparable examples of accelerating objects in our solar system and came up with comets. As comets approach the Sun, the ice within them heats up, sublimates, turns to gas, and sputters out of the comet's main body. This ejection of gas and dust forms the comet's characteristic tail and gives the comet a small thrust, acting like a small thruster on the side closest to the Sun. Comets are thus accelerated away from the heat source. Around Oumuamua, however, no evaporation such as ice, dust, and gas could be seen. These evaporations would have also made Oumuamua more visible. The absence of this similarity to known objects led to more exotic theories. The first theory came from Harvard professor Avi Loeb. Loeb was the first to proclaim Oumuamua could represent extraterrestrial technology. He argued in 2018 that solar winds could provide the acceleration observed at Oumuamua, but only if it was actually much thinner than scientists originally assumed. By thin, Loeb suggests somewhere between 0.3 and 0.9 millimeters thin. Since a 1,000 meter long, 1 millimeter thin object is unlikely in nature, Loeb argued that it must be artificial, a light cell created to capture solar winds and use them to accelerate from one star to another. This theory met resistance from other members of the academic community. Daryl Seligman, a theorist and postdoctoral researcher at Cornell University, countered in 2020 with a study that found that perhaps no outgassing of Oumuamua was detected because it was emitting an invisible gas like hydrogen. This would not have been detectable with telescopes pointed at Oumuamua. Seligman suggested that Oumuamua was composed entirely or mostly of such hydrogen, a hydrogen iceberg that sublimated thanks to the Sun's heat, and this sublimation produced the thrust. Loeb and Seligman got into an argument. A few months later, Loeb published another paper challenging the other theory and asking where exactly this hydrogen iceberg could have come from. He showed mathematically that starlight in interstellar space is warm enough to melt any hydrogen iceberg that would have formed in the nearest dense molecular clouds before it came anywhere near our solar system. Loeb was still convinced that an extraterrestrial technology explanation was most likely. Seligman revised his hydrogen iceberg theory, but maintained that Oumuamua had been moved by escaping pure hydrogen gas. Seligman eventually found support from Jennifer Bergner. In 2023, the assistant professor at the University of California found evidence in the laboratory that his hydrogen thrust theory was correct. The two wrote a paper arguing that Oumuamua was a whole new category of celestial object, a quote-unquote dark comet. Their new explanation took into account Oumuamua's acceleration and also its lack of dust, since dark comets need not emit dust. These objects create their propulsion by reconfiguring hydrogen structures inside. Avi Loeb was not convinced and wrote 2 new papers on the subject himself, accusing Seligman of bad mathematics and continuing to push his extraterrestrial spaceship model. Seligman was then already busy searching for proof of his theories and looking for clues to other dark comets. Together with Bergner and some other comrades in arms, he combed through data of objects that had already been registered in our solar system but could not be explained. 6 dark comets. In fact, the research team found 6 objects that fit the criteria. 6 objects that showed non-gravitational, non-solar wind acceleration that could not be explained by any known mechanism. These objects were small, some measured as little as 3 meters. They looked like asteroids, were near-Earth objects, and showed no special features except for the strange acceleration. Until now, these accelerations had not been noticed because the rates were very small due to the small size of the objects, and the strange behavior was not noticed at all. It wasn't until Seligman and his colleague specifically looked for these rates that the candidates stood out. These objects do not flit from planet to planet through the solar system like Oumuamua. They are also not interstellar objects, but they resemble Oumuamua and could allow conclusions about its true nature. In 2031, a Japanese probe is expected to study these strange near-Earth objects and even collect some of them and bring them to Earth to study. Perhaps then, Seligman can look forward to a late triumph, but for that long, he will be no more able to prove his theory than Loeb. With Oumuamua now far beyond our reach, we may never know. All attempts to quickly construct a probe that could still catch up with Oumuamua failed. Of course, it could end up that neither theory is correct. The longer and deeper we explore the universe, the more we encounter strange and unexpected phenomena, and the more we will learn. Maybe one day more objects like Oumuamua will appear in our solar system, and we will find a conclusive explanation for the phenomenon. From the 1960s to the 1980s, the Soviet Union landed on Venus with some technically excellent probes. No nation has studied this enigmatic planet as well as the former Soviet Union, and it can be assumed that nobody knows so well about the planet until today. Neil deGrasse Tyson, a renowned astrophysicist and science communicator, has recently worriedly pointed out that the Soviet Union may have withheld explosive information about Venus, and a study by a Russian researcher shocked with statements about finding aliens on Venus. But what is this all about? Did the Soviets really withhold scientific information on a grand scale? And did they really know of the existence of aliens on Venus? Stay tuned as we explore these explosive questions now. Neil deGrasse Tyson warns. Neil deGrasse Tyson is one of the best-known astrophysicists in the United States and a major science communicator. Recently, he has pointed out the importance of the Soviet missions to Venus, and for a very specific reason. Many of the accomplishments that the Soviet Union achieved in space exploration were proudly shared with the public at the time. The contributions to Venus research are still considered revolutionary today, and arguably no other nation has contributed as much to our understanding of Venus as Russia. However, it is actually obvious that the former Soviet Union was far from sharing all the information with Western scientists during the Cold War. Some of the achievements may also have been less well known and may be of renewed interest today. Others may have been overlooked or deliberately suppressed. Tyson cautioned in careful terms not to forget anything about the Soviets' Venus research when it comes to planning new missions to our neighboring planet. Shockingly, a new study from Russia proves just that. Allegedly, video footage from the Venera 13 probe even shows aliens. NASA wants to return to Venus. After a recent discovery of possible life on the planet, NASA has renewed a focus on exploring Venus. Before that, it had long been quiet about our inhospitable neighboring planet. After the biomarker phosphine was detected in Venus's atmosphere, NASA set up a new research program. Similar to Mars, computer simulations showed that Venus may have had a period in its evolution when it had a mild climate, possibly water, and even simple forms of life. Just as with Mars, changes then occurred that swept away this life and made Venus one of the most uncomfortable places in the solar system. Our home planet may also be facing changes that will make life increasingly difficult. Learning more about the processes that have caused desolation on Mars and Venus could tell us much more about our own fate, and we may even be able to avert it. Da Vinci Plus, the Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging Plus mission, is designed to penetrate Venus's atmosphere, which is 90 times denser than that of Earth. The samples and data collected will help scientists determine how Venus has evolved, whether it has ever had oceans, and whether traces of microbes can be found in the atmosphere. Da Vinci Plus is accompanied by Veritas, or more specifically, the Venus Emissivity, Radioscience, INSAR, Topography, and Spectroscopy mission. The mission will produce a detailed map of the planet's surface and attempt to reconstruct the geologic history of Venus. Each of NASA's 2 new Venus missions has been given a budget of $500 million. These missions will study the planet's atmosphere and geological features. The decision to again send missions to Venus marks a significant change in strategy for NASA, which has focused primarily on Mars in recent decades. According to NASA Solar System Exploration, more than 40 spacecraft have visited Venus to date. NASA's last mission to Venus was the Magellan mission, which was launched in 1990 and spent 4 years collecting data, resulting in the first mapping of the planet's surface. At the present moment, only one spacecraft is in orbit around the planet. Akatsuki from Japan is an orbiter that has been taking measurements around Venus since 2010. So far, this orbiter has not found any traces of life. However, the probe has also launched with some mishaps and has never reached the position originally intended for the mission. It also launched before the phosphine findings became known. Venus in the 1960s. In the 1960s, Venus was an enigmatic and challenging planet in NASA's eyes. Their records referred to it as a hell planet. Conditions on this planet are truly extreme and hostile to life. With temperatures high enough to melt lead and a dense, toxic atmosphere, Venus has always been a difficult target for space exploration. While NASA viewed Venus as challenging and mysterious, Venus became the Soviet Union's favored target. NASA, on the other hand, focused first on the Moon and then on Mars. The red planet, with its Earth-like topography and evidence of flowing water in the past, was considered the most likely place for extraterrestrial life in the solar system. By the 1960s, the space exploration race was in full swing, and both superpowers, the United States and the Soviet Union, were determined to be the first to reach and explore alien planets. For the US, the decision to set Mars as the primary target was not only scientifically motivated, it was also a symbol of the Cold War, in which the US and the Soviet Union were in a race for technological superiority and geopolitical dominance. As the red planet, Mars was somehow also a sign of communist systems and for socialism. If NASA were the first to land a probe there, it would have symbolically captured the planet of the Eastern Bloc. While the US targeted Mars, the Soviet Union chose to focus its resources on Venus, creating an interesting contrast in the two nations' space goals. The Soviets accepted the challenge. Initially then, the Soviet Union was not at all entirely voluntarily determined to send missions to Venus. Nevertheless, the nation's engineers and scientists accepted the challenge, and they were to meet it so brilliantly that to this day, the US can only tip its hat to the ingenuity, the technological advances, and ultimately the successes. Venus offered the Soviet Union the opportunity to demonstrate technological superiority, and it did just that. It was not until much later that wild speculation arose about the true Soviet intentions. Allegedly, the Soviet Union was obsessed with Venus. and intended to use its surface as a military base or to colonize the planet. Officially, the Soviet Union only sent some of the most successful probes ever to Venus. Of the nearly 30 missions, many went wrong. Probes landed in the wrong places, cameras didn't work, and other mishaps occurred. But the Soviet Union was tough, didn't let itself be put off by any failure, and continued on its course. Almost annually, probes were launched to Venus, sometimes even 2 per year, and with each launch, the probes became more successful. The Venera missions lasted from 1961 to 1983. The Soviets launched a total of 28 spacecraft to explore the planet, with 13 entering Venus's atmosphere and 8 landing successfully. Launching on February 12, 1961, Venera 1 was the first mission to attempt to fly past Venus. Unfortunately, the probe's telemetry failed 7 days after launch. It's believed that it approached Venus to within 100,000 kilometers and then simply flew past. Venera 3 became famous in 1966 as the first man-made object to impact another planet. Although it landed on Venus on March 1, 1966, no data could be sampled from Venus's atmosphere due to a failure of the measuring instruments. On October 18, 1967, Venera 4 made up for it and became the first spacecraft to measure the atmosphere of another planet. It revealed that the main gas in Venus's atmosphere is CO2. Venera 5 and 6 were specifically designed as atmospheric probes. In 1969, they each collected 53 and 51 minutes of data, respectively, while slowly descending through the atmosphere with a parachute. Venera 9 had June 8, 1975 to thank for the first images of the surface of another planet. The first sound recordings on another planet were provided by Venera 13 in 1981. And not only that, among the mission's accomplishments to this day are the best and most beautiful images of the surface of Venus. Around the Venera 13 mission, speculations arose again in the last years. Dr. Leonid Sanfilmalaity, a renowned researcher of the Space Research Institute of the Russian Academy of Sciences, has identified several objects resembling living beings on never-published images of this mission. His research and discoveries regarding Venus and the Venera missions have once again caused quite a stir in the scientific community. The researcher described 3 main objects that could not be explained. One was a disc-shaped entity that seemed to respond to changes in temperature or pressure. The second object resembled a black lobe that was visible for the first 13 minutes of the mission. Closer inspection revealed it to be a vertically elongated black object with an unknown appearance. Surprisingly, the black object disappeared from the images taken in the 27th and 36th minutes of Venera 13's landing approach. The most intriguing discovery was an alien scorpion sighted in the 90th minute of the mission. The origin of the scorpion is unknown, possibly extraterrestrial or astrobiological in nature. Secrets of the Soviet Union. The dissolution of the Soviet Union in 1991 affected far more than just the country itself. This change led to a profound geopolitical transformation, but it also left a legacy of mystery and speculation. The Soviet Union was known for its secrecy and advanced intelligence operations. This very culture of secrecy also has led to numerous theories and speculations surrounding secret findings of space travel. It has been repeatedly claimed that the Soviet Union may have possessed information about contacts with extraterrestrials, and the new studies on the forgotten data from the Venera 13 mission seem to support such thoughts. There were also always rumors that there was a secret airbase in the Soviet Union where extraterrestrials landed, similar to Area 51 in the USA, but there is still no concrete evidence for this. Dark matter is one of the most mysterious phenomena in the universe. Scientists assume that it's one of the fundamental building blocks of the universe, but it's neither visible nor measurable. Now it turns out that dark matter is not just a filler of the universe and is involved in the formation of black holes. Dark matter may have formed fascinating stars in the early days of the universe that shone brighter than any stars known today. Come with us on this journey to the threshold of the universe and to what may be an entirely new kind of star. What was in the beginning? The James Webb Space Telescope is designed to illuminate the mysterious early era of the universe. At the very beginning of the telescope's operational life, we were in for a surprise. An image taken deep into space revealed very old galaxies that were far brighter and more regular than they should have been at that early date. Since then, scientists have puzzled over the true nature of this phenomenon. In order to know how stars and the first celestial bodies such as planets or even gas clouds and rocks in the cosmos really evolved, we would have to find the oldest representatives. With the James Webb Telescope, this is theoretically possible, but only if the cosmos is really 13.8 billion years old as assumed so far. If the universe is possibly much older, also James Webb would have to pass, because the mirrors of the super telescope can catch only light, which was on the way to us about 13.5 billion years. During this first epoch of the universe, there should not have been much older light than that, according to the previous opinions of scientists. Only when the first stars from fast-rotating gas and dust disks developed, it became light. Researchers would like to find only too gladly some of these very old and first stars. A completely new type of star? Right now, it looks like researchers may have found a type of star they never thought possible. Einstein was able to predict the existence of black holes because the probability of the existence of such objects was apparent in his equations for relativity in the cosmos. It was not until about 40 years later that these mysterious objects were actually discovered in space. Currently, researchers believe a type of star is possible that no human has ever calculated or predicted. A star powered by dark matter that shines as brightly as an entire galaxy. So, of course, we can wonder how scientists are now coming up with this idea. In fact, the mysterious existence of the giant galaxies during the cosmic dawn could also be explained by the fact that these light spots are not galaxies at all, but single, extremely brightly shining superstars. The oldest light of the universe? In April 2023, an article appeared in Nature Astronomy, which describes 4 highly interesting objects in more detail. More precisely, they are galaxy candidates named JADES-GS-C10-0 to JADES-GS-Z13-0. They are galaxy candidates because researchers assume they are galaxies, but they can't be completely sure at that distance. At first sight, these galaxies don't look very impressive, but here you can see some of the oldest objects ever seen in the universe. The Z value at the end of the name indicates how far away the galaxy is from us. Z10 is closer than Z12, and Z13 is the most distant and therefore probably the oldest light source. They were discovered as part of the JWST Advanced Deep Extragalactic Survey, or JADES for short. JADES has set itself to the task of studying the very first galaxies that formed in our universe. This is now possible for the very first time in human history because the JWST works with a completely new infrared technique, which makes it possible for the first time to study old and distant objects in detail. To determine age and distance, researchers measure the value of the red light shift. As light travels through expanding space, it expands. The spectrum shifts into the red region. The detailed analyses of red light that are now possible thanks to James Webb allow scientists to make more accurate statements than ever before. Dark stars on the cusp of time? If we look at these objects, we are looking at the cosmos as it looked about 400 million years after the Big Bang. Based on the brightness of these spots, it appears that these objects must be entire galaxies. However, measurements of the light frequencies have shown partly contradictory results. The values of mass and luminosity did not fit well into the picture. Just as improbable, it was according to previous theories that in this epoch of the universe, finished galaxies already existed. The problem of the almost impossible early galaxies had caused a lot of stir in the summer of 2022, and some scientists are convinced that these objects have what it takes to disprove the Big Bang theory. Other scientists take a more cautious view of the discovery. They believe that it's not possible to say for sure at a distance whether these are really galaxies. They could also be luminous accretion disks formed around supermassive black holes, or the images show an unknown form of early star. Furthermore, critics of galaxy theory argue that these images show objects from a time when the cosmos may have functioned very differently than it does today. We do not know which processes exactly led to the fact that from the dark cosmos a shining one began. This is where the exciting new theory of dark stars comes in. A star is normally born from a cloud of dust and gas when gravity overcomes the pressure exerted by the matter in that cloud. In an ordinary star like our Sun, the necessary pressure is caused by the nuclear fuel that balances gravity and inflates the star. But a dark star would be so massive that even the nuclear fire would not be enough to balance the gravity. Instead, the dark star is driven by something much more exotic: dark matter. Now, this theory has a small catch, because researchers still don't know exactly what dark matter actually is. To explain the dark giant star theory, researchers introduced a theoretical particle, the WIMP. WIMPs could be a kind of heavy and only weakly interacting particle, which collide in the center of an extremely massive star, there to compress each other so strongly that a huge amount of energy is released. Purely mathematically, this process would explain why a dark star is not compressed by its gravity. Nevertheless, a dark star would probably be very unstable and could only exist for a short time before exploding or collapsing. Further calculations have shown that such a dark matter star would not be truly dark. Rather, it could shine as brightly as an entire galaxy during its short lifespan. So, are we seeing such mysterious dark stars here, representing an entirely new category of stars? Or are they just darn old galaxies after all, calling the Big Bang Theory into question? Scientists are currently struggling to come to terms with the JWST discoveries, and the uncertainties are driving the scientific community to ever new speculations and theories. What is really true, only the future and possibly an even better telescope than James Webb will show. Sense and nonsense of the research. In view of the new discoveries and the controversy that has now broken out in the academic world, the question arises once again: why it's actually so important to find out what happened in the early hours of the cosmos. Some people consider this research, and especially the sums invested in it, to be as excessive as the quarrels and disagreements of natural science. But if we look more closely, there is much more behind this research than being right or a contest among scientific disciplines. Physics seeks to understand the fundamental laws that govern our reality. Some of these laws are known to us, but we probably don't know all of them, because scientists still can't describe the entire universe and its formation 100% scientifically. The universe as we know it today is probably the result of billions of years of cosmological evolution. By studying its beginnings, we can understand the first moments after the Big Bang, which in turn helps us understand the forces and mechanisms that have shaped our current cosmological situation. Through this knowledge, we may one day begin to dominate matter. That this is not so improbable is shown by the studies of the Russian cosmologist Nikolai Kardashev. He had created a scale according to which intelligent species can develop so far that they dominate the universe. Super civilizations can create, form, and change matter. Natural science is a basic condition to arrive at realizations like these. In the vastness of the cosmos can be found answers to the urgent questions of the energy problem and space travel. This could be the case for medicine as well, and each and every one of us could benefit enormously if scientists unravel the mystery of matter. The discovery of new sources of energy or forces of nature could change everything in this world, just as scientific discoveries of the past have led people out of the Dark Ages. So, there is much more behind research than curiosity and scientific vanity. If we want to evolve, we need to know more about the universe and its true nature. In addition, this research also has an important philosophical and spiritual meaning. The question about the origin of the universe is closely connected with the question about our own origin and the meaning of our existence in this world. Even if at the moment quite chaos has broken out in cosmology, the scientists will overcome this uncertain time. Further findings will create new knowledge, and one day, we may have settled the question around the meaning of the universe. James Webb will accompany us for the next 20 years, and the sensations in which we were allowed to participate so far are only the beginning. So, we can already be curious here and now, which new fascinating discoveries James Webb will deliver and which theories will prove true in the end. Jupiter, the giant of the solar system, has been known to man since ancient times. As a brightly shining point, It traces its orbits across the night sky. For a long time, researchers thought they had found out everything about this planet. But then Jupiter surprises again and again with even more violent storms, an ocean of metals, and a hostile behavior that could be our undoing. Come along on this journey to the largest and most dangerous planet in the solar system. Jupiter, mystery of gas and dust. Even in ancient times, Jupiter was a figure of contention. As Lord of Olympus, he was the father of the gods in Roman mythology. Sometimes benevolent and wise, sometimes devious and angry, the chief of all gods stepped into the ring. It almost seems as if the astronomers of antiquity had a secret idea about the true nature of this celestial body. In ancient times, astronomers knew nothing about planets. They saw in Jupiter and the other planets visible to the naked eye an unusual star. Only in the present day does the planet's uncanny resemblance to the capricious father of the gods reveal itself. Jupiter has long been considered a benefactor, a cozy large planet whose gravity binds the solar system's numerous asteroids and comets in a stable belt between it and Mars. Thanks to the main asteroid belt, we are reasonably safe from the projectiles from space. At least that's what researchers thought for a long time. That this was a mistake, we will show you shortly. Jupiter is by far the largest planet in the solar system. If we were to put all the other planets on the scale together, Jupiter would still be quite a bit heavier. Some researchers are convinced that Jupiter almost became a star. Only a little more was missing. Then Jupiter would have initiated fusion processes by its gravity, as they take place on our sun. Instead of a giant planet in the neighborhood, we would then have a second star. As the oldest planet in the solar system, it formed from the amount of gas and dust that did not become part of the sun. Today, the star giant is composed mainly of gases such as hydrogen, helium, and dust. An ocean of metal. Hydrogen makes up about 90% of the planet's composition. In the outer layers of this gas giant, hydrogen is a colorless and transparent gas, just like on Earth. In the deeper layers, the atmospheric pressure increases immensely, and the hydrogen condenses to a bizarre liquid, which resembles liquid metal. This ocean of metallic hydrogen makes up about 10% of the inner areas of the planet. Liquid metallic hydrogen has properties similar to water, excellent electrical conductivity, and heat conduction. This bizarre substance turns Jupiter into a giant generator. On Earth, hydrogen can be artificially compressed in the laboratory to such an extent that it becomes a solid. However, hydrogen does not become metallic with us as a result and conducts heat and electricity poorly. Deep in Jupiter's layers, hydrogen is exposed to such extreme temperatures and pressures that it becomes liquid and metallic. This fact fascinates planetary scientists, and they would love to know firsthand what is going on inside the planet. The data that are available come from scans by the Juno space probe. It can penetrate deep into Jupiter's layers with its measuring instruments and measure detailed information about gases, elements, and temperatures. Scientists will probably never visit the ocean of liquid metallic hydrogen directly. Even if we eventually mastered space travel, we would have to stay away from the planets like Jupiter. The extreme gravity would magically attract a spacecraft at a certain threshold and then tear it apart inside the planet. Because of the large amounts of liquid metal at a depth of about 40,000 kilometers and its rapid rotation, Jupiter generates a colossal magnetic field that extends over an astonishing distance of 725 million kilometers. This magnetic field is the largest in our solar system and holds secrets of its own. Jupiter's magnetic field is 20,000 times stronger than Earth's and extends all the way to Jupiter's neighbor Saturn. The massive magnetic field is responsible for spectacular auroras at the poles of the gas giant and creates a mystery known as the Great Blue Spot. The fairly recently discovered magnetic anomaly near the gas giant's equator is not a storm, like the much better known and larger red spot, but a region with a particularly intense magnetic field. Unlike Earth's dipolar magnetic field, which consists of a north and south pole, Jupiter's magnetic field has a much more complex structure. The Great Blue Spot could be considered a kind of second magnetic south pole near the equator. The intensity of the magnetic field in this region varies by up to 1% annually, strengthening and weakening in different areas. Although the nature of the Great Blue Spot is completely different from that of the Great Red Spot, the two phenomena may have a complex connection in the overall structure of the planet because they lie at similar latitudes. At the moment, the Great Blue Spot is still the subject of current scientific investigation. The Great Cold Spot. The gas giant Jupiter also has other spots. Scientists refer to a spot that extends about 12,000 by 24,000 kilometers as the Great Cold Spot. The cold spot is not a storm, nor is it directly related to the magnetic field. This fascinating atmospheric feature is a region of much colder temperatures compared to its surroundings. Colder in this case means a difference of about 200 degrees Celsius. In the upper layers, Jupiter's temperature is about negative 145 degrees Celsius. Deeper, the pressure increases so massively that temperatures also probably rise to 20,000 degrees Celsius or even higher. The Great Cold Spot on Jupiter is located in the planet's thermosphere, where temperatures are usually around 800 degrees Celsius. Around the spot, temperatures plummet to about 600 degrees. The Great Cold Spot is unstable and appears only intermittently. Since it's always accompanied by the appearance of auroras, there is probably a connection. Jupiter's auroras are formed similarly to ours on Earth when charged particles from the solar winds interact with the magnetic field and atmosphere of the planet pole. On Jupiter, the auroras are more stable and intense because they are enhanced by particles originating from the planet's moons. New evidence shows that the intense auroras transfer energy to Jupiter's atmosphere and create a temperature difference between the upper and lower regions. This temperature difference leads to the formation of the swirling vortex known as the cold spot. Water on Jupiter. Water vapor was first detected on Jupiter in 1995 by the Galileo spacecraft. The near-infrared mapping spectrometer aboard Galileo recorded the fine water vapor in the planet's atmosphere during their close flyby. Recent data show that water makes up about 0.25% of Jupiter's atmosphere directly above the equator. While that may not seem like much, it's an immense amount of water when measured against the planet's massive size. In recent years, a team of researchers used telescope data to discover an even greater amount of water in Jupiter's famous Great Red Spot. The Juno spacecraft, launched in 2012, confirmed the water findings in the gas giant's clouds. The water creates flashes that are hundreds of times brighter than terrestrial ones. The process is much like ours on Earth. When water droplets and ice crystals collide in clouds, they create electrical charges. When these charges become strong enough, lightning is produced. In the past, researchers discovered lightning in Jupiter's atmosphere, where water droplets collide with electrically charged ice particles. Juno then recorded more water discoveries in the higher atmospheric layers. There, where temperatures drop to about negative 87 degrees Celsius, it's actually much too cold for liquid water. Nevertheless, it flashes faintly there too. The answer to the puzzle lies in a small amount of ammonia in Jupiter's atmosphere, which serves as a natural antifreeze. In the upper atmosphere, water ice crystals combine with ammonia vapors and melt. These water-ammonia droplets then collide with more ice crystals from below, creating an electrical charge that discharges in lightning bolts. Under the ammonia ice clouds, the ammonia water droplets even grow so continuously that they become large hailstones. Jupiter and the asteroids. Reconstructions of the evolution of our solar system have shown that Jupiter's influence has been instrumental in stabilizing the orbits of many planets. Its gravity has bound numerous asteroids and comets, so that impacts in the inner solar system have decreased enormously over millions of years. In the past, astronomers have even suggested that this was one of the reasons life had a chance on Earth. But recent findings cast doubt on Jupiter's role as a terrestrial protector. Long-period comets, which originate in the distant regions of the solar system and take millennia to orbit the Sun, would also pass by us if Jupiter's gravitational influence did not hurl them out of the solar system even before they approach Earth. The chances of long-period comets colliding with our planet are therefore extremely rare, occurring over millions or even tens of millions of years. Jupiter's presence thus plays a crucial role in protecting Earth from these potential impacts. However, the gas giant's gravitational forces have both positive and negative effects. On the one hand, Its immense gravity prevents nearby space rocks from accumulating and forming into a planet. Instead, thousands of asteroids, smaller rocks, and comets fly secured in a broad band between Mars and Jupiter. Not so long ago, however, astronomers discovered that at certain times, the gas giant's gravitational pull can also change so that it virtually pushes asteroids out of the belt and hurls them in our direction. Almost in such a way as Jupiter, the god of thunder and lightning, brought his bad mood or vengefulness over the people, then also the planet Jupiter behaves. The asteroids set in motion in this way do not necessarily have to collide with the Earth, but collisions with the Earth increase in probability. In 1770, Comet Lexell passed Earth by only about 1.5 million kilometers. On the astronomical scale, that's actually a short distance. Scientists believe that the comet originally came from the outermost reaches of the solar system and came close to the gas giant during its flight. It was deflected by its gravity and hurled directly towards Earth. After completing 2 orbits around the Sun, the comet returned to Jupiter's vicinity 9 years later, and this time was ejected from it out of the solar system. Jupiter's gravity could cause more problems in the future. It's probably its influence that is causing the smallest planet, Mercury, to move into an increasingly oblique orbit, and at some point, it will probably be pushed into the Sun by the tremendous force of the gas giant. So, Jupiter is both a curse and a blessing, or just the way it is. Planets certainly have no evil intentions in what they do. Do you find Jupiter threatening now, or is it simply a fascinating celestial body for you? On September 15, 2012, the ashes of the most famous astronaut of all time were released to the sea from the deck of the cruiser USS Philippine Sea. Burial in the Atlantic Ocean was a heartfelt wish of Neil Armstrong, the first man on the moon. Millions of U.S. citizens commemorated an incomparable national hero that day. After Armstrong's death, some rumors were confirmed that shock and touch us. What did we not know all these years about Armstrong's moon mission? And what did the astronauts involved at that time have to keep to themselves for life? Stay tuned as we investigate the shocking facts of the moon landing and uncover how one of America's most famous men really lived. Armstrong's family reveals. Nearly 11 years after the death of the man who became the very first person to set foot on a celestial body outside of Earth, his family is going public with another shocking revelation. The stories include details about the astronaut's dramatic end to life, which has been anything but heroic. Armstrong underwent heart surgery in the summer of 2012 that should have been routine. Nevertheless, the national hero died as a result of the procedure. The problem wasn't surgical error or an unexpected complication. A harrowing report reveals that a lack of care after the procedure led to a rapid deterioration in Neil Armstrong's condition. A nation is shocked after the connections came to light. Is this how a country like the USA and its healthcare system treats its heroes? Incidents occurred at Mercy Health Hospital in Cincinnati. After the dramatic circumstances of her husband's death became known, Armstrong's widow, Carol, tried to limit the damage. Armstrong's family had very well taken action against the hospital after the incident, and they had quietly agreed to pay about $6 million. The government is also said to have advised Armstrong's widow to accept the money and to keep quiet about the true circumstances of her husband's death. The explosive information came to the public through a secret informant. Even 11 years after the death of the man, who was quoted as saying, "One small step for man, one giant leap for mankind," became world famous. What was really in the box? Immediately after the passing of the beloved astronaut, another fact became known that captivated and touched the nation. Armstrong's widow, Carol, had told in an interview that she had found something unexpected in her husband's personal belongings after his death. It was a small box containing some odd and very old-looking items. Carol Armstrong soon recognized technical parts, as well as a camera from the 1960s. She figured these items were somehow related to the moon mission and turned the find over to NASA. Apparently Armstrong, who had retired from the public eye in a very modest way after the lunar landings and never flew into space again, had probably secured some mementos of the Apollo 11 mission. The pieces are likely worth at least 6 figures today. Carol Armstrong said that she had not known about the box for all those years. Her husband had never spoken about these keepsakes. Nevertheless, they seemed to have been very important to him, because he had kept them until the end of his life in a place where Armstrong kept his most personal things. NASA again used the find to celebrate Armstrong as a quiet hero who, despite his retirement from the limelight and from lunar missions, had a lifetime of pride in his achievement as the first man on the moon. NASA leaks the concealed details of the moon landing. Since its inception in the 1950s, NASA has been an organization that accomplishes great things, but also divides. Much like the US government and other agencies of the state, NASA has been repeatedly suspected of lying to and manipulating people on a grand scale. In the late 1980s, rumors surfaced that the entire moon landing was just a fake. Armstrong, Aldrin, and Collins had allegedly never flown to the moon, and the whole landing was staged in a Hollywood movie studio, just to get one over on the Russians, who were ahead in space travel at the time. These suspicions could not be proven until today, although there were allegedly dozens of witnesses who claimed to have been involved in the staging. A plausible explanation for these scenarios many years later was that NASA had a plan B in case the real moon landing should fail in a dramatic way. Had that been the case, NASA might have considered staging a fake to save face for the nation in the Cold War. Neil Armstrong, Buzz Aldrin, and Michael Collins were completely believable when they recounted their experiences on the moon. Like photographs, the film footage was examined several times by experts and found to be genuine. Likewise, the mystery of the waving flag on the moon could be solved. There is really no wind on the moon, but the frame on which the flag was stuck into the ground was moving, and this also caused the flag to vibrate in a way that resembled a breeze. Armstrong always called rumors like this nonsense, and the find of his small devotional box should be probably also a good proof that the man was really on the moon. Unless also this find was a later fake of NASA? What do you think? Let us know in the comments after you watch the video. More rumors about the moon landing. One circumstance of the moon landing that was concealed in 1969 and only became public much later was the almost botched landing on the moon. While third astronaut Michael Collins remained aboard the spacecraft, Armstrong and Aldrin descended two at a time in the Eagle landing capsule. Buzz Aldrin piloted the capsule and had to cope with some failures of important instruments and landing devices during the approach to the moon. To top it off, the radio link to Earth failed, and Armstrong and Aldrin seemed lost for a few minutes from the point of view of ground control in Houston. President Nixon had had a morning speech recorded, especially for this purpose, before the land of the Saturn V rocket. If something were to go wrong in front of millions of television viewers worldwide, the speech would have been ready immediately. But Armstrong and Aldrin had no intention of dying on the moon. Buzz Aldrin was, and still is to this day, an extremely experienced pilot and manually landed the Eagle on the moon. The incident landed the two astronauts several kilometers away from the actual planned landing site. The terrain in this area was rocky and characterized by cliffs with sharp edges. When contact was re-established with ground control, Armstrong and Aldrin were warned not to get too close to the rocks so as not to jeopardize the safety of their spacesuits. Moon rocks are extremely sharp. The television broadcast resumed when the astronauts were ready to leave Eagle, and again, one fact was long concealed. Actually, Armstrong and Aldrin should have taken a nap first, but the two were too excited to rest and began their lunar walk without resting. Even before Armstrong set his foot in the soft lunar dust, he addressed his famous radio message to mankind. Shortly thereafter, another important part is said to have been removed from the transmission of the moon landing. Allegedly, Armstrong and Aldrin sighted some spaceships at the edge of the crater. The radio message stating, "They're here, they're parked on the edge of the crater, they're watching us," is now almost as famous in some circles as that of a man's first small step on the moon. The secret radio message was leaked by a whistleblower. Although Buzz Aldrin and Neil Armstrong never literally said after the landing that they had seen extraterrestrials, Aldrin in particular is said to have confirmed the existence and sighting of UFOs on the moon throughout his life in private and by discreet hints. The forgotten third astronaut. Around the rumors of extraterrestrials on the moon, one man repeatedly comes into the sights of UFO lodges and science fiction enthusiasts. Michael Collins was the third astronaut of Apollo 11, who was gladly forgotten after the fame of Armstrong and Aldrin. Collins piloted the Apollo 11 command module and remained in lunar orbit while Armstrong and Aldrin were on the surface. It was during this time that Collins became a late spaceflight legend. At the time, hardly anyone was interested in the dark side of the moon, the part of the moon that we humans on Earth normally never get to see because the moon always faces the same side towards Earth due to a bound orbit. Today, wild rumors swirl about the far side of the moon, about alien bases, stranded spaceships, and other facilities posted on the moon by extraterrestrials. Collins was the first person to ever see the far side of the moon with his own eyes. Of course, he was questioned several times about what he saw there. Collins described the landscape as rugged and beautiful, his solitary trip around the moon as a profound, moving experience. Never before had a man been so far in space and all alone. More than 400,000 kilometers, Collins was away from Earth, his family, and everything familiar. If something had happened to Aldrin and Armstrong on the moon, Collins would have been all alone. He would have had no means of coming to the aid of his comrades, since the command module was not designed to land on the moon. But all went well and the three heroes returned to Earth unharmed. For a few months, there was a lot of hype about the three. Then the next Apollo mission started and Armstrong, Aldrin, and Collins retired from NASA. Evidence of aliens on the far side of the moon. Rumors surrounding alien ships on the far side emerged with the late Apollo missions. To this day, purported images circulate through the web showing a stranded spacecraft on the moon several hundred meters long. According to some unconfirmed rumors, Apollo astronauts are said to have recovered 2 female bodies from the spacecraft in a secret mission. Although the ship could have been there for millions of years, the 2 bodies are said to be remarkably well preserved, which could be due to the unusual climatic conditions of the moon. Lunar fans have since discovered several features on the far side of the moon that suggest entrances to underground facilities. Because the activity of extraterrestrial forces on the moon is said to have increased again in the early 1980s, the Apollo 18 and 19 missions were officially cancelled. However, there is no evidence for this. Neptune is about 30 times farther from the Sun than our Earth. As the last of the major planets, it orbits the Sun almost in complete darkness. Due to the lack of light, Neptune can only be seen from Earth with very good telescopes. The latest telescope now provided brand new views of this normally luminous blue planet. In this photo from the James Webb Telescope, Neptune shines almost as brightly as a star. But where did the glow suddenly come from, and what makes this planet so unique? Let's take a look at the latest discoveries and findings about the enigmatic ice giant, Neptune. You have never seen Neptune like this before. The James Webb Space Telescope outdid itself again in September 2022 by capturing a stunning image of Neptune and its rings. This image provides the clearest view of the rings of the distant planet that we have ever had. Indeed, the fine dust rings are not visible to the naked eye. They shimmered ever so slightly in an image taken by NASA's Voyager 2 spacecraft in 1989. But the quality of the image was barely enough to draw more accurate conclusions about the ring's composition and origin. The Webb telescope image clearly witnesses even the fainter dust rings of Neptune. This image was made possible by the near-infrared camera, or NIRCam for short, which can image objects in the near-infrared range from 0.6 to 5 microns. Due to light filtering, Neptune does not appear blue to the Webb telescope, but shines brilliantly. The image continues to show 7 of Neptune's 14 known moons. Triton, Neptune's large and unusual moon, dominates this image as a very bright point of light. Triton reflects an average of 70% of the sunlight that hits it, far outshining Neptune. This image is fascinating not only because of its unusual angle of view and its impressive composition. Scientists have gained completely new insights into the dynamics and composition of the planet and its moons. Almost at the edge of our solar system. Up to Neptune, the official major planets of the system are Mercury, Venus, the Earth, Mars, Jupiter, Saturn, and finally Uranus and Neptune. Until 2006, we had another planet, Pluto. But since the discovery of more Pluto-like objects in the fringes of the solar system, these mini-planets have been demoted to so-called trans-Neptunian objects. The size jump from Neptune to Pluto is indeed huge. Pluto is not even half the size of its neighbor. Because of its remoteness, Neptune is the least studied planet in the entire solar system. For a long time, researchers also thought that Neptune was not particularly exciting because hardly any life was suspected in this darkness, and the ice planet was considered barren and desolate. But this was a mistake. According to the newest realizations, one of the coldest planets in the system could support an ocean of hot water, and in this, even life forms would be conceivable. Neptune is an ice giant, about 4 times the size of Earth. It has a radius of about 15,300 miles and a volume of 15 trillion cubic miles, giving it a bottom-line volume 58 times larger than Earth. Neptune's main constituents are water, methane, and ammonia. Like the other ice and gas giants in our system, Neptune has no solid surface. Its atmosphere extends deep into the planet to the mantle, which consists of methane and ammonia ice and a rocky core. Yet scientists believe the ice giant may have an internal warm to even hot ocean. More alive than thought. Neptune's secret is that it is by no means as dull as researchers long thought. Scientists became aware of Neptune when they discovered that it has an active climate and some of the most violent and powerful storms in the solar system. The climatic phenomena on Neptune are much more like an oversized rocky planet than a gas planet. Measurements have revealed that Neptune's solid core may be larger and more complex than long thought. In fact, intense geological processes inside the planet can explain the weather phenomena. But not only that, model calculations have shown that Neptune could harbor a warm ocean beneath its ice. Sunlight travels a full 4 hours to reach Neptune's surface. Neptune's average atmospheric temperature is minus 182 degrees Celsius, making it one of the coldest objects in the solar system. Between the years 2003 to 2018, the planet experienced significant cooling, and at the same time, temperatures at the South Pole rose in 2018. Researchers noticed an interesting change in the chemical composition of Neptune's atmosphere in this context. These very changes provided evidence of internal heating produced by gravitational compression, or gravitational interaction between Neptune and its moon Triton. This naturally raises the question of whether life could exist on Neptune. For a long time, researchers thought that this was not possible, but this view is slowly changing. Since we have found life in the most impossible places on Earth, we have to open our minds to the possibility that life may exist in places in the solar system that we have previously overlooked. For a long time, we searched on Mars, and even Venus will soon be examined more closely for traces of microbes in the atmosphere. But Neptune was not on anyone's radar during this search. Some very brave scientists even suggested that some of the strange spots on Neptune might be caused by swarms of bacteria under the thick ice. This theory currently finds few supporters, but who knows? We may be in for a surprise. Neptune's troubled past. Another explanation for the enormous internal energy inside Neptune could have been a collision with a cosmic object. Since Neptune is the only planet that radiates nearly 3 times as much energy as it receives from the Sun, some as yet unknown mechanism must be at work. Another clue is the unusual 28-degree tilt of the axis. The axis tilt is similar to Earth's and explains why Neptune experiences seasons. Unlike on Earth, a season on Neptune lasts not just a few months, but a full 40 years. Because of Neptune's long distance from the Sun, the clocks run a little differently here. Not only are the seasons a bit longer than on Earth, but also a Neptune year is a bit longer, at 165 Earth years. However, since Neptune rotates quite quickly around its own axis, a day on the planet lasts just 16 hours. The planet's rapid rotation generates some of the strongest winds in the solar system. Neptune is the windiest planet in the system, and winds quickly assume speeds of up to 1,900 kilometers per hour. This makes Neptune's storms even stronger than those on Jupiter. Similar to Jupiter, Neptune also has a large storm that forms a prominent surface. The Earth-sized cyclone was first discovered by the Voyager 2 spacecraft in 1989. In 1994, the storm had disappeared from a new image taken by the Hubble telescope. Instead, a small, new spot had appeared in the northern hemisphere. In contrast to the 300-year-old cyclone on Jupiter, the violent storms on Neptune exist only 2 to 6 years. Since Neptune has certain similarities with Jupiter and has a kind of mixture of a rocky planet and a gas planet in its interior, researchers came up with an interesting idea. Neptune seems somehow out of place on its position at the outer edge of the solar system. From the evolutionary history of the planets, Neptune may have once formed between Mars and Jupiter. It's quite possible that some planets in our solar system have exchanged places in the course of time. Thus, Neptune could have been pushed to the edge of the system by the tremendous gravitational forces of Jupiter. Another crazy theory says that Neptune is so different from all other planets because it did not originally come from our solar system at all, but was captured as a vagabond planet by our sun at some point. If this theory is correct, Neptune would be an alien world which quasi-cheated itself into our solar system. Why is Neptune so blue? Neptune's atmosphere is 80% hydrogen and 19% helium, with the rest being other gases, including some methane. In fact, it is this small amount of methane that colors the planet deep blue. Methane molecules absorb solar radiation in the short-wave region and reflect the color blue. Uranus has a very similar distribution of gases, but unlike Neptune, its color is pale blue. Researchers from Oxford University tried to unravel this mystery. In their thesis, they suggested that this difference in color could be due to the density of the methane nebula. Both planets have several layers within their atmospheres formed from fine aerosols. The bottom layer is a mixture of hydrogen disulfide ice. The second layer is probably exactly what turns both planets more or less blue. Since Neptune's atmosphere is much more active than Uranus's, its second aerosol layer is thinner. Because of the lower density, more light is reflected, and this provides the intense blue color. The third atmospheric layer consists of large particles of methane ice. The retrograde moon, Triton. Thanks to James Webb's new image, scientists will unlock the secrets of Neptune's best-known moon, Triton. Triton is a very active moon. Its surface is covered in methane and nitrogen ice. Methane flakes appear, and Triton has very active volcanoes. Researchers have not been able to explain how the heat inside and the unusual volcanism came about. It was thought that the seventh largest moon in the solar system is heated by Neptune's gravity. The volcanoes emit a mixture of cold dust and gas into the thin atmosphere. It is possible that these ejections are involved in the formation of Neptune's fine rings of dust and gas. A very similar process has been observed in the vicinity of Saturn. There, the icy moon Enceladus feeds one of the gas giant's outer rings with tiny ice particles. Triton is special among the moons of the solar system because it orbits retrograde around its planet. This suggests that it may once have been an independent object captured by Neptune. The unusual retrograde orbit and its intense reflection have led to speculation that this moon was originally a Kuiper Belt object, gravitationally bound by Neptune. Researchers now hope the new image and much more information will finally clarify where Neptune really came from and when and how Triton became bound to it. It's really exciting what's happening at the very edge of the solar system. It almost seems like every planet and every moon in the solar system has some fascinating property that makes it unique and a worthwhile object of study. We look forward to sharing more information about Neptune and its moons with you soon. Tell us now what you find particularly interesting about this planet.
We know some of the answers. Finding the solution, where do the stars come from? Questions of this nature are as inevitable as a person's smile. They have always been questioned about it. What makes our time different from the past is that, at long last, we know some of the answers. Finding the solutions to problems is made much easier by the existence of books and libraries. The term recapitulation refers to a principle with powerful, if limited, applicability in biology. This principle states that during our individual embryonic development, we retrace the evolutionary history of the species. In the process of our intellectual development, a recapitulation also takes place. We unconsciously wander back in time and revisit the ideas of our distant ancestors. Try to picture a world in which there was no science and no libraries. Imagine a period that occurred several 100,000 years in the past. We had about the same level of intelligence, the same level of curiosity, and the same level of involvement in social and sexual activities. However, the experiments had yet to be carried out, and the innovations had yet to be conceived. It was the time when the Homo genus was still young. Imagine the moment when the fire was discovered for the first time. What was it like to be a human back then? When our ancestors looked at the night sky, what did they think the stars were? My imagination takes me to a place where I sometimes picture someone thinking something like this. Berries and roots are a staple food for us. Things like nuts and leaves, as well as dead animals. Some animals we discover, and others we hunt and kill. We are aware of the healthy foods and those that are harmful. The punishment for eating certain foods is that we are allowed to taste them. We had no intention of acting in an unsavory manner. Hemlock and foxglove, on the other hand, are both lethal. We have a deep love for both our offspring and our companions. We caution them to avoid eating such foods. When we hunt animals, we put ourselves in danger of being killed ourselves. We can express gratitude, or crushed underfoot, or consumed. What animals do, how they act, what tracks they leave behind, when they mate and have babies, and when they wander, directly impacts our lives. This includes the window of opportunity during which they do these things. These are things that we need to be aware of. It's something we tell our kids. They will share it with their offspring. We are completely reliant on animals. We take their advice, particularly during the colder months when fewer plants are available to eat. We are nomadic hunters and gatherers who travel from place to place. The name given to our people is the hunter folk. Most people doze off while lying beneath the stars, a tree, or one of its branches. We wrap ourselves in animal skins to insulate ourselves from the cold, to conceal the fact that we are naked, and occasionally to use as a hammock. When we wear animal skins, we can feel the power of the animal. We bound through the air like a gazelle. We go on hunts together with the bear. We share a connection with the other living things in the world. We engage in hunting and then consume the game. They hunt us down and consume us. We are each other's complete selves. Tool-making is essential to our continued existence. Some of us are good at finding rocks, splitting, flaking, sharpening, and polishing rocks. We fashion an axe by attaching animal sinew to a wooden handle and placing it on top of some rocks. When we swing the axe, we hit both plants and animals. Some rocks are attached to long sticks. If we are cautious and quiet, there is a chance that we will be able to approach an animal and use the spear to kill it. The meat will go bad. Sometimes we are hungry, but we choose to ignore it. Sometimes, to mask the flavor of bad meat, we mix herbs in with it. To preserve perishable foods, we fold them into pieces of animal skin, or large leafy plants, or the husk of a particularly large nut. It is prudent to set some food aside and bring it with you. If we consume this food too soon, some of us will end up starving later. Therefore, we are obligated to assist one another. Rules have been established for this and a great number of other reasons. Everyone is responsible for following the rules. There have always been guidelines in place. The rules must be followed. One day a thunderstorm was complete with lightning, thunder, and rain. The younger ones have a phobia of thunderstorms, and other times I am as well. The cause of the storm is a closely guarded secret. The thunder is rumbling and extremely loud, and the lightning is flashy and intense for a short while. Perhaps someone very powerful and influential is feeling very angry. Someone or something must be up in the clouds. In the immediate forest area, there was a flickering and crackling sound after the storm. We went to see something that was bright, hot, and jumping, and it was yellow and red in color. Something like that had never appeared in front of us before. It has its distinctive odor, which we now call flame. To some extent, it possesses life. Food is consumed by it. If allowed, it will consume plants, tree limbs, and even entire trees. It has a lot of power, but it has the potential to be smarter. It will perish if there is nothing left to eat. If it has food, it will travel the distance of a spear throw from one tree to the next. It is only able to walk while it is feeding. but in places with abundant food, it flourishes and births many flame children. Someone among us had the courageous and terrifying idea to tame the flame, give it some fuel, and cultivate a relationship with it as a friend. We discovered some lengthy branches of various types of hardwood. The flame consumed them, but it was a slow process. We could pick them up when we reached the end, which was not on fire. When you run too quickly with a small flame, it will extinguish. Their offspring are frail and vulnerable. We did not attempt to run. As we went, we yelled out encouragement to one another. We pleaded with the fire, telling it, "Do not perish." The other hunters stopped what they were doing and stared at me with wide eyes. Since then, we have always kept it close at hand. We have what amounts to a flame mother, who will slowly feed the flame so it does not perish from hunger. Flame is a wonder that serves a purpose and is almost certainly a gift from more powerful beings. Are they the same as the irate beings seen in the storm? During the chilly nights, the flame helps keep us warm. It is a source of light for us. When the moon is new, it creates voids where there was once darkness. Tonight is a good time to sharpen spears for tomorrow's hunt. If neither of us is exhausted, we can see each other and converse even though it is dark. A further positive development. Fire deters animals from approaching. The nighttime poses a risk for us. Smaller animals such as wolves and hyenas have sometimes consumed us. It is not the same anymore. The flame is successful in preventing the animals from approaching. We can hear them howling softly in the darkness as they prowl around, their eyes glowing brightly in the light of the flame. They are shaken with fear when they see the fire. However, we do not feel any fear. We are the keepers of the flame. We are the ones who tend to the fire. The flame watches over and protects us. There is significance in the sky. We are protected by it. It addresses us directly. Before we discovered the source of the light, we used to lie down in the pitch black and look up at the various points of light. A representation of the sky would emerge due to the convergence of a few points. Someone among us had a clearer view of the images than the others did. She instructed us on how to draw the constellations and taught us their names. We used to gather late at night and make up stories about the pictures we saw in the sky, which included lions, dogs, bears, and people who hunted and gathered their food. Other, stranger things. Could these images represent the powerful beings in the sky, the same beings whose wrath causes violent storms? The sky rarely alters its appearance. The star pictures are always the same from one year to the next. The moon begins as nothing, then expands into a thin sliver, into a round ball, and finally shrinks back to nothing. When there is a change in the phase of the moon, the women bleed. Some communities have rules prohibiting sexual activity during particular phases of the moon's growth and shrinkage. On the antler, bones of some tribes can be found scratched on the days of the moon or the days that the women bleed. After that, they can organize themselves and follow their rules. The rules must be followed. The stars are located at a great distance. We will only get closer to them if we climb a hill or a tree. In addition, clouds prevent us from seeing the stars. Therefore, the stars must be located behind the clouds. As it slowly moves across the sky, the moon occasionally obscures our view of distant stars. After some time, you will notice that the stars have not been harmed. The moon does not consume the stars in any way. The stars are located behind the moon. They are flitting, a strange light that was distant, white, and cold. Many of them, everywhere in the heavens, but only when it's nighttime. I'm curious to know what they are. After locating the flame, I sat near the campfire and thought about the night sky. The notion crept up on me gradually. I imagined the stars to be flames. After that, an idea came to me. The stars are the campfires other hunters lit during the night. Even the brightest campfire can't compare to the stars' light. Therefore, the stars must be extremely distant campfires. But, they ask me, how can there be campfires in the sky? Why do the campfires and hunters gathered around those flames not fall to our feet? Why don't strange tribes drop from the sky? Those are insightful questions to consider. They give me a headache. Sometimes the sky resembles the bottom half of a large eggshell or nutshell. If you get what I'm saying, the people sitting around those distant campfires look up at us and say that we are in their sky, and they wonder why we haven't fallen up to them yet. This is if you understand what I mean. However, hunterfolk have a saying, down is down and up is up. This is also a valid response. One of us also had another thought about this. His perception of night was that it was a large, dark animal skin draped over the canopy of the sky. The skin has several holes in it. We examine the area through the holes, and there are flames visible. There are a few spots where we can see stars where he's going with this idea too. He believes that fire can be found in every corner. He is under the impression that flames fill the entire sky. However, the skin hides the flame, except for the holes. Some stars wander. We hunt just like the animals do, just like us. You will notice they move if you closely monitor them for several months. There is only a total of 5 of them, like there are 5 fingers on a hand. They move through the night sky in a leisurely manner. If the story around the campfire is accurate, those stars must be groups of nomadic hunters traveling with large fires. But I don't understand how stars that move around could be holes in a skin. When a hole is made, it is immediately visible. Simply put, a hole is a hole. Holes don't go anywhere else. In addition to that, I do not wish for the sky above me to be composed entirely of flames. If the skin were removed, the night sky would be bright, far too bright, as if flames were everywhere. I believe that a sky full of flames would consume all of us. Perhaps there are 2 distinct types of powerful beings residing in the clouds. Those who wish for us to be consumed by the flame. And then there are the good ones who put on the armor to ward off the enemy. We must devise a way to express our gratitude to the good ones. I wonder if the stars are just campfires floating around in the night sky. Or perhaps there are slits in our flesh through which the blazing torch of authority peers. There are times when I have a certain thought. There are times when I have a different thought. At one point, I was under the impression that there were neither campfires nor holes. However, there was something else I could not comprehend. Put the log under your neck to relax it. You are bending your head backwards. After that, you will only be able to see the sky. There are no mountains, forests, other campers, or campfires. Only the sky. There are times when I find myself floating in the clouds. I want to visit those other campfire keepers who are out and about if the stars are campfires. After that, I have a positive attitude about getting back up. However, I feel fear if the stars are holes in a skin. I don't want to be sucked into a hole and thrust into the blazing fire of power. I really wish I knew which of these was correct. It bothers me when I'm in the dark. It's hard for me to imagine that many people in a group that relied on hunting and gathering would have had such ideas about the night sky. A select few did throughout history, but never all of these thoughts in the same individual. However, complex ideas are not uncommon in these kinds of communities. For instance, the Kung Bushmen who live in the Kalahari Desert in Botswana have a theory about the Milky Way, which, due to their location, is frequently visible in the sky above them. They call it the backbone of night, as if the night sky were some enormous beast we live in. Their explanation not only helps one to comprehend, but also makes the Milky Way more useful. The Kung believe that the Milky Way keeps the night from crumbling to the ground below us. If it weren't for the Milky Way, pieces of darkness would fall to the ground right at our feet. It is a very sophisticated idea. Metaphors such as those about galactic backbones or celestial campfires were eventually supplanted in most human cultures by a different concept. The powerful beings in the sky were elevated to the status of gods. They were each given a name, a relative, and a unique set of responsibilities following the tasks expected of them in the cosmos. Every conceivable human preoccupation was represented by a god or goddess. The gods ruled over nature. Nothing could take place in the absence of their direct participation. If they were content, there would be an adequate food supply, making people content. However, If the gods were angered by anything, and sometimes it only took a very small thing, terrible things would happen, such as droughts, storms, wars, earthquakes, volcanoes, and epidemics. To appease the gods, a vast industry of priests and oracles existed. This was done to calm the wrath of the divine beings. However, since the gods were arbitrary, predicting what they would do was impossible. The natural world remained a mystery. It was challenging to make sense of the world. On the island of Samos in the Aegean Sea lies what is left of the Heraion, which was once considered one of the 7 wonders of the ancient world. It was a massive temple devoted to Hera, who was originally worshipped as the goddess of the sky. She was revered as the protector goddess of Samos and served the same function on that island as Athena did on Attica. Long after that, she tied the knot with Zeus, the most powerful of the Olympian gods. According to the legends, they went to Samos for their honeymoon. The Greek religion explained that diffuse band of light in the night sky as the milk of Hera, squirting from her breast across the heavens. This legend originates from the phrase Westerners still use, the Milky Way. It's possible that it once stood for the profound idea that the heavens provide sustenance for the earth, but if so, we have lost track of that significance throughout several millennia. Nearly all of us are descended from people who came up with stories about capricious or displeased deities to cope with the challenges of being alive. In ancient Greece, during the time of Homer, there were gods of the sky and the earth, the thunderstorm, the oceans and the underworld, fire and time, and love and war. Every tree and meadow had its own dryad and maenad. For a very long time, the human instinct to understand was thwarted by simplistic religious explanations. The idea that the universe is like a marionette, the strings of which are pulled by an unseen and incomprehensible god or gods, has oppressed humans for thousands of years, and it continues to do so for some of us even today. Then, approximately 2,500 years ago, Ionia experienced a momentous reawakening, specifically on the island of Samos and the other nearby Greek colonies that flourished. Among the numerous islands and coves of the Aegean Sea's active eastern side, some people suddenly believed that everything was composed of atoms, that humans and other animals had evolved from simpler forms, that diseases were not caused by demons or the gods, and that the Earth was nothing more than a planet that revolved around the sun, and that there was a great distance between the stars. Because of this revolution, chaos was transformed into the cosmos. The ancient Greeks believed chaos was the first being to exist, corresponding to the phrase "without form" in Genesis in the same context. Chaos was created. Then he mated with a goddess named Night, and their offspring eventually produced all of the gods and men. The idea that an unpredictable and capricious nature was controlled by gods was consistent with the ancient Greek belief that the universe was created from chaos. But during the 6th century BC, the people of Ionia developed a brand new idea that would become one of the most important concepts in human history. The ancient Ionians concluded that the universe can be comprehended because it possesses an inherent order. More specifically, natural patterns make it possible for its mysteries to be solved. Even Mother Nature has to play by the rules. The natural world has no complete randomness. The name given to this beautiful and well-ordered aspect of the universe is cosmos. But why would anyone want to live in Ionia, with its unassuming and pastoral landscapes, isolated islands and inlets in the eastern Mediterranean? Why not in one of the great cities of China, Mesoamerica, India, or Babylonia? China's astronomical tradition dates back millennia, and the country was the first to develop paper and printing technology, rockets, clocks, silk, porcelain, and ocean-going navies. Several historians believe that despite this, it was a society that was far too traditionalist and unwilling to adopt innovations. Why not India, an extremely rich culture and exceptionally gifted in mathematics? Certain historians remain utterly fixated on the concept of an infinitely old universe doomed to an endless cycle of deaths and rebirths, of souls and universes, in which nothing fundamentally new could ever take place. Why not the Mayan and Aztec societies, which were skilled in astronomy and fascinated by large numbers just like the Indians were? Some historians assert that they did not possess the necessary skills or the drive to develop mechanical inventions. If you count their toy versions, the Mayans or the Aztecs only invented the wheel. The Ionians held several distinct advantages. The realm of Ionia is located on an island. Isolation, even if only partial, is a breeding ground for diversity. Due to the many distinct islands, there were many different political systems. There needs to be more power in any one location to impose social and intellectual uniformity across the entire archipelago. The possibility of free inquiry emerged. Encouraging people to believe in superstitions was not considered necessary for political survival. In contrast to many other ancient cultures, the Ionians existed not at the center of civilization, but rather at a crossroads between many different cultures. Ionia was where the Phoenician alphabet was first modified for use in Greek, which paved the way for spreading literacy. The priests and scribes no longer held exclusive rights to the ability to write. The ideas of a great number of people were laid out for consideration and discussion. The merchant class held political power at the time, and they were the ones who drove forward the technological advancements that were essential to their economic success. African, Asian, and European civilizations, as well as the great cultures of Egypt and Mesopotamia, came into contact with one another and cross-fertilized one another in the Eastern Mediterranean. This interaction resulted in a vigorous and heady confrontation of prejudices, languages, ideas, and gods. What should one do when confronted by multiple gods who claim ownership over the same territory? The Babylonian god Marduk and the Greek god Zeus were revered as supreme rulers of the heavens and the pantheon of deities. You'll come to the conclusion that Zeus and Marduk were actually the same. The priests could also make up one because they had very different characteristics. If only one is possible, then why not both? And so it was that the great idea came to be. The realization that there might be a way to know the world without the God hypothesis, that there might be principles, forces, and laws of nature through which the world could be understood without attributing the fall of every sparrow to the direct intervention of Zeus. In other words, the idea that there might be a way to know the world without the God hypothesis was the realization that there might be a way to know the world without the God hypothesis. If they had been given more time, China, India, and Mesoamerica would have become scientifically advanced. Cultures do not develop following the same rhythms or progress in step with one another. They begin at various times and advance at several different rates. Because the scientific worldview works so well, explains so much, and resonates so harmoniously with the most advanced parts of our brains, it is inevitable that, given enough time and the opportunity to pursue its own interests, virtually every culture on Earth will, at some point, find its way to science. Some cultures needed to come first. It turned out that Ionia was the place where the first scientific discoveries were made. This significant shift in human thought began between 600 and 400 BC. The hand was the instrument that enabled the revolution to succeed. Sons of farmers, seafarers, and weavers gave birth to some of the most brilliant thinkers in Ionian history. They were used to prodding and fixing things, unlike the priests and scribes of other nations, who had been brought up in luxury and were unwilling to get their hands dirty. They did not believe in superstition, and as a result, incredible things happened. Quite frequently, the only accounts we have need to be completed or come from second-hand sources. The metaphors used back then are lost on us now. A few centuries later, there was almost certainly an effort made on purpose to bury the new insights that had been discovered. The most influential people during this uprising were people with Greek names who are largely unknown today. However, these men were the true forefathers in the expansion of our civilization and our humanity. Thales of Miletus, a city in Asia located across a narrow water channel from the island of Samos, is regarded as the first Ionian scientist. He was well versed in the knowledge of Babylon and had previously explored Egypt. He allegedly predicted that there would be a solar eclipse. He was the first person to learn how to calculate the height of a pyramid based on the length of its shadow and the angle at which the sun was positioned above the horizon. This technique is still used today to calculate the heights of the mountains on the moon. He was the first person to prove geometric theorems that Euclid would codify 3 centuries later, such as the proposition that the angles at the base of an isosceles triangle are equal. There is a clear continuity of intellectual effort from Thales to Euclid to Isaac Newton's purchase of the elements of geometry at Stourbridge Fair in 1663, precipitating modern science and technology. This can be demonstrated by tracing the history of the work from Thales to Euclid. Thales tried to comprehend the world without appealing to the gods' assistance in any way. Like the Babylonians, he believed the entire world was once covered in water. The Babylonians claimed that to explain why there was dry land, Marduk had placed a mat on the surface of the waters and then piled dirt on top of it. Yes, everything was once water, but the earth formed out of the oceans by a natural process, similar, he thought, to the silting he had observed at the delta of the Nile. Benjamin Farrington said Thales held a similar view but left Marduk out. He believed that water was a universal principle underpinning the world's matter, much like we might say today about electrons, protons, neutrons, or quarks. Whether Thales' conclusion was correct is less important than his approach. The world was not made by the gods, but instead was the work of material forces interacting in nature. Thales brought the seeds of the new sciences of astronomy and geometry back with him from his travels to Babylon and Egypt. These are the seeds that would later germinate and flourish in the fertile soil of Ionia. Although very little is known about Thales' personal life, Aristotle tells one illuminating anecdote in his Politics. Thales was reproached for his poverty, which was supposed to show that philosophy is useless. According to the legend, he could interpret the signs of the heavens and knew that while it was still winter, there would be a large harvest of olives in the following year. As a result, despite only having a small amount of money at the time, he put down deposits for the use of all of the olive presses in Chios and Miletus, which he hired at a low price because no one else bid against him. When it came time to harvest the crops, and a large number were needed all at once, he let them out at any rate he pleased, and as a result, he made a lot of money. As a result, he demonstrated to the rest of the world that philosophers can easily become wealthy if they so choose. However, their goals are different. In addition to this, he was well known for his role as a political sage. He successfully persuaded the Milesians to resist assimilation by Croesus, king of Lydia, but he was unsuccessful in persuading the island states of Ionia to form a federation to fight the Lydians. Anaximander of Miletus was a friend and colleague of Thales, one of the first to conduct an experiment. Anaximander was also a prominent figure in ancient Greek philosophy. He accurately determined the length of the year and the seasons by observing the shifting shadow cast by a stick that was held vertically. Men have been using sticks to club and spear one another for a long time. Time was measured with one of these by Anaximander. He is credited with being the first person in Greece to construct a sundial, a map of the known world, and a celestial globe that displayed the patterns of the constellations. He believed that the sun, the moon, and the stars were made of fire and could be seen through moving holes in the sky's dome. This is an idea that is quite old. He held the remarkable view that the earth is not supported or suspended from the heavens, but rather remains at the center of the universe. He reasoned that since it was equidistant from all places on the celestial sphere, no force could move it. He believed that the earth was the center of the universe. He argued that we are so helpless when we are born, that if the first human infants had been put into the world on their own, they would have died as soon as they were exposed to the outside world. Anaximander concluded that humans evolved from other animals with newborns that were more capable of taking care of themselves. He hypothesized that life began by itself in the muck, and that fish covered in spines were the first animals to evolve. Some of these fishes' descendants eventually moved onto land, where they underwent the process of metamorphosis, changing from one form into another. This allowed them to evolve into other kinds of animals. He believed there were infinite worlds, all inhabited and gone through cycles of destruction and regeneration. Nor, St. Augustine lamented in a regretful tone, did he, any more than Thales, attribute the cause of all this ceaseless activity to a divine mind. In the year 540 BC or thereabouts, on the island of Samos, there came to power a tyrant named Polycrates. After working as a caterer for a while, he moved on to a career as an international pirate. The arts, sciences, and engineering fields benefited greatly from Polycrates' philanthropic support. But he oppressed his own people. He made war on his neighbors. He quite rightly feared invasion. As a result, he constructed a massive wall approximately 6 kilometers in length and encircled the city that served as the capital of his kingdom. He ordered a massive tunnel to transport water from a remote spring through the fortifications. It is a kilometer long, and it goes through a mountain. 2 cuttings, one dug from each end, eventually met in the middle and almost created a perfect circle. The fact that the undertaking was finished in only about 15 years is both a testimonial to the state of the art in civil engineering at the time and an indication of the extraordinary practical capability of the Ionians. But there is another, more ominous side to the enterprise. It was partly constructed by enslaved people in chains, many of whom were captured by the pirate ships of Polycrates. Those ships were responsible for the majority of the construction labor. It was during this time that Theodorus, the age's most accomplished engineer, was active. Among the Greeks, Theodorus was credited with creating the key, the ruler, the carpenter's square, the level, the lathe, bronze casting, and central heating. Why are there no memorials or statues dedicated to this man? Those who dreamed and conjectured about natural laws conversed with those who worked in technology and engineering. They frequently consisted of the same individuals. Both the theoretical and the practical aspects merged into one another. At the same time, Hippocrates established his renowned medical tradition on the neighboring island of Kos, which is now largely forgotten due to the Hippocratic Oath. Hippocrates insisted that the school of medicine he founded had to be based on the contemporary principles of physics and chemistry, so that it could be both useful and successful. However, there was also a theoretical component to it. Hippocrates wrote this in his book On Ancient Medicine. Men think epilepsy is divine, simply because they do not understand it. However, if they called everything divine, which they do not comprehend, why would there be no end to divine things? The Ionian influence and the experimental method eventually made their way to the mainland of Greece, Italy, and Sicily over time. At one point in history, very few people had faith in the existence of air. Naturally, they were aware of breathing and believed the wind was the divine wind that the gods breathed. On the other hand, the concept of air as a corporeal but imperceptible substance did not exist. The first experiment to be recorded while being conducted on air was carried out by a physician named Empedocles, who was active around 450 BC. According to a few versions of the story, he fancied himself to be a god, but people only regarded him as divine because he was so intelligent. He thought that the speed of light was extremely fast, but not infinitely fast. He taught that there had been a significantly greater variety of living things on Earth in the past, but that many different races of beings must have been unable to beget and continue their kind. Because of this, every species that has ever lived has been shielded from danger and kept alive thanks to its members' ingenuity, bravery, or swiftness from the beginning of their existence. Empedocles, along with Anaximander and Democritus, see below, clearly anticipated some aspects of Darwin's great idea of evolution by natural selection in his attempt to explain the lovely adaptation of organisms to their environments. Empedocles' attempt can be found in the following passage. The so-called clepsydra, known as the water thief, was a kitchen ladle used during Empedocles' experiment. It was a common household implement used by people for many years. A water-filled brazen sphere with a wide opening neck and numerous tiny holes in the base is presented here. When you pull it out while keeping the neck open, water creates a little shower by pouring out the holes in the bottle. However, if you pull it out properly, with your thumb covering the neck, the water will remain within the sphere until you lift your thumb. This will take place until you lift your thumb. Nothing will happen if you attempt to put something in it while the neck is covered. There must be something tangible in the path of the water. This kind of substance is invisible to our eyes. Is there any way to tell? Empedocles contended that the substance in question could only be air. If I were so foolish as to keep my finger on the neck, a force that we cannot see could exert pressure, making it impossible for me to fulfill my desire to fill a container with water. Empedocles had made a discovery that was previously unknown. He reasoned that for matter to exist in the form of air, it must be extremely finely divided and therefore invisible. It is said that Empedocles committed suicide by jumping into the molten lava that filled the summit caldera of the massive volcano Etna during an episode of apotheosis. But there are times when I like to think that he lost his footing amid a bold and innovative endeavor in observational geophysics. Democritus, who was born in the Ionian colony of Abdera in northern Greece, was the one who took this oblique suggestion, this whiff, of the existence of atoms and developed it significantly further. To some extent, Abdera was a town full of jokes. In the year 430 BC, if you told a story about someone from Abdera, you could count on getting a good laugh out of your audience. It was similar to Brooklyn in many ways during that era. Democritus believed that every aspect of life should be appreciated and comprehended, and that doing so was equivalent to having fun. He once said, "A life without festivity is like a long road without an inn." Democritus may have been born in Abdera, but that doesn't mean he was a fool. He believed that many worlds formed independently out of the diffuse matter found in space, developed, and eventually disappeared. At a time when no one knew about impact craters, Democritus believed that worlds occasionally collided. He also believed that some worlds wandered alone through the darkness of space, while others were accompanied by several suns and moons, that some worlds were inhabited, while others lacked plants, animals, or even water, and that the most basic forms of life emerged from a kind of primordial ooze. Democritus lived in a time when no one knew about impact craters. He taught that perception was a purely physical and mechanistic process, such as the reason, for example, that I think there is a pen in my hand, that thinking and feeling were attributes of matter put together in a sufficiently fine and complex way, and not due to some spirit that was infused into matter by the gods. And that perception was the reason, for example, that I think there is a pen in my hand. Democritus is credited with the invention of the word atom, which comes from the Greek for unable to be cut. Atoms were the most fundamental particles, and our efforts to disassemble them into smaller parts were ultimately fruitless. According to what he said, everything is just a complex collection of atoms put together, even us. Nothing exists, he asserted, but atoms and the void. When Democritus sliced an apple, he believed the knife had to travel through the empty spaces between the atoms. If there were no such things as empty spaces or voids, the apple could not be cut because the knife would run into atoms that were impossible to penetrate. Let's say we started by cutting a slice from a cone. Now, let's look at the difference in the cross-sections of the two pieces. Are there any differences in the exposed areas? Not at all, Democritus replied. Because of the cone's slope, one side of the slice will have a slightly less extensive cross-section. If the two areas were the same, we would not have a cone but rather a cylindrical shape. Regardless of how skilled the knife user is, the two pieces will always have different cross-sections. Why? Because when viewed on an extremely small scale, the texture of matter has an element of irreducible roughness. Democritus believed that the world of the atoms could be represented by a particularly fine scale of roughness. His arguments were not the same as those we use today. They were subtle, elegant, and derived from life in general. And the conclusions that he came to were basically accurate. In a separate thought experiment, Democritus considered the possibility of determining the volume of a cone or a pyramid by stacking a very large number of very small plates that gradually shrank in size from the base to the apex of the structure. He outlined the difficulty that can be found in the mathematical theory known as the theory of limits. He was on the verge of discovering differential and integral calculus, a fundamental tool for understanding the world that, as far as we can tell from written records, was discovered in the time of Isaac Newton. He was knocking on the door of differential and integral calculus. Calculus could have been invented by the time of Christ if Democritus's work had been almost entirely recovered. Long before astronomy reaped any benefit from the improved sciences of optics, he saw, as we may say, through the eye of reason, full as far into infinity as the most able astronomers in more advantageous times have done since. Thomas Wright marveled in 1750 about Democritus's belief that the Milky Way was made up primarily of unresolved stars. The mind of Democritus soared further and further away from the milk of Hera, and further still from the backbone of night. It would appear that Democritus was a rather peculiar individual. He placed a high value on friendship, thought that happiness should be the primary aim of one's life, and devoted a significant portion of his philosophical research to studying the roots and characteristics of enthusiasm. He traveled to Athens intending to pay Socrates a visit, but he needed to be more bold to introduce himself. Hippocrates counted him as one of his closest friends. He was in awe of the world because of its beauty and sophistication. He thought that being poor under a democratic government was preferable to being wealthy under an autocratic one. He thought that the dominant religions of his time were corrupt, and that there was no such thing as an immortal soul or God. Nothing exists but atoms and the void. It is unknown whether Democritus faced any consequences due to his opinions. However, he was from Abdera. However, during his period, the tradition of tolerating unconventional viewpoints deteriorated and broke apart. People began to suffer consequences for harboring strange beliefs. Democritus can now be depicted on Greece's 100 drachma note. However, his observations were disregarded, and his impact on history was negligible. The mystics were making progress towards victory. An Ionian experimentalist, Anaxagoras, flourished around 450 BC and resided in Athens during his lifetime. He was wealthy and apathetic towards his wealth, but had a strong interest in science. When asked what the point of life was, he responded with, "The investigation of the sun, the moon, and the heavens," which is the response that one would expect from a genuine astronomer. He carried out a deft experiment in which he demonstrated that adding a single drop of a white liquid, such as cream, to a large pitcher containing a dark liquid, such as wine, did not noticeably lighten the pitcher's contents. He concluded that there must be changes that can be deduced through experiments but are far too subtle to be directly perceived by the senses. Democritus was a much more revolutionary thinker than Anaxagoras was. Both of them were committed materialists, not in the sense that they placed a high value on possessions, but rather in the sense that they believed that matter alone was responsible for the structure of the world. Anaxagoras was a philosopher who disbelieved in the existence of atoms and held that there was a unique mental substance. He held the very Ionian belief that the presence of hands conferred a higher level of intelligence on humans than on other animals. He was the first person to state unequivocally that the moon shines as a result of reflected light, and as a result, he developed a theory regarding the phases of the moon. Because of the severity of the threat posed by this doctrine, its description had to be passed around as a covert document known as an Attic samizdat. Explaining the phases of the moon or eclipses using the relative geometry of the Earth, the moon, and the self-luminous sun at the time was unacceptable because it did not conform to the prevalent prejudices. Aristotle, who lived 2 generations later, was content to argue that those things occurred because it was the nature of the moon to have phases and eclipses. This explanation is nothing more than verbal juggling, and it explains nothing. The majority of people held the belief that the sun and the moon were deities. According to Anaxagoras, the sun and the stars were both made of fiery stones. Because of their great distance from us, we do not feel the heat that the stars produce. In addition, he believed that the moon possessed mountains and inhabitants, both of which were incorrect. According to his theory, the sun was so enormous that it was even bigger than the Peloponnesus, which occupies approximately the southwestern third of Greece. This estimate was considered excessive and ridiculous by his detractors. Anaxagoras was brought to Athens by Pericles, who was in charge of the city at the time of its greatest glory, but was also the person whose actions led to the Peloponnesian War, which was ultimately responsible for destroying Athenian democracy. Anaxagoras was considered to be one of Pericles' most trusted advisors. The two shared a passion for philosophy and science. Within this capacity, Anaxagoras made a significant contribution to the rise to greatness of Athens. However, Pericles encountered political challenges. Because he was too powerful to be attacked directly, his adversaries focused their attention on those close to him instead. Because Anaxagoras had taught that the moon was made of ordinary matter, that it was a place, and that the sun was a red-hot stone in the sky, he was found guilty of the religious crime of impiety and sentenced to imprisonment for it. This was because of his teachings. Bishop John Wilkins made the following observation regarding these people of Athens in the year 1638. Those zealous idolaters counted it a great blasphemy to make their god a stone, whereas notwithstanding they were so senseless in their adoration of idols as to make a stone their god. It appears that Pericles was responsible for Anaxagoras' release from prison, but unfortunately it was too late. The Ionian tradition persisted in Alexandrian Egypt 200 years later, even though the tide was turning in Greece at the time. It is common practice in history and philosophy books to refer to the great scientists from Thales to Democritus and Anaxagoras as presocratics. Their primary purpose was to maintain the philosophical status quo until the arrival of Socrates, Plato, and Aristotle, and perhaps to exert some influence on them. Instead, the ancient Ionians represent a distinct and, in many ways, contradictory tradition, albeit one that is significantly more in line with contemporary scientific understanding. Everyone who lived between the Ionian awakening and the Italian Renaissance suffered an irreparable loss because their influence was only strongly felt for 2 or 3 centuries. Pythagoras, a contemporary of Polycrates who lived in the 6th century BC, is considered the most influential person connected with Samos. Tradition has it that he was the first person in the history of the world to deduce that the Earth is a sphere. He is said to have lived in a cave on the Samian Mount Kirkis and was the first to do so. Maybe he made his point by drawing an analogy between the moon and the sun. Or maybe he saw the Earth's curved shadow on the moon during a lunar eclipse. Or maybe he noticed that when ships leave Samos and recede over the horizon, their masts vanish last. Pythagorean theorem was either found by him or his disciples. It states that the square of the longest side of a right triangle equals the sum of the squares of the shorter sides. Pythagoras did not merely demonstrate this theorem by citing specific instances. Rather, he devised a line of reasoning in mathematics that could be used to demonstrate the proposition in a more general sense. Pythagoras is largely responsible for the modern tradition of mathematical argument, which is fundamental to the scientific method. He was the first to use the word cosmos to refer to a well-ordered and harmonious universe, and a world humans could understand. Many Ionians thought observation and experimentation, the 2 mainstays of modern scientific methodology, could reveal the universe's underlying harmony. Pythagoras, on the other hand, utilized an entirely different approach. He taught that one could discover the rules of nature through one's own introspection. He and those who followed him did not believe in experimentalism on a fundamental level. They were experts in mathematical theory, and they were mystics in every sense of the word. In a statement that could be construed as being less than charitable, Bertrand Russell asserts that Pythagoras founded a religion, the main tenets of which were the transmigration of souls and the sinfulness of eating beans. His religion took the form of a religious order which in some places took control of the state and instituted a saint's rule. In other places, however, the state was not conquered. But those who had not been converted yearned for beans and eventually rebelled. The Pythagoreans took great pleasure in the indisputable evidence that could be derived from mathematical demonstrations. They envisioned a universe in which the sides of right triangles perfectly obeyed straightforward mathematical relationships. This was a world that was open to the human intellect. It stood in stark contrast to the chaotic reality of the everyday world in which we live and work. They believed that through their mathematics, they had caught a glimpse of a perfect reality, a realm of the gods, and that the world we know is merely an imperfect reflection of this perfect reality. Prisoners were imagined to be tied in such a way that they saw only passers-by's shadows and believed them to be real in the famous parable of the cave written by Plato. These prisoners had no idea that a more complex reality would be available if they turned their heads. The Pythagoreans would significantly impact Plato and, later on, Christianity. They did not advocate for the open discussion of opposing viewpoints or viewpoint confrontation. Instead, they adhered to a rigidity in their practices, which, like all orthodox religions, prevented them from recognizing and correcting their mistakes. Cicero stated in writing that, "When conversing, the demand should be less for the weight of authority than for the force of argument. They stop using their own judgment and take what they perceive to be the verdict of their chosen master as if it were the final answer, which is a positive hindrance to those who want to learn but are often negatively affected by the authority of those who profess to teach." When questioned as to the grounds of any assertion that they advanced in debate, it is said that the Pythagoreans were accustomed to responding, "The master said so," with the master referring to Pythagoras. In point of fact, I am not inclined to approve of the practice traditionally ascribed to the Pythagoreans. Because of the force of an opinion already decided, authority prevailed despite the lack of support from reason. Pythagoreans were particularly interested in regular solids, three-dimensional objects with symmetrical sides composed of the same regular polygon. The cube has 6 identical squares for its sides and is the simplest example. However, there are only 5 regular solids despite infinite regular polygons. A well-known example of mathematical reasoning which serves as the proof for this statement can be found in Appendix 2. Their familiarity with a solid known as the dodecahedron, which has 12 pentagons for sides, gave off an ominous vibe. It had some esoteric connection to the cosmos. Earth, fire, air, and water were thought to be the 4 elements that made up the world at the time. And these elements were somehow associated with the other 4 regular solids. They reasoned that since there were only 4 regular solids, the 5th one must correspond to a 5th element that could only be the stuff that made up the heavenly bodies. The concept of a 5th essence is where the English word quintessence comes from. The dodecahedron was not supposed to be discussed with regular people at all. Pythagoreans believed that everything, including all other numbers, could be calculated using only whole numbers because they were obsessed with these numbers. When it was discovered that the square root of 2, the ratio of the diagonal to the side of a square, was irrational and that 2 could not be accurately expressed as the ratio of any 2 whole numbers, regardless of how large these numbers were, a crisis in doctrine ensued. Pythagorean theorem was used, ironically, in the process of making this discovery, which is reproduced in Appendix 1. The concept of irrational originally referred to the inability of a number to be written as a ratio. But for the Pythagoreans, it came to mean something menacing, a hint that their worldview might not make sense, which is the other meaning we associate with the word irrational today. Instead of discussing these significant mathematical discoveries with others, the Pythagoreans attempted to stifle knowledge of the dodecahedron and its existence. The information was not to be shared with the outside world. Even in the modern era, scientists continue to oppose the popularization of science. They believe scientific knowledge should remain within the confines of the cult and should not be tainted by public understanding. Pythagoreans believed that the sphere was perfect, meaning that every point on its surface was the same distance from its center. Circles were another ideal shape. In addition, Pythagoreans were adamant that planetary motion was circular and occurred at a constant rate. The non-circular motion was in some way flawed and unsuitable for the planets, which, being free of the Earth, were also deemed perfect. They believed that moving slower or faster at different places in the orbit would be unbecoming. The work of Johannes Kepler provides a crystal-clear illustration of the Pythagorean tradition's benefits and drawbacks. Early Christians readily accepted the Pythagorean concept of a perfect and mystical world unseen by the senses. This concept was also an essential component of Kepler's early education. On the one hand, Kepler was convinced that mathematical harmonies exist in nature. He wrote that the universe was stamped with the adornment of harmonic proportions, and that simple numerical relationships must determine the motion of the planets. On the other hand, Kepler was convinced that the motion of the planets could not be explained by any other mechanism. On the other hand, following the Pythagoreans, he had long believed that the only acceptable motion was circular and uniform. After finding time and time again that the observed motions of the planets could not be explained using this method, he tried again. On the other hand, unlike many Pythagoreans, he was a proponent of observation and experimentation in the real world. After a while, his extensive observations of the apparent motion of the planets compelled him to give up the concept that the planets travel in circular paths and instead acknowledge that they move in ellipses. Kepler was both inspired in his search for the harmony of planetary motion and delayed for more than a decade by the attractions of Pythagorean doctrine. Kepler was inspired to search for the harmony of planetary motion. The ancient world was characterized by a widespread contempt for the sensible. Plato advised astronomers to think about the heavens rather than observe them to avoid wasting time. Aristotle says, "The lower sort are by nature enslaved people, and it is better for them than for all inferiors that they should be under the rule of a master." Aristotle said this because he believed the lower sort are by nature enslaved people. The enslaved person is allowed to participate in the daily activities of his master, while the artisan has a less intimate connection with his master and only achieves excellence in direct proportion to the amount of time he spends serving as an enslaved person. The more scathing variety of mechanics have their own distinct form of servitude. As Plutarch stated, it does not necessarily follow that, if the work delights you with its grace, the one who wrought it is worthy of esteem. He explained why this was the case. The philosopher Xenophon believed that what are called the mechanical arts carry a social stigma and are rightly dishonored in our cities. Due to attitudes like these, the brilliant and potentially fruitful Ionian experimental method was largely disregarded for the next 2,000 years. Experiments are the only way to choose between competing hypotheses and make progress in scientific research. With experiments, science can advance. Even in modern times, the anti-empirical taint left by the Pythagoreans can be found. However, why? Why do I have such a strong aversion to participating in this experiment? Benjamin Farrington, a historian of science, has put forward a theory to explain the fall of ancient scientific achievement, which is as follows. The mercantile tradition, which resulted in the development of Ionian science, also resulted in the development of an economy based on slavery. The acquisition of wealth and power was contingent upon one's ownership of enslaved people. The fortifications that belonged to polycrates were constructed by people who were enslaved. Athens had a sizable population of people who were held as enslaved people during the time of Pericles, Plato, and Aristotle. Benjamin Farrington, a historian of science, has put forward a theory to explain the fall of ancient scientific achievement, which is as follows. The mercantile tradition, which resulted in the development of Ionian science, also resulted in the development of an economy based on slavery. The acquisition of wealth and power was contingent upon one's ownership of enslaved people. The fortifications that belonged to polycrates were constructed by people who were enslaved. Athens had a sizable population of people who were held as enslaved people during the time of Pericles, Plato, and Aristotle. All courageous Athenians talk about how democracy only applies to a select group of people with privilege. Most of the time, enslaved people are responsible for performing manual labor. However, conducting experiments in the name of science requires manual labor, which slaveholders try to keep as far away from as possible. This is because only slaveholders, politely referred to as gentlemen in some societies, have the leisure time to conduct scientific research. As a result, only some people engaged in scientific endeavors. The Ionians could construct machines that were both functional and beautiful. Nevertheless, the fact that there were people available to be enslaved was detrimental to the economic motivation for the development of technology. Therefore, the mercantile tradition contributed to the Great Ionian Awakening around 600 BC. The practice of slavery may have been the reason for the decline of the Ionian civilization some 2 centuries later. There are a lot of ironies in this situation. Many different regions are experiencing the same trend. The work of Kuo Shouqing, who utilized an observational baseline of 1,500 years and improved astronomical instruments and mathematical techniques for computation, represented the pinnacle of indigenous Chinese astronomy around 1280. He did this by using improved mathematical techniques for computation and by improving astronomical instruments. It is generally accepted that Chinese astronomy went through a significant decline at some point. Nathan Sivine thinks that part of the reason lies in the increasing rigidity of elite attitudes, so that the educated were less inclined to be curious about techniques and less willing to value science as an appropriate pursuit for a gentleman. The profession of astronomer eventually evolved into a hereditary office, which is a practice that is incompatible with the progression of the subject. In addition, the responsibility for the evolution of astronomy remained centered in the imperial court and was largely abandoned to foreign technicians, primarily the Jesuits. The Jesuits were the ones who had introduced Euclid and Copernicus to the astonished Chinese. However, after the censorship of the latter's book, they had a vested interest in concealing and suppressing heliocentric cosmology. It's possible that the prevalence of the slave economy in Ionia contributed to the demise of science in Indian, Mayan, and Aztec civilizations, the same reason that it fell into disuse in Ionia. The fact that the educated classes in the contemporary Third World tend to be the children of the wealthy who have a vested interest in the status quo and who are not accustomed to working with their hands or challenging conventional wisdom is a major contributor to the political instability that plagues this region. The scientific process needs to advance at a more rapid pace. Both Plato and Aristotle had no problem living in a society based on slavery. They provided rationales for the system of oppression. They were of service to despots. They taught the disconnection of the mind from the body, which was a natural enough ideal in a society based on slavery. They also taught the separation of matter and thought and the separation of the earth and the heavens. These divisions were to dominate the thinking of Westerners for more than 20 centuries. Plato, who believed that all things are full of gods, connected his political philosophy and his conception of the cosmos through the analogy of slavery. He advocated for destroying all of Democritus's books. Much like they made significant strides towards advancing the field of science by recognizing the contributions made by Pythagoras and Plato to the idea that the cosmos is knowable and that there is a mathematical basis for nature. However, by concealing unsettling facts, adhering to the belief that scientific knowledge should be reserved for a select few, shunning the practice of experimentation, embracing mysticism, and being content to live in slave societies, these individuals have set the human enterprise back. The Ionian approach, which was in some cases transmitted through scholars at the Alexandrian library, was finally rediscovered after a long mystical sleep during which the tools of scientific inquiry lay rusting. The Western Hemisphere experienced a reawakening. Experimentation and open inquiry were given their respectful place in society once more. The reading of long-lost books and sections of text was resumed. This ancient Greek tradition inspired Leonardo da Vinci, Christopher Columbus, and Nicholas Copernicus, who independently retraced parts of this tradition. There is a lot of courageous free inquiry going on in our time, although not in politics and religion, and there is a lot of Ionian science. But in addition to this, there are horrifying superstitions and potentially lethal ethical ambiguities. Ancient inconsistencies have left us with problems. The Platonists and the Christians who succeeded them believed that the heavens were perfect and divine, whereas the earth was corrupted and unpleasant somehow. The fundamental concept that the earth is a planet and humans are citizens of the universe was disregarded and lost. Aristarchus, born in Samos 3 centuries after Pythagoras, was the first to argue for this idea. Aristarchus was one of the Ionian scientists who lived at the end of their time. At this point in history, the great library of Alexandria had become the epicenter of intellectual progress and enlightenment. Aristarchus was the first to propose that the sun, not the Earth, is at the center of the planetary system and that all planets, rather than the Earth, revolve around the sun. He also proposed that the sun is the center of the solar system. Typically, his writings on this subject must be recovered to proceed. He reasoned that because the Earth casts such a large shadow on the Moon during a lunar eclipse, the Sun must be considerably more massive than our planet and located on the outskirts of our solar system. After that, he may have concluded that it is illogical for such a massive object as the Sun to revolve around such an insignificant object as the Earth. He positioned the Sun in the middle, set the Earth to rotate once per day on its axis, and set the Earth's orbit around the Sun to occur once yearly. It is the same concept that we associate with the name of Copernicus, whom Galileo called the restorer and confirmer, rather than the inventor of the heliocentric hypothesis. Even though the foundations had been laid by Aristarchus, people were still determining the correct arrangement of the planets for most of the 1,800 years between him and Copernicus. Around the year 280 BC, it became perfectly clear. The concept incensed several Aristarchus contemporaries during his time. Cries called for him to be condemned for impiety, similar to the cries about Anaxagoras, Bruno, and Galileo. The resistance to Aristarchus and Copernicus, a form of geocentrism in everyday life, is still with us. We still talk about the sun rising and setting. Even though it has been 2,200 years since the time of Aristarchus, our language continues to operate under the assumption that the Earth does not rotate. The vast distances that separate the planets from one another, such as the 40 million kilometers that separate Earth and Venus at their point of closest approach, and the 6 billion kilometers that separate Earth and Pluto, would have astounded the ancient Greeks, who were incensed by the idea that the sun might be as big as the Peloponnesus. Considering the solar system was significantly closer to home and more local, it was only natural. If I place my index finger in front of my eyes and look at it with both eyes, it appears to be moving in the background in the distance. The closer my finger gets to the object, the more motion I appear to see. Based on the amount of this apparent motion, also known as parallax, I can calculate the distance to my finger. If I spread my eyes further apart, the movement of my finger will appear to be much more pronounced. The longer the baseline from which we make our two observations, the greater the parallax will be, and the more accurately we can measure the distance to more distant objects. However, we live on a platform that is constantly moving, and that platform is the Earth. Every 6 months, the Earth travels the 300,000 kilometers that separate one end of its orbit from the other. We can determine very large distances at the same immobile celestial object 6 months apart. Aristarchus had a hunch that the stars were actually faraway suns. He positioned the sun among the permanently positioned stars. The fact that there was no detectable change in stellar parallax as the Earth moved gave rise to the hypothesis that the stars were located far from the sun. Before the telescope's development, even the most nearby stars had a parallax that was too minute to be picked up by the instrument. In the 19th century, someone first attempted to measure the parallax of a star. Straightforward Greek geometry made it abundantly clear that the distance between the stars was measured in light years. Even though the Ionians will have to use this alternative technique at some point in the future, there is another method for determining the distance to the stars that they could discover. It is common knowledge that things appear more diminutive when viewed from a greater distance. Perspective is an artistic and photographic technique based on the inverse proportionality between apparent size and distance. Therefore, the further away we are from the sun, the more diminished in size and brightness it appears to be. How far away would we have to be from the sun before it would appear as if it were a star in both size and brightness? Or would an equal piece of the sunshine with the same intensity as a star? To investigate this question, Christian Huygens carried out an early experiment that was very much in the Ionian tradition. After drilling a few holes in a brass plate, Huygens held the plate up to the sun and questioned it himself about which hole appeared as bright as he recalled the brilliant star, Sirius, to have been the previous night. The hole was approximately 1/5 of 1/800,000th of the sun's apparent size. Therefore, according to his reasoning, Sirius must be 28,000 times farther from us than the Sun, equivalent to approximately half a light year. After looking at a star for many hours, it is difficult to remember how bright it was, but Huygens could recall the information very accurately. If he had known that Sirius had a higher intrinsic brightness than the Sun, he would have been able to find an almost perfect answer. The distance between Sirius and the Sun is 8.8 light years. It hardly makes a difference that Aristarchus and Huygens utilized imprecise data and derived imperfect answers from their research. They provided such a detailed explanation of their procedures that it became possible to derive more precise answers as more accurate observations became available. The question, "What are the stars?" fascinated me as a young boy growing up in Brooklyn. Between the time of Aristarchus and Huygens, humans provided an answer to this riddle. The answer is that the stars are enormous suns located in interstellar space and separated by light years. The most important thing we can take away from Aristarchus is the realization that neither we nor our planet occupies a special place in the natural order. This realization has since been used downward to the planets and upward to the stars and sideways to many different subsets of the human family, with a great deal of success, but always against it. It is responsible for significant advancements in astronomy, physics, biology, anthropology, economics, and politics. Is the widespread social implications of it one of the primary motivations behind efforts to suppress it? The influence of Aristarchus's legacy can be felt well beyond the scope of the astronomical realm. William Herschel, a musician and astronomer to George III of England, finished a project to map the starry skies at the end of the 18th century. He discovered what appeared to be equal numbers of stars in all directions in the plane or band of the Milky Way. Reasonably, he deduced that we were at the galaxy's center. In the months leading up to World War I, a man from Missouri named Harlow Shapley developed a method for determining the distances to globular clusters, which are beautiful spherical arrays of stars that look like a swarm of bees. A star that was noticeable due to its variability but always had the same average intrinsic brightness was the stellar standard candle that Shapley had discovered. In the same way that we can estimate the distance to a lantern of known intrinsic brightness based on the feeble light that reaches us in a field, Shapley was able to calculate how far away these stars are by comparing the dimness of these stars when they were discovered in globular clusters with their actual brightness, as determined by nearby representatives. This is, in a sense, the method that Huygens developed. Shapley discovered that the globular clusters were not centered around the solar neighborhood, but rather about a distant region of the Milky Way, in the direction of the constellation Sagittarius, also known as the Archer. It seemed to him that there was a strong possibility that the nearly 100 globular clusters used in this investigation would somehow revolve around the Milky Way's enormous barycenter and pay homage to it. In 1915, Shapley mustered the bravery to suggest that our solar system was located on the periphery of our galaxy rather than near its center. Herschel had been led astray due to the copious amount of dust that obscured his view in the direction of Sagittarius. He was unaware of the enormous number of stars that lay beyond. It is now very clear that we live approximately 30,000 light-years from the galaxy's center, on the outskirts of a spiral arm, in a region with a relatively low density of stars. Some may inhabit a planet located in the core of the globular cluster, or one that orbits a central star in one of Shapley's globular clusters. These beings might feel sorry for us because we only have a few stars visible to the naked eye, while their skies will be ablaze with stars. In comparison to the meager few thousand stars that can be seen from Earth, there would be millions of brilliant stars visible near the center of the Milky Way galaxy. Even if the sun went down, we would never experience nighttime. Although, in the 18th century, Thomas Wright of Durban and Immanuel Kant of Königsberg each had a premonition that the exquisite luminous spiral forms viewed through the telescope were other galaxies, astronomers believed that there was only one galaxy in the cosmos, and that galaxy was the Milky Way. This belief persisted well into the 20th century. Kant made the explicit suggestion that the galaxy M31, which is located in the constellation Andromeda, is an additional Milky Way which is made up of an enormous number of stars, and he proposed calling such objects by the evocative and haunting phrase island universes. Some researchers entertained the notion that the spiral nebulae were not isolated universes in the far reaches of space, but rather nearby interstellar gas clouds that were condensing and possibly on the verge of forming solar systems. To determine how far apart the spiral nebulae are, a class of intrinsically much brighter variable stars was required to serve as a new standard candle. Such stars were discovered to be alarmingly dim in M31 by Edwin Hubble in the year 1924. It became apparent that M31 was located at a prodigious distance, now estimated to be slightly more than 2 million light-years. But for M31 to be located at such a great distance, it can't be a cloud of mere interstellar dimensions. Instead, it must be much larger, and, in its own right, an enormous galaxy. And the other, less bright galaxies must be even further away than that. 100 billion of them must be strewn across the darkness to the edges of the known universe. Since the beginning of human history, we have pondered where we fit into the greater cosmos. Where are we right now? Since the beginning of our species, when our ancestors occasionally looked up at the stars for no apparent reason, among the Ionian scientists of ancient Greece and even in our own time, this topic has fascinated us. Who exactly are we? We discover that we live on an insignificant planet that orbits a humdrum star that is lost between two spiral arms on the outskirts of a galaxy. This galaxy is a member of a sparse cluster of galaxies tucked away in some forgotten corner of a universe where there are far more galaxies than people. This viewpoint is a brave continuation of our propensity for constructing and testing mental models of the skies, and it depicts the sun as a crimson hot stone, the stars as celestial flames, and the galaxy as the backbone of night. Since Aristarchus, each new stage we have traversed in our quest has brought us further and further away from the center of the cosmic drama. More time is required to properly digest all of these recent discoveries. The discoveries that Shapley and Hubble made occurred during the lifetimes of a great number of people who are still alive today. In their hearts are those who still pine for a universe in which the Earth serves as the century, focus, and fulcrum. Some people privately deplore these great discoveries, view every step as a demotion, and consider every step a demotion. However, to interact with the cosmos, we must first understand it. This is true, even if it dashes our hopes of achieving some undeservedly privileged position. A necessary first step towards bettering the neighborhood is to understand the area in which we live. It is helpful to have knowledge of the characteristics of other neighborhoods as well. If we want our planet to be recognized as having significance, there is something that we can do to make that happen. The boldness of our inquiries and the comprehensiveness of our responses give our world its significance. We began our exploration of the cosmos with the question, what are the stars? This question has been asked since the dawn of our species and is passed down from generation to generation with the same sense of awe and curiosity. The spirit of discovery resides within each of us. We started out as nomads, and to this day we still consider ourselves nomads. We have lingered on the outskirts of the universe's vast ocean for far too long. At long last, everything is in place for us to set sail for the heavens. Both the moon and the sun are located at a great distance. However, their gravitational influence is real and can be felt here on Earth where they originated. The beach brings to mind the vastness of space. After aeons of jostling, rubbing, abrasion and erosion, fine sand grains, which are more or less uniform, have been produced from larger rocks. This process has been driven by waves and weather for a long time, so the moon and the sun are far away. The beach also causes us to reflect on the passage of time. The age of the world predates that of the human species by a significant margin. The number of grains in a handful of sand is approximately 10,000, greater than the number of stars seen with the naked eye on a dark night. However, the number of stars visible to the human eye represents only a minute portion of the total number of stars. We can only make out a sparse scattering of the stars closest to us at night. In the meantime, the wealth of the cosmos is unfathomable. The total number of stars in the universe is greater than the sum of all the grains of sand found on Earth's beaches combined. A constellation is an arbitrary grouping of stars composed of intrinsically dim stars that seem bright because they are nearby and intrinsically brighter stars that are somewhat more distant from us. Despite the efforts of ancient astronomers and astrologers to put pictures in the skies, a constellation is nothing more than an arbitrary grouping of stars. To a high degree of accuracy, no 2 points on Earth are located at a different distance from any stars. Because of this, the patterns of the stars within a particular constellation do not change even if we travel from Soviet Central Asia to the Midwest in the United States. In astronomical terms, the United States of America and the Soviet Union correspond to the same location. The stars that make up any constellation are all located so far away from Earth that we can never comprehend them as a three-dimensional arrangement for as long as we are rooted here. A light year is approximately 10 trillion kilometers long. As a reminder, the average distance between the stars is only a few light years. We must travel over distances comparable to those that separate the stars. More specifically, we must venture across the light years for the patterns of the constellations to shift. After that, it will appear that some nearby stars have moved out of the constellation while others have moved in, and the overall arrangement of the constellation will change dramatically. Our technology is yet to be capable of undertaking such massive interstellar journeys, at least not within a time frame that is considered reasonable. But our computers can be taught the three-dimensional positions of all of the nearby stars, and we can ask to be taken on a little trip, for example, a circumnavigation of the collection of bright stars that constitute the Big Dipper, and watch the constellations change before our very eyes. Follow the dots drawings of the night sky typically connect the stars that make up various constellations. As we shift our position, we can see that the apparent shapes of the objects are being severely warped. The people who live on the planets that orbit around faraway stars see very different constellations in the night sky than we do here on Earth. Their night skies are like Rorschach tests for other people's minds. Someday in the next few centuries, a spaceship from Earth may travel such vast distances at some remarkable speed and see new constellations that no human has ever seen, except with a computer like this one. The appearance of the constellations shifts not only in space but also in time. This occurs not only when we move to a new location but also when we wait for a long enough period. There are times when the stars move as a group or cluster, and other times when a single star may move relatively quickly compared to its neighbors. These stars eventually move on to a new constellation, leaving behind the one they were previously a part of. If one of the stars in a binary star system were to explode, it would free the other star from the gravitational bonds that held them together. The freed star would then launch into space at the same speed as its previous orbit, creating an effect similar to a catapult in the sky. In addition, stars are born, progress, and eventually expire. If we wait long enough, we will see new stars appear while the old ones disappear. The patterns in the sky are gradually dissolving and shifting. Even during the brief existence of the human species, which spans only a few million years, ideas have been evolving. Consider the current arrangement of the Great Bear or the Big Dipper. Our computers can also transport us through time as well as space. When we run the Big Dipper backwards into the past, taking into account the movement of its stars, we find that its appearance was quite different a million years ago. During that time, the Big Dipper appeared shaped like a spear. If you somehow found yourself transported back to an unknown era in the distant past, you could determine the epoch by observing the constellations in the sky. For example, if the Big Dipper is shaped like a spear, you are in the Middle Pleistocene. We can also request that the computer move a constellation forward in time. Take the sign of Leo the Lion. The zodiac is a band of 12 constellations that wrap around the sky in the sun's apparent annual path as it travels through the heavens. The belief that the zodiacal constellations such as Leo are primarily animals is where the word zoo comes from. Even a million years from now, the constellation Leo will not resemble a lion nearly as much as it does now. Our distant descendants may refer to it as the constellation of the radio telescope. But in a million years, the radio telescope will be as archaic as the stone spear. 4 prominent stars frame the non-zodiacal constellation of Orion, the Hunter, and a diagonal line of 3 stars represents the Hunter's belt. The 3 stars that are fainter than the others and hang from Orion's belt are what the traditional astronomical projective test identifies as the Sword of Orion. Stars are formed in large clouds of gas known as nebulae, such as the one in the Orion constellation, which can be seen as the middle star in the sword. The constellation Orion contains a large number of young and hot stars, many of which are in the process of rapidly evolving into supernovae as their lives come to an end. They have a lifespan of tens of millions of years during which they are born and die. If we were to run Orion quickly into the distant future on our computer, we would see a startling effect: the births and spectacular deaths of many of its stars, which would light up and go out like fireflies in the night. Within the solar neighborhood, also known as the immediate surroundings of the Sun in space, one can find the star system Alpha Centauri, which is the closest to the Sun. It is a triple system consisting of 2 stars that revolve around each other and a third star, Proxima Centauri, that orbits the first 2 at a distance that is not easily discernible. The name Proxima comes from the fact that the star is closest to the Sun at certain points in its orbit. Most stars in the night sky are part of double or multiple star systems. Our solitary Sun is a peculiarity in the cosmos. Beta Andromeda is the second brightest star in the constellation Andromeda, located 75 light-years away. On its way to Earth, the light that reveals it to us now has traveled through interstellar space for 75 years, during which time it has been invisible to us. In the highly improbable event that Beta Andromeda blew itself up on Tuesday, we would not know about it for another 75 years. This is because information traveling at the speed of light takes 75 years to traverse the enormous interstellar distances between the stars. When the light that we now see from this star began its long journey, a young Albert Einstein was beginning his career as a patent clerk in Switzerland. On Earth, he had recently published his seminal work, The Special Theory of Relativity. The fabric of space and time is woven together. When we want to look back in time, we must look back into space first. Light travels at an extremely rapid speed. However, space is empty, and the distance between the stars is great. Compared to other astronomical distances, a distance of 75 light-years or less is relatively short. It is approximately 30,000 light-years from the Sun to the galactic core of the Milky Way galaxy. It is approximately 2,000 light-years from our galaxy to the nearest spiral galaxy, M31, in the constellation Andromeda. When the light that reached Earth from M31, which we see today, first arrived, there were no humans on our planet. However, our ancestors rapidly evolved into the form we have today. It takes 8 or 10 billion years for light to travel from Earth to the most distant quasars in the universe. We can see them as evidence that the Earth accumulated more material before the Milky Way. This circumstance is not unique to astronomical objects. However, because only astronomical objects are so distant, the importance of the limited speed of light becomes apparent in this context. When you look at a friend who is across the room and 3 meters 10 feet away, you do not see her as she is now, but rather as she was 100 millionths of a second ago. To determine the travel time, we divided the total distance by the average speed used in this calculation. However, the difference between now and now minus 100 millionth of a second is so minute that it is impossible to distinguish between them. When we look at a quasar that is 8 billion light-years away, the fact that we are seeing it as it was 8 billion years ago may be very significant. For instance, some believe that quasars are explosive events that are only likely to occur early in the history of galaxies. If this is the case, the further away the galaxy is, the earlier in its history we can observe it, and the more likely we will see it as a quasar. In fact, if we look at distances greater than 5 billion light-years, we will see an increase in the number of quasars. The two Voyager interstellar spacecraft, which are currently traveling at 1/10 the speed of light, are the most powerful machines that have ever been launched from Earth. They would have to travel a distance equivalent to that of the nearest star, which would take 40,000 years. Do we have any plans to leave Earth and travel the vast distances all the way to Proxima Centauri in a reasonable amount of time? Is there anything we can do to get closer to the speed of light? What exactly makes the speed of light so magical? We are capable of going much faster than that. If you had strolled through the bucolic countryside of Tuscany in the 1890s, you might have run into a long-haired adolescent who had dropped out of high school while traveling to Pavia. His teachers in Germany had warned him that he would never amount to anything, that his questions were disruptive to classroom discipline, and that he would be better off dropping out of school altogether. Therefore, he up and left, taking pleasure in the independence of northern Italy, where he could ruminate on topics completely unrelated to the topics he had been coerced into learning in his highly structured Prussian classroom. His name was Albert Einstein, and his musings were responsible for the revolution in the world. Bernstein's People's Book of Natural Science was a popularization of science that described on its first page the astounding speed at which electricity travels through wires and light travels through space. This book profoundly impacted Einstein, who was captivated by it. He pondered the possibilities of what the world would be like if it could travel on waves of light, achieving and maintaining travel at the speed of light. What an interesting and entrancing thought it must have been for a young boy to have while walking along a road in the countryside where the sunlight was dappled and rippled. If you traveled with a light wave, there was no way to tell if you were actually riding one. If you began your journey on the highest point of a wave, you would remain there and eventually forget that you were even riding a wave. When traveling at the speed of light, a strange phenomenon takes place. The more Albert Einstein contemplated such questions, the more unsettling he found them. If you could travel at the speed of light, paradoxes would pop up everywhere you went. Without consideration, a few ideas were taken at face value and treated as facts. Einstein's questions were straightforward and could have been asked many decades earlier. For instance, when we say that two events are occurring simultaneously, what exactly do we mean by that? Imagine that I am coming towards you on a bicycle right now. As I approach the intersection, I come dangerously close to hitting a horse-drawn cart. I have to swerve to avoid getting run over, but just barely. Now think about the event again, but this time, imagine that the cart and the bicycle are moving at speeds approaching the speed of light. If you are standing at the edge of the road, you will notice that the cart moves perpendicular to the direction in which you are looking. You can tell I'm approaching you because the sunlight reflects off me. Would the sum of my speed and the speed of light be sufficient to ensure that the image of me reaches you a significant amount of time before the image of the cart? Should I see you make a sharp turn once you spot the delivery cart coming? From my vantage point, the cart and I should be able to approach the intersection simultaneously. But this might not be possible from your perspective. Could I come dangerously close to colliding with the cart while you watched me veer around nothing and continue to pedal merrily in the direction of the town of Vinci? These are interesting questions with a lot of nuance. They challenge what is already known. There is a good explanation for why no one considered them before Einstein. Einstein produced a fundamental rethinking of the world and a revolution in physics from such simple questions. There are some rules or commandments of nature that must be obeyed for the world to be comprehended, and if we are to avoid such logical paradoxes when traveling at high speeds, we must adhere to certain guidelines. These guidelines were formalized by Einstein in the form of the special theory of relativity. Whether an object is moving or not, the speed at which light, either reflected or emitted, travels from it remains the same. The speed of light is not to be increased by adding your own speed. Additionally, no material object may move faster than the speed of light. Thou shalt not travel at or beyond the speed of light. This commandment also applies to travel. Nothing in the laws of physics would prevent you from traveling as close to the speed of light as you like. Traveling at 99.9% of the speed of light would be fine. However, regardless of how diligently you work, you will never be able to acquire that final decimal point. There must be a cosmic speed limit for the world to make sense from a logical standpoint. If not, you could achieve any desired speed by adding velocity to a moving platform. Around the turn of the century, many Europeans believed they had privileged frames of reference. They believed that German, French, or British culture and political organization were superior to those of other countries. They also believed that Europeans were superior to other people who had the good fortune to be colonized. Their contemporaries disregarded or ignored the social and political application of Aristarchus and Copernicus's ideas. Albert Einstein fought against the idea of privileged frames of reference in politics and physics when he was young. No place could be considered at rest, and no perspective on the cosmos was superior to any other perspective. This was because the universe was filled with stars moving in all different directions at breakneck speeds. This is the definition of the concept known as relativity. Despite its mystical overtones, the concept at its core is quite straightforward. When viewed from the universe's perspective, every location is on par with every other location. Regardless of who is describing it, one thing is certain. The laws of nature are always the same. If this is the case, and it would be incredible if there was something unique about our inconsequential location in the universe, then it follows that no one can travel faster than the speed of light. This is because light has a finite speed. It is possible to hear the crack of a bullwhip because the whip's tip is moving at a speed greater than the speed of sound. This results in the creation of a shockwave as well as a small sonic boom. The origin of a thunderclap is very similar. It was once believed that aeroplanes could not fly at a speed greater than the speed of sound. It is now common practice to travel at a speed greater than sound. On the other hand, the light barrier is not the same as the sound barrier. It is not merely an issue of engineering, such as the problem that the supersonic aeroplane helps to resolve. It is a basic rule of nature, on the same level as the law of gravity. In addition, there are no phenomena that we have encountered in our lives, such as the snap of a bullwhip or the clap of thunder for sound, that point to the possibility of moving through a vacuum at a speed greater than the speed of light. On the other hand, there is an extensive range of experience in precise quantitative agreement with special relativity. Some examples of this kind of experience include nuclear accelerators and atomic clocks. Because sound is transmitted through some material medium, typically air, the simultaneity problems only apply to sound to a much lesser extent than they do to light. When a close friend speaks to you, you feel the motion of the air molecules. Light, on the other hand, can travel through empty space. In a vacuum, the free movement of molecules of air is not constrained in the same way that it is in an atmosphere. We can receive light from the sun despite the vast distance that separates us from it. However, no matter how carefully we listen, we cannot hear the crackling of sunspots or the rumbling of solar flares. Before the theory of relativity was developed, people believed that light traveled through a unique medium present throughout all of space and was referred to as the luminiferous ether. On the other hand, the well-known Michelson-Morley experiment provided conclusive evidence that there is no such thing as the ether. Rumors have been that certain things can move faster than light. The concept of the speed of thought is brought up in conversation occasionally. This is a ridiculous idea, especially when one considers that the speed at which impulses travel through the neurons in our brains is roughly comparable to that of a cart. The fact that humans are smart enough to come up with relativity proves that we think well, but I do not believe we can take pride in our ability to think quickly. However, the electrical impulses that make up today's computers travel at a speed very close to light. The theory of special relativity, which Einstein finished developing in his middle 20s, has been supported by every experiment that has been carried out to verify it. Someone will come up with a theory tomorrow that explains everything we already know, is consistent with everything we already know, avoids privileged reference frames, and makes it possible to travel faster than light. Someone will come up with this theory, but I have serious doubts about that. Our common sense and Einstein's prohibition against traveling faster than the speed of light are incompatible. But why should we put our faith in common sense regarding this issue? Why should the laws of nature be constrained by our experience traveling at 300,000 kilometers per second when we only travel at 10 kilometers per hour? The theory of relativity places restrictions on the capabilities of humans. However, it is optional for the universe to be completely harmonious with the aspirations of humans. The theory of special relativity makes it impossible for us to build a spaceship capable of traveling faster than the speed of light. This tantalizing evidence hints at an additional approach that is not expected. Let's follow in the footsteps of George Gamow and imagine a world in which the speed of light is not its actual value of 300,000 kilometers per second, but rather something much more modest, like 40 kilometers per hour, and this speed is strictly enforced. Because there are no crimes or penalties for breaking the laws of nature, nature is self-regulating and merely arranges things so that its prohibitions are impossible to violate. Imagine riding a motor scooter and getting closer and closer to the speed of light. There are a lot of sentences in relativity that start with the word imagine. Einstein referred to this type of activity as a Gedanken experiment, which literally translates to thought experiment. As your speed increases, you will eventually be able to see around the corners of objects moving past you. When you are fixedly facing forward, things behind you will appear in your field of vision when you are looking forward. From your vantage point, the world appears very strange when you travel close to the speed of light. Eventually, everything appears to be crammed into a small circular window just in front of you. When viewed from the perspective of a stationary observer, the light reflected off you turns blue when you return and red when you depart. Your normally invisible infrared emission will be shifted to the shorter wavelengths associated with visible light if you move towards the observer at almost the speed of light. As you move closer to the observer, this will cause an eerie chromatic radiance to envelop you. The breathtaking effect of traveling near the speed of light is called time dilation. When you travel close to the speed of light, you become compressed in the direction of motion. Your mass increases, and the passage of time slows down as you experience it. But when viewed from the perspective of an observer moving alongside you, perhaps there is a second seat on the scooter, none of these effects are seen to take place. These odd and puzzling predictions of special relativity are true, but only in the most fundamental sense that anything in science can be true. They are dependent on the relative motion of you and the object. However, they are not optical illusions. They exist in the world. Because they can be demonstrated with elementary mathematics, primarily algebra, from the first year on, any educated person should be able to comprehend them easily. They are also in agreement with the results of many different experiments. When compared to clocks that are kept in stationary locations, timepieces that are carried on aeroplanes are less accurate. Accelerated particles would collide with the walls of the apparatus if nuclear accelerators were not constructed to allow for an increase in mass in conjunction with an increase in speed. If nuclear accelerators were constructed differently, there would be more room for experimentation in nuclear physics. To calculate speed, divide the distance traveled by the amount of time. Because it is not possible to add speeds near the velocity of light, as it is something that we are used to doing in the working world, it is necessary to abandon the common conceptions of absolute space and time, which are independent of your relative motion. Because of this, you contract. This is the cause of a slowing of the passage of time. If you traveled at the speed of light, you would hardly age, but your friends and relatives who remained on Earth would continue to age at the typical rate. What a striking contrast there would be between you and your friends when you returned from your relativistic journey. For example, they might have aged several decades while you would have barely changed at all. An elixir of life is traveling at the speed of light. The theory of special relativity enables us to travel to the stars thanks to the fact that time passes more slowly as we get closer to the speed of light. To what extent, however, does the realm of practical engineering permit the possibility of approaching the speed of light? Is it possible to build a starship? Tuscany was not only the incubator of some of the thinking of the young Albert Einstein, but also the home of another great genius who lived 400 years earlier, Leonardo da Vinci. Leonardo da Vinci was delighted to climb the Tuscan hills and view the ground from a great height as if soaring like a bird. This made him imagine he was soaring through the air like a bird. He is credited with producing the earliest drawings of landscapes, towns, and fortifications, as seen above. In addition to the wide range of fields in which Leonardo was interested and successful, such as painting, sculpture, anatomy, geology, natural history, military engineering, and civil engineering, he was driven by a strong desire to design and build a machine capable of flight. He tried to draw pictures, make models, and even build full-size prototypes, but his ideas were unsuccessful. There was no engine available at the time that was both sufficiently powerful and lightweight. On the other hand, the designs were exceptionally clever and inspired future engineers. Leonardo's mood suffered as a result of these setbacks. However, it was not at all his fault. He found himself unable to escape the 15th century. A similar situation occurred in 1939 when a group of engineers known as the British Interplanetary Society designed a ship that would use technology from that year to transport people to the moon. It was in no way similar to the design of the Apollo spacecraft, which successfully completed this mission 30 years later, but it did suggest that an expedition to the moon might one day be a feasible engineering possibility. At this time, we have preliminary designs for ships that will transport people to other star systems. It is only assumed that these spacecraft will indirectly depart the planet. Instead, they are built in orbit around the Earth, and from there they embark on their lengthy journeys through interstellar space. One of them was given the name Project Orion, derived from the name of a constellation. This was a constant reminder that the ship's ultimate destination was among the stars. Each explosion served as a sort of put-put, a scissable nuclear motorboat in space that Orion intended to use the explosions of nuclear weapons. And these odd and puzzling predictions of special relativity are true, but only in the most fundamental sense that anything in science can be true. They are dependent on the relative motion of you and the object. However, they are not optical illusions. They exist in the world. Because they can be demonstrated with elementary mathematics, primarily algebra, from the first year on, any educated person should be able to comprehend them easily. They are also in agreement with the results of many different experiments. When compared to clocks that are kept in stationary locations, timepieces that are carried on aeroplanes are less accurate. Accelerated particles would collide with the walls of the apparatus if nuclear accelerators were not constructed to allow for an increase in mass in conjunction with an increase in speed. If nuclear accelerators were constructed differently, there would be more room for experimentation in nuclear physics. To calculate speed, divide the distance traveled by the amount of time. Because it is not possible to add speeds near the velocity of light, as it is something that we are used to doing in the working world, it is necessary to abandon the common conceptions of absolute space and time, which are independent of your relative motion. Because of this, you contract. This is the cause of a slowing of the passage of time. If you traveled at the speed of light, you would hardly age, but your friends and relatives who remained on Earth would continue to age at the typical rate. What a striking contrast there would be between you and your friends when you returned from your relativistic journey. For example, they might have aged several decades while you would have barely changed at all. An elixir of life is traveling at the speed of light. The theory of special relativity enables us to travel to the stars thanks to the fact that time passes more slowly as we get closer to the speed of light. To what extent, however, does the realm of practical engineering permit the possibility of approaching the speed of light? Is it possible to build a starship? Tuscany was not only the incubator of some of the thinking of the young Albert Einstein, but also the home of another great genius who lived 400 years earlier, Leonardo da Vinci. Leonardo da Vinci was delighted to climb the Tuscan hills and view the ground from a great height as if soaring like a bird. This made him imagine he was soaring through the air like a bird. He is credited with producing the earliest drawings of landscapes, towns, and fortifications, as seen above. In addition to the wide range of fields in which Leonardo was interested and successful, such as painting, sculpture, anatomy, geology, natural history, military engineering, and civil engineering, he was driven by a strong desire to design and build a machine capable of flight. He tried to draw pictures, make models, and even build full-size prototypes, but his ideas were unsuccessful. There was no engine available at the time that was both sufficiently powerful and lightweight. On the other hand, the designs were exceptionally clever and inspired future engineers. Leonardo's mood suffered as a result of these setbacks. However, it was not at all his fault. He found himself unable to escape the 15th century. A similar situation occurred in 1939 when a group of engineers known as the British Interplanetary Society designed a ship that would use technology from that year to transport people to the moon. It was in no way similar to the design of the Apollo spacecraft, which successfully completed this mission 30 years later, but it did suggest that an expedition to the moon might one day be a feasible engineering possibility. At this time, we have preliminary designs for ships that will transport people to other star systems. It is only assumed that these spacecraft will indirectly depart the planet. Instead, they are built in orbit around the Earth, and from there, they embark on their lengthy journeys through interstellar space. One of them was given the name Project Orion, derived from the name of a constellation. This was a constant reminder that the ship's ultimate destination was among the stars. Each explosion served as a sort of put-put, a scissable nuclear motorboat in space that Orion intended to use the explosions of nuclear weapons, and only in the vast emptiness of interplanetary or interstellar space would it have been possible to produce the vast quantities of radioactive debris that it was predestined to produce due to its design characteristics. Before the United States and other nations signed an international treaty prohibiting the detonation of nuclear weapons in space, the United States was making significant progress on the Orion project. What a terrible shame this is. The Orion starship is the most effective application of nuclear weapons. The British Interplanetary Society has been working hard on a new concept called Project Daedalus. It presupposes the existence of a nuclear fusion reactor which would be considerably less dangerous and more effective than the fission power plants that are currently in operation. Fusion reactors still need to be created, but their development is widely anticipated to occur within the next few decades. Orion and Daedalus may travel at a speed equivalent to 10% of the speed of light. Less than a human lifetime would be required to journey to Alpha Centauri, located 4.3 light-years away. The trip would take 43 years. These vessels could never get close enough to the speed of light for the effects of special relativistic time dilation to be noticeable. Even if we make optimistic projections about how quickly our technology will advance, it does not appear likely that Orion, Daedalus, or other ships of their kind will be constructed before the middle of the 21st century. However, we could already construct Orion if we so desired. Something else is required for journeys beyond the stars in the immediate vicinity. It was possible to use the Orion and the Daedalus as multi-generational ships, which means that the people who eventually arrived at a planet orbiting another star could be the distant descendants of those who had set out on the journey centuries earlier. Or scientists will devise a foolproof method of human hibernation, allowing individuals to be preserved in liquid nitrogen and brought back to life hundreds of years later. Compared to starships that travel close to the speed of light, these non-relativistic starships are simpler in design, construction, and operation, although they would have enormously high costs. Humans can travel to other star systems, but doing so will require significant effort. It is not an objective for the next 100 years, but rather for the next 1,000 or 10,000 to achieve rapid interstellar travel, with the ship's velocity approaching the speed of light. However, this could happen in theory. There has been some discussion regarding the possibility of an interstellar ramjet. The diffuse matter, primarily made up of hydrogen atoms and floating between the stars, is sucked up by R.W. Bussard, accelerated inside a fusion engine, and expelled out the back of the ship. The hydrogen would be used as both a fuel and a reaction mass. However, in the vacuum of deep space, there is only about 1 atom for every 10 cubic centimeters, equivalent to a grape's volume. A frontal scoop that is hundreds of kilometers across is required for the ramjet to function properly. When the ship reaches relativistic speeds, the hydrogen atoms will move towards the spaceship at the speed of light, which will cause them to collide with the ship. These artificially produced cosmic rays have the potential to incinerate both the spaceship and its occupants if adequate safety measures are not taken. One solution that has been proposed uses a laser to remove the electrons from the interstellar atoms, thereby causing them to become electrically charged while they are still quite a distance away. This is followed by applying an extremely powerful magnetic field, which directs the electrically charged atoms into the scoop and away from the rest of the spacecraft. This represents engineering on a scale that has never been seen on Earth. When we talk about engines, we're talking about the size of small worlds. But before we move on, let's consider what such a ship would be like. When we fall towards the ground, we feel the force of the Earth's gravitational attraction, which manifests as acceleration in our bodies. If we were to fall out of a tree, as many of our proto-human ancestors must have done, our rate of descent would increase by 10 meters, or 32 feet per second for every second that passed. This would cause our fall to be exponentially more dangerous. This acceleration, which exemplifies the gravitational pull that keeps us rooted to the Earth's surface, is referred to as 1g for the Earth's gravity. We feel perfectly at ease with accelerations of 1g because we have spent our entire lives accustomed to 1g. If we lived in an interstellar spacecraft that could accelerate at 1g, we would be in an environment completely unaltered from its natural state. One of the most important aspects of Einstein's later general theory of relativity is the equivalence between gravitational forces and the forces we would feel in an accelerating spaceship. If we maintain a constant acceleration of 1g throughout our time in space, we will approach the speed of light after 1 year. Suppose that such a spacecraft begins its journey traveling at a speed of 1g, gradually getting closer and closer to the speed of light until it reaches the halfway point of its journey, at which point it is turned around and begins traveling at a speed of 1g in the opposite direction until it reaches its final destination. Most of the journey would be completed at speeds exceeding the speed of light, resulting in a significant slowdown with time. Barnard's star, located approximately 6 light-years away, is a mission objective that is relatively close by, and a sun that may have planets. According to the clocks on board the vessel, it could be reached in approximately 8 years. The center of the Milky Way galaxy could be reached in 21 years, and the Andromeda galaxy could be reached in 28 years. People who remained on Earth would, of course, have a unique perspective on the events. They would calculate an elapsed time of 30,000 years to reach the galaxy's center rather than the standard 21 years. When we arrived home, a few of our close friends would await us there. In theory, such a journey would allow us to circumnavigate the known universe in about 56 years of ship time. This would be possible because we would get closer to the speed of light as we increase the decimal points. If we traveled tens of billions of years into the future, we would find that the sun has died and the Earth has been reduced to cinders. Traveling through space at relativistic speeds makes the universe accessible to more advanced civilizations, but only to those civilizations currently on their way there. No mechanism would allow information to travel back to those left behind at a rate greater than the speed of light. Likely, the designs for Orion, Daedalus and the Bussard ramjet are further removed from the actual interstellar spacecraft that we will one day construct than Leonardo's models are from the supersonic transports that are in use today. However, if we do not destroy ourselves, we will eventually travel to the stars. When the planets in our solar system have been thoroughly explored, humans will turn their attention to the planets orbiting other stars. The ability to travel through time and space is connected. We can only rapidly travel into space if we simultaneously rapidly travel into the future. But what about things in the past? Can we make changes to what happened in the past? Could we alter the course of events so they didn't turn out like the history books say they did? We move forward gradually, one day at a time, every single day. We could travel through time much more quickly if we had relativistic space travel. On the other hand, many physicists think that traveling through time is impossible. They claim that even if you had a machine that allowed you to go back in time, you still wouldn't be able to change anything about the outcome of the situation in any way that would be significant. You are a contradiction because it is obvious that you already exist. After all, you cannot have been born if you went back and stopped your parents from getting together. This is an argument in which the premise is challenged because the conclusion seems absurd. It is similar to the proof of the irrationality of the square root of 2 and the discussion of simultaneity in special relativity. However, other physicists believe that two alternate realities could coexist, each of which is a reality in its own right. These realities are the one in which you were born and the one in which you were never born. Even though we can only ever experience one dimension of time, time may have many possible manifestations. Imagine for a moment that you could travel through time and alter it. For instance, you could talk Queen Isabella out of her support for Christopher Columbus. If this were the case, one line of reasoning goes, you would have started a new chain of historical occurrences, which the people you left behind in our timeline would have no way of knowing about. If this method of time travel were feasible, then every alternative history that can be conceived of would be a possibility. The majority of what we know about history can be summed up as a convoluted mass of social, cultural, and economic forces that are difficult to disentangle from one another. Numerous, insignificant, unpredictable, and random occurrences that occur continuously and frequently do not have long-range consequences. However, those that take place at pivotal junctures or forks in the road have the potential to alter the overall trajectory of history. Some circumstances in which seemingly insignificant alterations can bring about significant results. The further back in time an occurrence occurs, the more likely its influence will be significant. This is because the lever arm of time increases as time passes. A polio virus is a very small microorganism. Every day we come into contact with a great number of them. Thankfully, only one of them infrequently infects a single one of us, which causes this terrible illness. Polio affected Franklin D. Roosevelt, who became the 32nd President of the United States during his time in office. As a result of the disease's incapacitating effects, Roosevelt may have developed greater compassion for those who were disadvantaged as a result of it, or perhaps he became more driven to achieve success. The Great Depression of the 1930s, World War II, and the development of nuclear weapons could have had very different outcomes if Franklin D. Roosevelt had a different personality or had never aspired to become President of the United States. The course of history will now be different. However, a virus is extremely insignificant, with a width of only 1/1,000,000th centimeter. It is not even close to being significant. On the other hand, let us assume that our time traveler successfully convinced Queen Isabella that Christopher Columbus's geography needed to be corrected and that, based on Eratosthenes' estimation of the circumference of the Earth, Columbus could never reach Asia. Within a few decades, additional Europeans would have arrived from Europe and sailed to the western part of the New World. Around 1500, the discovery of America was more or less inevitable due to advancements in navigational technology, the allure of the spice trade, and competition among rival European powers. Without European colonization in the Americas, there would be no nation of Columbia, no District of Columbia, no Columbus, Ohio, and no Columbia University. However, history's general direction might have remained the same. If a time traveler wanted to significantly impact the outcome of the future, they would have to alter the course of multiple events in the past at specific points in time. Exploring worlds that were never created makes for a lovely fantasy piece. By traveling there, we can better understand how history unfolds. This allows history to evolve into an experimental science. How different would the world be if a person who seems to have played a pivotal role in history had never lived, such as Plato, Paul, or Peter the Great? Imagine for a moment that the ancient Ionian Greeks' rich scientific heritage would have been able to flourish had it been preserved. That would have required many social forces to have been different during that period, including the prevalent belief that slavery was natural and appropriate. What if, instead of fading away after 2,500 years, the light that first appeared in the eastern Mediterranean region continued to shine? What if the scientific method, the dignity of crafts and the mechanical arts and the pursuit of scientific knowledge had been vigorously pursued 2,000 years before the advent of the Industrial Revolution? What if the potential of this fresh way of thinking had been recognized and appreciated by a greater number of people? There are times when I wonder if we have yet to beat back time by 10 or 20 centuries. Leonardo da Vinci's contributions would have been made 1,000 years ago, and Albert Einstein's would have been made 500 years ago. Leonardo da Vinci and Albert Einstein would never have existed on such a different version of Earth. Too many aspects of the situation would have been very different. There are hundreds of millions of sperm cells in every ejaculation. However, only one of these cells has the potential to fertilize an egg and give rise to a member of the next generation of human beings. However, the sperm successful in fertilizing an egg must be determined by the tiniest and least significant of several internal and external factors. If even a minor event that occurred 2,500 years ago had gone differently, none of us would be here today. If we had lived somewhere else, billions of other people would be here. If the Ionian spirit had prevailed, I believe that we, a different we, of course, would probably already be exploring the stars by this point. It's been a long since our first survey ships returned from Alpha Centauri, Barnard's Star, Sirius, and Tau Ceti. Large fleets of interstellar transports would be built in Earth's orbit, including uncrewed survey ships, liners for immigrants, and immense trading ships to traverse the seas of space. These ships would be able to travel to and from other star systems. These vessels would have glyphs and other forms of writing on board. If we looked more closely, we might have been able to tell that Greek was being used. On the prow of one of the earliest starships, perhaps a dodecahedron would be emblazoned with the inscription, "Starship Theodorus of the planet Earth." Things have progressed at a more glacial pace throughout our world's history. We are continuing to prepare for the arrival of the stars. However, in another century or two, when the entirety of the solar system has been mapped out, we will also have organized our planet. We will have the motivation, the resources, and the technical know-how to travel to other star systems. We will have investigated various other planetary systems from great distances, some comparable to ours, while others dissimilar to ours. We will be able to determine which stars to travel to. The children of Thales and Aristarchus, Leonardo and Einstein, will then skim across the light years, accompanied by our machines and their descendants. There appear to be many planetary systems, however, we still count them all. Jupiter, Saturn, and Uranus are the 3 planets closest to us out of the 4 in our solar system's neighborhood. Each possesses a moon system that closely resembles the planetary systems that orbit the Sun regarding the relative sizes of the moons and the spacing between them. The statistics of double stars, which can have masses very different from one another, can be extrapolated to suggest that almost all single stars, such as the Sun, should have planetary companions. Because their respective suns are so bright, we still need to be able to directly observe the planets that orbit other stars. However, we can recognize the gravitational effect of an unseen planet acting upon a known star. Imagine such a star that has a large proper motion, meaning that it is moving over decades against the backdrop of more distant constellations, and that it also has a large planet, say with the mass of Jupiter, whose orbital plane is aligned by chance to be perpendicular to our line of sight. This would make it appear that the planet is moving in the opposite direction of the star. When the dark planet is, from our vantage point to the right of the star will be pulled slightly to the right. On the other hand, when the planet is to the left of the star's path will be altered or perturbed from a straight line to a wavy one. Both of these effects can be seen from our vantage point. Barnard's star, the single star located closest to our solar system, is the one to which this gravitational perturbation method can be applied. The 3 stars that make up the Alpha Centauri system have such complicated relationships with one another that it would be difficult to find a low-mass companion there. Even for Barnard's star, the investigation has to be conducted with great care. It entails looking for minuscule shifts in position on photographic plates that have been exposed to the telescope for several years. According to some standards, 2 of these searches for planets around Barnard's star have been successful. This indicates the existence of 2 or 3 planets of Jovian mass moving in an orbit that, according to Kepler's third law, is closer to their star than Jupiter and Saturn are to the Sun. Both planets orbit their stars in a way consistent with Kepler's third law. However, unfortunately, the two different sets of observations are not compatible with one another. There is a possibility that a planetary system revolving around Barnard's star has been found, but definitive proof will require additional investigation. Other techniques for discovering planets in orbit around stars are being researched and developed. One of these techniques involves artificially occulting the illuminating light from the star, either by placing a disk in front of a space telescope or employing the Moon's dark edge as such a disk. After this, the reflected light from the planet, previously obscured by the intensity of the nearby star, becomes visible. We should have definitive answers to which of the nearest 100 stars have large planets in close orbit around them within the next few decades. Infrared observations have unearthed several pre-planetary disk-shaped clouds of gas and dust revolving around some of the nearby stars throughout the past few years. In the meantime, several thought-provoking theoretical studies have hinted that planetary systems are relatively common throughout the cosmos. Researchers have used computers to investigate the development of a flat, condensing disk of gas and dust, which is thought to be the precursor to the formation of stars and planets. Randomly distributed throughout the cloud, small clumps of matter, which represent the first condensations in the disk, are injected. The movement of the lumps causes the accumulation of dust particles. When they reach a certain size, they gravitate towards cloud gas, primarily hydrogen, which continues even after the cloud is no longer present. When two moving lumps come into contact with one another, the computer program causes them to become stuck. This process will continue until all the gas and dust used in this manner have been utilized. The outcomes are determined by the conditions at the beginning of the experiment, specifically the distribution of gas and dust density as a function of distance from the cloud's center. But generating planetary systems that are recognizably similar to our own is possible for various plausible initial conditions. These systems have approximately 10 planets, terrestrials close to the star and Jovians on the exterior. In other situations, there may not be any planets. Instead, there may be a scattering of asteroids. Alternatively, there may be Jovian planets near the star. Alternatively, a Jovian planet may amass enough gas and dust to transform into a star, which would be the beginning of a binary star system. It is still too early to say for certain, but a splendid variety of planetary systems is to be found throughout the galaxy. And with high frequency, we believe that all stars must have originated from such clouds of gas and dust. The galaxy may contain 100 billion undiscovered planetary systems just waiting to be explored. There won't be another world that's quite like ours. Few will be friendly, while most will project an unfriendly demeanor. There will be many that are breathtaking. On some worlds, the sky will be filled with many suns during the daytime, an abundance of moons during the nighttime, or enormous particle ring systems stretching from horizon to horizon. There will be moons so close to their planet that they will appear to loom large in the heavens and cover half of the sky. And the view from some worlds will be of a vast gaseous nebula, all left over from an ordinary star that used to be there but no longer is. The home star of the fleet of interstellar transports exploring this minuscule region of the vast Milky Way galaxy will be a dim yellow star. This star may be so faint that it is only visible through a telescope, or so faint that it is barely visible to the naked eye. Either way, it will be present in all those skies abundant in faraway and exotic constellations. As we've seen, the concepts of space and time are intricately intertwined. Just like people, worlds and stars are born, live their lives, and eventually pass away. The average human lifespan can be measured in decades, while the sun's age is measured in terms that are 100 million times greater. Mayflies are transient, ephemeral creatures that completed their entire life cycle in a single day, and that is how a star can be compared to youth. From the perspective of a mayfly, human beings appear to be unmoving, dull, and almost entirely immobile. They give almost no indication that they are ever engaged in any activity. A human being, when viewed from the perspective of a star, is nothing more than a minuscule flash. One of the billions of brief lives that are tenuously flickering on the surface of an unusually cold, anomalously solid, and exotically distant sphere of silicate and iron. On all those other planets in space, events are taking place right now that will significantly impact their destinies. This point in the history of our little planet is a historical branch point that is just as significant as the encounter between the Ionian scientists and the mystics that took place 2,500 years ago. What we do in this time with our world will propagate down through the centuries and powerfully determine the destiny of our descendants and their fate, if they have one, among the stars. Where did all of these atoms originate? All of them are made of stars, except hydrogen. Inside a star, hydrogen atoms are transformed into heavier atoms through cooking. A star can be thought of as a cosmic kitchen. Interstellar gas and dust, primarily composed of hydrogen, are where stars are formed. Hydrogen, on the other hand, was produced during the Big Bang, the explosion credited with starting the cosmos. You must develop the universe concept before making an apple pie from scratch. Suppose you cut an apple pie in half. Then, in the spirit of Democritus, you take one of the two pieces and cut it in half again. How many slashes do you have to make before you reach the level of an atom? The correct number is approximately 90 different cuts in succession. Naturally, no knife could be sharp enough, the pie would be too crumbly, and the atom would be too small to see without magnification. However, there is a solution to this problem. The nature of the atom was first comprehended during the 45 years centered on 1910 at Cambridge University in England. This was accomplished partly by firing pieces of atoms at other atoms and observing their deflection. The exterior of a typical atom is covered in something resembling a cloud of electrons. True to their name, electrons carry an electric charge within their bodies. The charge is referred to as negative for no particular reason. Electrons are responsible for determining the chemical properties of an atom, such as the icy texture of iron and the crystalline structure of a carbon diamond. The nucleus is typically made up of positively charged protons and electrically neutral neutrons, and it is located deep within the atom, far beneath the cloud of electrons. Atoms are tiny. If you line up 100 million of them, they wouldn't be much longer than the tip of your little finger. On the other hand, the nucleus is still 100,000 times smaller, which is one of the reasons why it took so much time to discover. Despite this, most of an atom's mass is located in its nucleus. The electrons are nothing more than clouds of moving fluff. The majority of an atom is composed of empty space. The vast majority of matter is made up of nothing. I am composed of individual atoms. My elbow, composed of atoms, rests on the table before me. Atoms have been used to construct the table. But if atoms are so tiny and empty, and nuclei are even smaller than that, how can the table keep me from falling through it? As Arthur Eddington liked to ponder, why are the nuclei that make up my elbow unable to pass through the nuclei that make up the table easily? How come I don't find myself on the ground, or plunge directly through the surface of the Earth? The electron cloud is the correct response. My elbow contains atoms with an outermost layer with a negative electrical charge. The same is true for each and every atom in the table. On the other hand, negative charges work to cancel each other out. The fact that atoms have electrons surrounding their nuclei and that electrical forces are strong is why my elbow does not slide through the table. The structure of the atom is essential to life as we know it. If you remove the atom's electrical charges, everything around you will disintegrate into an imperceptible powder. Without electrical forces, there would be nothing in the universe but diffuse clouds of electrons, protons, and neutrons and gravitating spheres of elementary particles. These featureless remnants of worlds would be all that would remain if there were no electrical forces. When we think about slicing an apple pie down to the level of a single atom and beyond, we are confronted with an infinite number of very small things. When we gaze into the depths of the night sky, we are confronted with an infinite expanse of the extremely massive. These infinities stand for a never-ending regression extending very far into the indefinite future. If you stand between two mirrors, say in a barbershop, you will see many different reflections of yourself. Each of these images is a reflection of the other. Because the mirrors are not perfectly flat and aligned, you cannot see infinite reflections. After all, because you are there, light cannot travel at an infinitely high speed through space. When we speak of infinity, we refer to a quantity greater than any number, regardless of how large the number may be. American mathematician Edward Kasner once asked his nephew, who was only 9 years old then, to name a number 10 times as powerful as 100 and consisted of 1 and 100 zeros. You too can imagine very large numbers and assign peculiar names to them. Could you test it out? It has a certain allure, particularly if you are 9 years old. If one Google seems like a lot, consider how many Googleplexes there are. It equals 10 to the power of a Google, which can also be written as a single number followed by a Google 0. Comparatively, the total number of atoms in your body is approximately 10 to the power of 28, and the total number of elementary particles in the observable universe is approximately 10 to the power of 80. Protons, neutrons, and electrons make up elementary particles. Even if all of the empty space in the universe were filled with neutrons, as an example, the total number of particles in the universe would still only amount to about 10^128. This is significantly more than a Google, but insignificantly less than a Googleplex. And yet these numbers, the Google and the Googleplex, do not even come close to approaching the concept of infinity. In fact, they are nowhere near it. The number 1 is the same distance away from infinity as a Googleplex. We could attempt to write a Googleplex, but that seems like a hopeless goal. The known universe can't accommodate a piece of paper large enough to have all of the zeros in a Googleplex written out explicitly on it, and the paper is. There is, thankfully, an easier and more condensed way to write a Googleplex, which is 1010 Lz0, and even infinity, which is pronounced infinity. The charred crust of a burnt apple pie is composed primarily of carbon. After 90 cuts, you will arrive at a carbon atom that has 6 protons, 6 neutrons, and 6 electrons in its nucleus, and a cloud of 6 electrons surrounding it. If we were to remove a portion of the nucleus, for example, one that contains 2 protons and 2 neutrons, we would be left with not the nucleus of a carbon atom, but rather the nucleus of an atom of helium. In nuclear weapons and conventional nuclear power plants, atomic nuclei undergo a process known as cutting or fission. However, carbon is not split apart. If you make the 91st cut of the apple pie and slice a carbon nucleus, you don't end up with a smaller piece of carbon. Rather, you end up with something else. An atom with completely different chemical properties. You can change the elements by cutting an atom into smaller pieces. Continue on with this. Atoms comprise subatomic particles known as protons, neutrons, and electrons. Is it possible to split a proton? If we bombard protons with other elementary particles at high energies, say other protons, we can glimpse more fundamental units hiding inside the proton. Physicists now propose that so-called elementary particles, such as protons and neutrons, are in fact made of even more elementary particles called quarks, which come in a variety of colors and flavors, as their properties have been termed in an emotionally moving attempt to make the subnuclear world a little more like home. Are quarks the tiniest and most fundamental particles that make up matter? Or do they consist of even smaller and more fundamental particles? If there is an infinite regression into more fundamental particles, will there ever come a time when our understanding of the nature of matter will be complete, or will it always expand? This is one of the most important scientific questions yet to be answered. Alchemy was the name given to the practice pursued in medieval laboratories to change one element into another. According to ancient Ionian speculation, many alchemists believed that all matter was a combination of 4 fundamental substances: water, air, earth, and fire. They believed it was possible to transform copper into gold by adjusting the proportions of fire to earth in a certain way. The field was teeming with charming frauds and conmen, such as Cagliostro and the Count of Saint-Germain, who pretended not only to be able to transmute the elements but also to hold the secret to immortality. They conned their victims out of a significant amount of money. Sometimes gold would be concealed in a wand with a false bottom, and then it would miraculously appear in a crucible after a particularly laborious scientific experiment. The practitioners of this questionable art were able to entice the European aristocracy with promises of wealth and immortality in exchange for large sums of money. However, there were other, more serious alchemists, such as Paracelsus and even Isaac Newton. Due to the expenditure, new chemical elements such as phosphorus, antimony, and mercury were found, so the money was completely well spent. These experiments are, in fact, directly responsible for giving rise to the modern field of chemistry. 92 naturally occurring atoms can be classified according to their chemical properties. They are known as the chemical elements, and until fairly recently, everything on our planet was made up of them, even though they are most commonly found combined into molecules. Hydrogen and oxygen are the two elements that make up the atoms of the water molecule. Nitrogen, N, oxygen, O, carbon, C, hydrogen, H, and argon, R, make up the majority of the atoms that make up air, and these elements exist in the molecular forms of nitrogen dioxide, N2, oxygen dioxide, O2, carbon dioxide, CO2, and argon. The Earth is an abundant place with a conglomeration of atoms with silicon, oxygen, aluminium, magnesium, and iron making up the majority. There is no chemistry involved in the creation of fire at all. It is a radiating plasma in which some electrons are stripped away from their nuclei due to the high temperatures. One of the ancient Ionian and alchemical elements is a molecule, two are mixtures of molecules, and the last is a plasma. None of these four things can be considered an element in the modern sense. Since the time of the alchemists, an ever-increasing number of elements have been discovered, with the most recently discovered elements typically being the rarest ones to be found. Many are well known, particularly those that predominantly compose the Earth or those that are essential to the existence of life. Some are solids, some are gases, and two are liquids at room temperature, bromine and mercury. It is customary for scientists to arrange them in ascending order of complexity. Hydrogen, element 1, is the simplest, and uranium, element 92, is the most complex. Other elements, such as hafnium, erbium, dysprosium, and praseodymium, are less familiar to us because we do not typically come into contact with them in our day-to-day lives. In general, the prevalence of an element increases in proportion to how well known it is. Iron is one of the most abundant elements on Earth, while yttrium is one of the least abundant. There are some notable exceptions to this rule, including gold and uranium, which are prized either because of arbitrary economic conventions or aesthetic judgments, or because they have remarkable practical applications. A relatively recent discovery is that atoms comprise three different types of elementary particles: protons, neutrons, and electrons. These three types of particles make up the atomic nucleus. It wasn't until 1932 that scientists found evidence of the neutron. The complexity of the material world has been reduced to an astonishing simplicity thanks to modern physics and chemistry. Combined in various configurations, three basic units are the building blocks of everything. As stated, and following what one might infer from their name, neutrons do not carry any electrical charge. The protons and the electrons carry a negative charge, but the protons have a slightly stronger charge. Electrons and protons have opposing electrical charges, creating an attractive force that keeps the atoms together. Because each atom maintains its internal electrical balance, the number of protons in the nucleus and electrons in the electron cloud must be equal. The atomic number, which is equal to the number of protons and is referred to as the electron count, is the only factor that determines the chemical composition of an atom. Pythagoras would have approved of the notion that chemistry is nothing more than the manipulation of numbers. If you are an atom with one proton, your name is hydrogen. If you have two, your name is helium. If you have three, lithium. If you have four, beryllium. If you have five, boron. If you have six, carbon. If you have seven, nitrogen. If you have eight, oxygen. And so on until you have 92 protons. Your name is uranium. Charges that are identical or have the same sign are extremely repellent. It's possible to think of it as a dedicated mutual aversion to their own kind, almost as if the world were densely populated by anchorites and misanthropes. Electrons have a repulsion towards electrons. Protons do indeed repel other protons. How, then, does a nucleus maintain its structure? Why does it not just disintegrate into pieces right away? Because there is another force in nature, not gravity, not electricity, but the short-range nuclear force, which, like a set of hooks that engage only when protons and neutrons come very close together, overcomes the electrical repulsion among the protons. Specifically, the short-range nuclear force is akin to a set of hooks that only engage when protons and neutrons come close together. Neutrons, which only contribute nuclear forces of attraction to the nucleus and have no effect on its electrical forces of repulsion, act as a glue that helps to keep the nucleus intact. Despite the hermit's desire for seclusion, their fellow hermits have been chained together, and each of them has been instructed to be friendly and talkative with everyone. The nuclei of a helium atom, which is exceptionally stable, comprise 2 protons and 2 neutrons. Carbon's nucleus is composed of 3 helium nuclei, oxygen's is composed of 4, neon's is composed of 5, magnesium's is composed of 6, silicon's is composed of 7, and so on. Every time we add 1 or more protons and sufficient neutrons to maintain the structure of the nucleus, we create a new element in the periodic table of chemical elements. The ancient alchemist's dream of turning mercury into gold can be realized if we remove 1 proton and 3 neutrons from the element mercury. In addition to uranium, the Earth does not have naturally occurring deposits of the other elements. They are created by humans, and almost immediately they disintegrate into their component parts. One is called plutonium, one of the most toxic substances science has ever discovered. Element 94. Regrettably, it crumbles to pieces in a rather sluggish manner. Where do the elements that occur in their natural state originate? We could make a separate creation for each different atomic species. The universe, however, is almost entirely composed of hydrogen and helium, the 2 most fundamental elements. In fact, helium was discovered on the Sun long before it was discovered on Earth. Hence, the origin of its name comes from Helios, one of the Greek sun gods. Are hydrogen and helium the progenitors of the other periodic table elements? It is necessary to bring pieces of nuclear matter close to engage the short-range nuclear forces to balance the electrical repulsion and the short-range nuclear forces. Only at extremely high temperatures, where the particles are moving so quickly that the repulsive force does not have time to act, which is at temperatures of tens of millions of degrees, is it possible for this to occur? In the natural world, such high temperatures and the accompanying high pressures are only ever found on the interiors of stars. We have looked at the Sun, the nearest star, in various wavelengths, ranging from radio waves to regular visible light to X-rays, originating only from the Sun's outermost layers. It is not exactly a red-hot stone, as Anaxagoras thought. Rather, it is a large ball of hydrogen and helium gas glowing due to its high temperatures, like a poker glows when it is brought to red heat. At the very least, Anaxagoras was partially correct. During violent solar storms, brilliant flares interfere with Earth's radio communications. Additionally, enormous arching plumes of hot gas, guided by the Sun's magnetic field, dwarf the Earth. Sunspots are cooler regions on the Sun's surface with increased magnetic field strength. They are sometimes visible to the naked eye at sunset. All of this churning, roiling, and turbulence is taking place on the surface, which is relatively calm. Temperatures of approximately 6,000 degrees are all that we observe. However, the Sun's dark interior, where the light comes from, has a temperature of 40 million degrees. The gravitational collapse of a cloud of gas and dust in interstellar space gives rise to the formation of stars and the planets that orbit around them. The collision of the gas molecules within the cloud's interior generates heat, eventually raising the temperature to the point where hydrogen can fuse into helium. This occurs when 4 hydrogen nuclei combine to form a helium nucleus, accompanied by the release of a gamma photon. The photon endures alternating bouts of absorption and emission at the hands of the matter above it as it slowly works its way towards the surface of the star, gradually losing energy at each stage of its epic journey. This ordeal lasts 1 million years before the photon finally emerges from the star's surface as visible light and is emitted into space. The light on the star has been turned on. the prestellar cloud's gravitational collapse has come to a halt for now. The high temperatures and pressures produced by the nuclear reactions occurring within the star's core currently support the weight of the star's outer layers. For the past 5 billion years, the Sun has maintained this level of consistency in its environment. In a controlled and ongoing explosion, the Sun is powered by thermonuclear reactions like a hydrogen bomb. These reactions convert approximately 400 million metric tons, 4 times 1014 grams, of hydrogen into helium every second. When we look up at night and observe the stars, everything we see is glowing due to nuclear fusion in the distance. An enormous glowing superbubble of extremely hot gas can be found in the direction of the star Deneb, located in the constellation of Cygnus the Swan. This superbubble was most likely produced by supernova explosions near the bubble's center, which are the deaths of stars. The shock wave from the supernova causes the interstellar matter to be compressed at the periphery, which in turn causes new generations of cloud collapse and star formation. In this sense, stars are said to have parents. However, much like it is sometimes the case with humans, a parent may pass away when the child is born. Massive cloud complexes like the Orion Nebula, where stars like the Sun are born in batches, have the characteristics of a nebula. These clouds give off an ominous and dark impression when viewed from the outside. On the other hand, the newborn stars within them cast a brilliant light throughout their interiors. Later, the stars leave their nursery to seek their fortunes in the Milky Way. Nebulosity still glows around these stellar adolescents, and their leftovers are still gravitationally bound to the amniotic gas they were born in. A good local example would be the Pleiades. As is the case in human families, the maturing stars travel very far from their birthplace, and as a result, the siblings rarely interact with one another. There are other stars in the galaxy, perhaps dozens of them, that are the Sun's brothers and sisters. They originated from the same cloud complex approximately 5 billion years ago. However, we are unable to identify the stars in question. They are on the opposite side of the Milky Way from where we are. The transformation of hydrogen into helium in the Sun's core produces photons of visible light that make up the Sun's brightness. This transformation also produces a more enigmatic and spectral radiance. Neutrinos are subatomic particles that, like photons, have no mass and move at the speed of light. The Sun emits a very faint glow of neutrinos. However, neutrinos are not the same thing as photons. They do not belong to the category of light. Neutrinos and protons, electrons, and neutrons all possess an intrinsic angular momentum known as spin, but photons do not. Neutrinos can travel through matter unimpeded, as evidenced by their ability to travel through the Earth and the Sun. The matter in between only prevents a minute portion of them from moving forward. During this brief examination of the Sun, 1 billion neutrinos travel through my eyeball. They pass through the back of my head unimpeded because, unlike regular photons, they do not get stopped at the retina as they travel through the eye. When I look down at the ground at night, towards where the Sun would be, if the Earth were not in the way, almost the same number of solar neutrinos pass through my eyeball. These neutrinos are pouring through an interposed Earth that is as transparent to neutrinos as a pane of clear glass is to visible light. This is the curious part. If our understanding of the solar interior is as comprehensive as we believe it to be, and if we also have an understanding of the nuclear physics that is responsible for the production of neutrinos, then we should be able to calculate with a reasonable degree of accuracy how many solar neutrinos we should receive in a specific area, such as my eyeball, in a specific amount of time, such as a second. Obtaining experimental confirmation that the calculation is correct is a lot more difficult. Because neutrinos travel through the Earth unimpeded, we can't capture any particular one. However, for many neutrinos, only a tiny portion will interact with matter, which may be detectable under certain conditions. Neutrinos have the potential to transform chlorine atoms into argon atoms that have the same total number of protons and neutrons. American physicists have poured a large quantity of cleaning fluid into the Homestake mine in Lead, South Dakota, to detect the predicted solar neutrino flux, which requires enormous chlorine. The mine is located in the Black Hills. A microchemical process removes the chlorine in preparation for the newly produced argon. The greater the amount of argon discovered, the greater the number of neutrinos inferred. The results of these experiments suggest that the Sun emits a lower level of neutrinos than what is predicted by the calculations. There is a genuine mystery that has not been resolved here. The low solar neutrino flux will likely not jeopardize our understanding of stellar nucleosynthesis, but it does mean something significant. The proposed explanations range from the idea that neutrinos break up while traveling between the Sun and Earth to the concept that the nuclear fires in the interior of the Sun are temporarily banked and that sunlight is being generated in our time in part by slow gravitational contraction. One of the most popular hypotheses is that neutrinos break up while traveling between the Sun and Earth. However, neutrino astronomy is still in its infancy. We are still in awe that we have developed a device capable of peering directly into the raging core of the Sun. As the sensitivity of the neutrino telescope continues to improve, it will become possible to investigate the possibility of nuclear fusion occurring deep within the interiors of nearby stars. The fusion of hydrogen, however, cannot go on indefinitely because there is a finite amount of hydrogen fuel in the interior of stars, like the Sun and other stars. The initial mass of a star is a critical factor in determining how it will ultimately fare at the end of its life cycle. When a star reaches the end of its life cycle, it does so in a manner that is strikingly dissimilar to that of the Sun. This is the case even if the star has lost matter to space and still has 2 or 3 times the mass of the Sun. However, the destiny of the Sun is quite spectacular. After 5 or 6 billion years from now, when all of the central hydrogen has reacted to form helium, the zone of hydrogen fusion will slowly migrate outward, becoming an expanding shell of thermonuclear reactions until it reaches a location where the temperatures are less than about 10 million degrees Celsius. After that, the process of hydrogen fusion will turn off by itself. During this time, the Sun's self-gravity will cause its helium-rich core to contract again, increasing the Sun's interior temperatures and pressures. The helium nuclei will be crammed together even more closely to the point where they will begin to adhere to one another. This will occur even though the nuclei's short-range nuclear forces will be repelled by one another's electrical attraction. The ash will be converted into fuel, which will in turn cause the Sun to begin a second cycle of fusion reactions. This process will generate carbon, oxygen, and additional energy for the Sun, allowing it to shine for a limited time longer than it would otherwise. A star is like a phoenix in that it is doomed to rise from its ashes after a certain amount of time. The Sun will transform significantly due to the combined effects of hydrogen fusion in a thin shell far from the solar interior and high-temperature helium fusion in the core. This will cause the Sun's exterior to expand and cool over time. It is predicted that the Sun will eventually evolve into a red giant star, with its surface visible from space being so far removed from its core that the Sun's gravity will weaken at its surface while its atmosphere blows away into space in a stellar gale. When the Sun reaches its full size and expands into a red giant, it will engulf and consume the planets Mercury, Venus, and most likely, the Earth. After that, the Sun's interior will be home to the inner solar system. There will be one final day on Earth that is without flaw when it is billions of years in the future. After that, the Sun will gradually turn red and become bloated, presiding over a planet that will be scorching hot all the way to the poles. The ice caps in the Arctic and Antarctic will eventually melt, which will cause flooding along the coasts of the world. The high temperatures of the oceans will cause more water vapor to be released into the air, which will result in an increase in cloudiness, which will shield the Earth from sunlight and postpone the end of the world. However, the evolution of the Sun cannot be stopped. At some point in the not-too-distant future, our planet will be overtaken by a catastrophe of unfathomably massive proportions, resulting in the oceans boiling and the atmosphere dissipating into space. In the interim, humans will have developed into substantially different species. Our descendants will likely be able to control or influence the evolution of stars, or, as Robert Goddard envisioned, they could search for an uninhabited planet in some young and promising planetary system and move there. Another option is that they could pick up and move to Mars, Europa, or Titan. To a certain extent, the stellar ash that comes from the Sun can be recycled and used as fuel. When that time comes, the interior of the Sun will be composed entirely of carbon and oxygen, and further nuclear reactions will be unable to take place at the temperatures and pressures that are currently in place. After almost all of the central helium has been consumed, the collapse of the Sun's interior will continue at some point in the future. This will cause temperatures to rise again, setting off a final chain reaction of nuclear reactions and causing the solar atmosphere to expand slightly. The Sun will eventually expel its atmosphere into space in the form of one or more concentric shells of gas as it goes through the final stages of its life cycle. The Sun will slowly pulsate during this time, expanding and contracting once every few millennia. The shell will be inundated with ultraviolet light due to the hot, exposed solar interior, resulting in a beautiful red and blue fluorescence extending beyond Pluto's orbit. This may cause the Sun to lose half of its mass. When this occurs, the solar system will be filled with an eerie radiance that can only be described as the ghost of the Sun. When we turn our attention to the region of the Milky Way immediately surrounding us, we notice that many of the stars are encircled by glowing spherical shells known as planetary nebulae. They have nothing to do with planets, but some seem to be reminiscent of inferior telescopes of the blue-green disks of Uranus and Neptune. The only reason they appear as rings is that we see more of them at the periphery than the center, similar to how we see more soap bubbles. Every planetary nebula is evidence of a star that has reached the end of its life. Near the primary star, there might be a retinue of dead worlds, the husks of planets that were once teeming with life but are now devoid of atmosphere and oceans and are illuminated by a spectral kind of light. The remnants of the Sun, which will consist of the exposed solar core initially encased in its planetary nebula, will be a small hot star that will eventually cool off into space after having contracted to a density that is unheard of on Earth and is greater than 1 ton per teaspoonful. In the distant future, billions of years from now, the Sun will degenerate into a white dwarf before eventually transitioning into a dark and lifeless black dwarf, just like all those points of light we see at planetary nebulae' centers. If two stars have roughly the same mass, their evolution will be relatively similar. But a star with a greater mass will burn through its nuclear fuel more quickly, transform into a red giant at an earlier stage, and be the first to begin the decline into a white dwarf. As a result, there should be many instances of binary stars, with one component being a red giant and the other being a white dwarf, and there are such cases. Some of these pairs are so close to one another that they touch. When this occurs, the glowing stellar atmosphere flows from the expanded red giant to the compact white dwarf. This glowing stellar atmosphere tends to fall on a particular region of the surface of the white dwarf. The intense gravity of the white dwarf causes the hydrogen to accumulate, which in turn causes it to be compressed to higher and higher pressures and temperatures. This continues until the stolen atmosphere of the red giant goes through thermonuclear reactions, at which point the white dwarf briefly flares into brilliance. A nova is the name given to this type of binary, and its origin is very different from that of a supernova. Supernovae are the result of the fusion of a single star, whereas novae are only the result of binary star systems. It is common for atoms created within the interiors of stars to be returned to the gas between them. The outer atmospheres of red giants are blown away into space, and planetary nebulae result from Sun-like stars reaching their final stages of evolution before exploding. During a supernova, a significant portion of the stellar mass is violently ejected into space. The atoms returned are naturally those most readily made in the thermonuclear reactions in stellar interiors. Hydrogen fuses into helium, helium into carbon, carbon into oxygen, and after that, in massive stars, by the successive addition of further helium nuclei, neon, magnesium, silicon, sulfur, and so on are built, additions by stages, 2 protons and 2 neutrons per stage, all the way to iron. Iron is produced when 2 atoms of silicon, each with 28 protons and neutrons, combine at a temperature of billions of degrees to form a single atom of iron with 56 protons and neutrons. This process is known as the direct fusion of silicon. These are all well-known constituents of chemical substances. We are familiar with their names. The nuclear reactions in stars do not easily produce erbium, hafnium, dysprosium, praseodymium, and yttrium. However, rather than the elements we are familiar with in our day-to-day lives, elements returned to the interstellar gas, where they were swept up in a subsequent generation of cloud collapse and the formation of stars and planets. All elements that make up Earth, except hydrogen and a small amount of helium, were created through stellar alchemy billions of years ago in stars, some of which are now obscure white dwarfs on the opposite side of the Milky Way galaxy. This process cooked up all of the elements that make up Earth. The interiors of stars that were in the process of collapsing were the source of the nitrogen that is in our DNA, the calcium that is in our teeth, the iron that is in our blood, and the carbon that is in our apple pies. We are composed of the stuff of the stars. The supernova's explosion can produce some of the universe's most exotic elements. As a result of the numerous supernova explosions that took place just before the solar system formed, the Earth contains a relatively abundant supply of gold and uranium. Other planetary systems may have different concentrations of these extremely rare elements. Is it possible that there are worlds whose inhabitants wear niobium pendants and protactinium bracelets with pride but consider gold nothing more than a laboratory curiosity? If gold and uranium were as rare and unimportant on Earth as praseodymium, would our quality of life be better? The beginning and development of life are most closely related to the birth and growth of the universe's first stars and galaxies. To begin, the very matter of which we are composed, the atoms that make it possible for there to be life, were generated in giant red stars a very long time ago and very far away. There is little room for doubt that red giants and supernovae are the furnaces and crucibles in which matter was forged, because the relative abundance of the chemical elements in the cosmos matches the relative abundance of the atoms generated in stars. The Sun is a star that belongs to the second or third generation. All of the matter in it and the matter around you has been through at least one or two cycles of stellar alchemy in the past. Second, the discovery of specific types of heavy atoms on Earth proves that an enormous supernova exploded in the neighborhood before the Sun, planets, and other solar system components came into existence. However, it is highly unlikely that this is merely a coincidence. It is more likely that the shock wave produced by the supernova compressed interstellar gas and dust, which in turn triggered the condensation that led to the solar system's formation. Third, when the Sun began to shine, its ultraviolet radiation poured into the Earth's atmosphere, and its surface's warmth caused lightning to form. These different energy sources served as the spark that ignited the complex organic molecules that eventually led to the beginning of life. Fourth, almost all of the energy that sustains life on Earth comes from the Sun. Plants are responsible for absorbing photons and transforming them into chemical energy. The plants are parasitized by the animals. Methodically harvesting sunlight through the use of plants as reluctant intermediaries constitutes farming. Solar energy provides the majority of our power. Last but not least, the hereditary shifts known as mutations provide the essential building blocks for evolution. Cosmic rays are high-energy particles ejected almost at the speed of light in supernova explosions. These particles contribute to the production of mutations, which nature then uses to select its new inventory of life forms. The spectacular demise of ancient, extremely massive suns is one of the driving forces behind the development of life on Earth. Imagine going to some location very deep within the Earth, such as a gold mine or a lava tube with a Geiger counter and a piece of uranium ore in your possession. A lava tube is a cave carved through the Earth by a river of molten rock. The sensitive counter clicks when subjected to gamma rays or high-energy charged particles like protons and helium nuclei. The count rate and the number of clicks per minute significantly increase when we place it close to the uranium ore undergoing spontaneous nuclear decay and emitting helium nuclei. The count rate drops significantly after the uranium ore is placed inside a heavy canister made of lead because the lead has taken in the radiation from the uranium. However, there are still some clicks that can be heard. A portion of the counts that are left is overcome by the natural radioactivity that is present in the cave walls. However, there are more clicks than can be explained by the radioactivity. Some are brought on by high-energy charged particles that have broken through the roof. We are currently listening to cosmic rays created in a previous era, deep within the reaches of space. For the entirety of our planet's existence, it has been pounded by cosmic rays, most of which are composed of electrons and protons. In a galaxy thousands of light-years away, a star annihilates itself, producing cosmic rays that spiral through the Milky Way galaxy for millions of years, until, quite by accident, some of them strike the Earth and our genetic material. These cosmic rays are thought to have played a role in the evolution of life on Earth. It's possible that cosmic rays were responsible for the initial stages of the development of the genetic code, the Cambrian explosion, or the evolution of our ancestors into bipedal stature. A guest star was discovered by Chinese astronomers on July 4, 1054, within the constellation of Taurus, also known as the Bull. A star that had never been seen before became more brilliant than any other star in the sky. In the American Southwest, halfway around the world, there is a high culture abundant in astronomical knowledge. The traditions of the past witnessed this dazzling new star. We know that in the middle of the 11th century, some Anasazi, the ancestors of the Hopi of today, lived under an overhanging ledge in New Mexico because carbon-14 dating of the remains of a charcoal fire revealed this fact. One apparently drew a picture of the new star on the cliff overhang, where it would have been protected from the elements. Its location concerning the waning crescent moon would have been the same as depicted. In addition, there is a handprint, which may be the artist's signature. An astronomer centuries later had the uncanny experience of being reminded of a crab when looking at the explosion remnants through his telescope. This remarkable star is located 5,000 light-years away and is now known as the Crab supernova. The Crab Nebula is all left of a massive star that went supernova millions of years ago. On Earth, the explosion could be seen with the naked eye for 3 months. Even though it was easy to see during the day, you could read it at night. In any given galaxy, there will be a supernova approximately once every century on average. A typical galaxy will live for about 10 billion years when 100 million stars have blown themselves apart. This is a significant number, but it still accounts for only about 1 star in 1,000. Tycho Brahe observed and described a supernova in the Milky Way in 1572, following the event in 1054. Shortly after that, in 1604, Johannes Kepler described another supernova in the Milky Way. Astronomers have been chomping at the bit for centuries, but unfortunately no supernova explosions have been observed in our galaxy since the invention of the telescope. This has caused them much frustration. It is now common practice to spot supernovae in galaxies other than ours. The following passage from a paper written by David Helfand and Knox Long and published in the issue of the British journal Nature dated December 6, 1979, is one of my candidates for the sentence that would most thoroughly astound an astronomer working in the early 1900s. On 5th of March 1979, an extremely intense burst of hard X-rays and gamma rays was recorded by the 9 interplanetary spacecraft of the Burst Sensor Network and localized by time-of-flight determinations too. There is also, contrary to what you might anticipate, a relatively insignificant Magellanic Cloud. On the other hand, E.P. Mazets and colleagues from the IOFA Institute in Leningrad, who observed this source with the gamma-ray burst detector aboard the Venera 11 and 12 spacecraft while they were traveling to Venus, argue that what is being observed is a flaring pulsar that is only a few hundred light-years away. Their findings were published in the same issue of Nature, but Helfand and Long do not insist that the gamma-ray outburst is associated with the supernova remnant, even though their positions are very similar. They carefully consider a wide range of possibilities, including the possibility that the origin is somewhere within the solar system. It could be the byproduct of an extraterrestrial starship's long journey back to its home planet. The rekindling of the stellar fires in N49 points to a more straightforward explanation. We are certain that supernovae are real phenomena. The future of the inner solar system is not looking good as the Sun continues to evolve into a red giant. On the other hand, there is no danger of a supernova exploding and turning the planets into a molten mess. This calamity befalls planets that orbit stars that are significantly more massive than the Sun. The lifetimes of stars with higher temperatures and pressures than the Sun are significantly shorter due to the rapid depletion of their stores of nuclear fuel. The Sun's lifetime is approximately 93 billion years. It only takes a few million years for a star with tens of times the Sun's mass to convert hydrogen into helium in a stable manner, before the star shifts its focus to nuclear reactions that are more unusual. Therefore, there is almost certainly not enough time for the evolution of advanced life forms on any of the accompanying planets, and it will be extremely unlikely that beings elsewhere will ever be able to know that their star will become a supernova. If people survive long enough to learn about supernova, it is highly unlikely that their star will ever explode. The formation of a massive iron core through the fusion of silicon is an essential step that must take place before a supernova can occur. The equal and opposite electrical charges cancel each other out, transforming the star's interior into a single giant atomic nucleus, which occupies a much smaller volume than the precursor electrons and iron nuclei. This process takes place under enormous pressure and results in the free electrons in the stellar interior being forcibly melded with the protons of the iron nuclei. A violent implosion occurs at the core, followed by a rebound of the exterior, leading to an explosion known as a supernova. A supernova can emit more light than the total radiance of all of the other stars in the part of the galaxy in which it is located. Those recently hatched massive blue-white supergiant stars in Orion are on track to become supernovae within the next few million years, continuing the cosmic fireworks in the Hunter constellation. The incredible supernova explosion causes the majority of the matter from the precursor star to be propelled into space. This includes trace amounts of hydrogen-helium and significant quantities of other atoms, such as carbon, silicon, iron, and uranium. The remnants consist of a core of hot neutrons that are held together by nuclear forces, a single massive atomic nucleus with an atomic weight of approximately 1056, a sun that is 30 kilometers across, a tiny, shrunken, dense, withered stellar fragment, and a rapidly rotating neutron star. The core of a massive red giant collapsing to form a neutron star spins faster as it does so. The neutron star at the heart of the Crab Nebula is an enormous atomic nucleus that spins 30 times per second and is roughly the size of Manhattan. Its robust magnetic field, amplified during the collapse, captures charged particles to a greater extent than Jupiter's much more modest magnetic field. Electrons circulating in a rotating magnetic field give off beam radiation that can be detected at radio frequencies and in visible light. If the Earth happens to be in the path of the light from this cosmic lighthouse, then we will see it blink once for every rotation. Because of this characteristic, astronomers refer to it as a pulsar. Pulsars, which flash and tick like a cosmic metronome, keep time significantly more accurately than even the most accurate standard clock. The timing of the radio pulse rate over a longer period for some pulsars, such as PSR 0329 plus 54, suggests that these objects may have one or more small planets as companions. A planet can survive the transformation of a star into a pulsar, and it is also possible that a planet could be snatched up later. I can't help but imagine what the sky would look like if I were standing on such a planet. Neutron star matter weighs about the same as an average mountain per teaspoonful. Because of this, if you were to take a small amount of neutron star matter and let it go, which would be nearly impossible, it could pass through the Earth as easily as a falling stone through air, carving a hole for itself completely through our planet and emerging out the other side, possibly in China. People who live there might be going about their day-to-day activities when all of a sudden a neutron star the size of a pebble emerges from the ground, floats in the air for a short while, and then sinks back down into the ground. providing at least a momentary distraction from the monotony of the day. If a piece of neutron star matter were to be dropped from nearby space while the Earth was rotating beneath it as it fell, it would repeatedly plunge through the rotating Earth, punching hundreds of thousands of holes before the motion was stopped by friction with our planet's interior. Before it comes to rest at the Earth's center, our planet's interior may momentarily resemble Swiss cheese. However, the subterranean flow of rock and metal will heal the wounds as it moves towards the planet's center. It is probably for the best that large chunks of neutron star matter have never been discovered on Earth. On the other hand, there are numerous bumps present. The formidable force of the neutron star is latent in the nucleus of each atom. It is concealed in every teacup and dormouse, as well as every breath of air and apple pie. The neutron star instills an appreciation for the unremarkable aspects of life. As we have seen, a star with the same lifespan as the Sun will end its days as a red giant and then a white dwarf. A star with twice the Sun's mass on the verge of collapse will transform into a supernova and a neutron star. But a more massive star that is still around after its supernova phase will have an even more remarkable end in store for it. Its gravity will turn it into a black hole. This is because its mass will be 5 times that of the Sun. Imagine for a moment that we had access to a magic gravity machine, a tool that would allow us to manipulate the planet's gravitational pull at the turn of a dial. At first, the dial is positioned at 1G, and everything acts in the manner that we have come to be accustomed to anticipating. All of the living things on Earth, including plants and animals, as well as the architecture of our buildings, have either evolved to or been designed for BMG. If gravity were significantly weaker, there might be tall, spindly shapes that would not be thrown over or crushed by the weight of their own bodies. If the force of gravity were significantly higher, all living things, including plants, animals, and buildings, would need to be compact, stocky, and strong to avoid toppling over. But light would still travel in a straight line even in an environment with a fairly strong gravity field, just as in everyday life. Imagine a typical gathering of people from Earth attending the tea party described in Alice in Wonderland. As gravity is reduced, the weight of objects drops. When they get close to 0 GA, even the slightest movement causes our friends to float and tumble up into the air. Tea or any other liquid, when spilt into the air, will form pulsating spheres because the surface tension of the liquid will overcome the force of gravity. There are tea balls scattered all over. The tea maker will start working if we give the number 1G another try. Everyone becomes immobile when we slightly increase the gravity, from 1G to 3 or 4 Gs, because even moving a pore requires significant effort in this environment. Before we continue to dial in higher gravities, we remove our friends from the territory controlled by the gravity machine. The light emanating from a lantern moves in the same manner when subjected to accelerations of a few Gs as it does when subjected to accelerations of 0G. At 1000 Gs, the beam is still straight, but trees have become squashed and flattened. At 100,000 Gs, rocks are crushed by their own weight because of the force exerted by the beam. Ultimately, nothing is left alive except for the Cheshire Cat, who was granted a miraculous exemption. Something even stranger takes place when the gravitational acceleration approaches 1 billion Gs. The direction in which the beam of light has been traveling, which has been directly upward into the sky until this point, is beginning to curve. Even light is perturbed when subjected to extremely high magnitude gravitational accelerations. If we strengthen gravity, the light will be drawn down to the ground closer to where we are. The cosmic Cheshire Cat has disappeared, leaving only its gravitational grin behind. When the gravity is high enough, nothing, not even light, can escape. There is nowhere to go. A location like this is referred to as a black hole. It is a cosmic Cheshire Cat, mysteriously indifferent to its surroundings and a complete enigma. When the black hole's mass density and gravitational pull reach a certain threshold, it evaporates and vanishes from our universe. Because no light can pass through it, we refer to it as black. Inside, things are attractively well lit because the light is kept down where it can't escape. Even though a black hole cannot be seen from the outside, the gravitational presence of a black hole can still be felt. If you are not paying attention while on an interstellar journey, you may be drawn into it irreversibly, and your body is stretched into an uncomfortably long and thin thread. In the unlikely event that you made the journey alive, however, the process of matter accumulating into a disk surrounding the black hole would be a sight to remember. Thermonuclear reactions occurring deep within the solar interior keep the sun's outer layers stable and put off the inevitable collapse of the sun's gravitational field for billions of years. The pressure exerted by the electrons that have been removed from white dwarf's nuclei is what keeps the star intact. Neutron stars can defy gravity due to the intense pressure caused by their neutrons. But no known force can prevent the implosion of an old star with a mass more than several times that of the Sun if it has been left behind after supernova explosions and other violent events. The star undergoes a remarkable contraction, spins, turns red, and finally vanishes. A star with 20 times the Sun's mass will eventually contract until it is the size of Greater Los Angeles. At this point, the crushing gravity will reach 1010 Gs, and the star will disappear from our universe after passing through a self-generated crack in the space-time continuum. In 1783, an English astronomer named John Mitchell conceived the concept of black holes. But because it was such an odd concept relatively recently, people paid more attention to it. Then, much to the surprise of many astronomers, evidence was discovered that pointed to the existence of black holes in space. The atmosphere of Earth blocks X-rays from reaching the surface. To determine whether or not astronomical objects emit light with such short wavelengths, it is necessary to lift an X-ray telescope into the air. The United States of America launched the first X-ray observatory into orbit from a launch pad located in the Indian Ocean off the coast of Kenya. This observatory was given the Swahili name Uhuru, meaning freedom. Uhuru discovered an extremely brilliant X-ray source in the constellation of Cygnus, also known as the Swan, in 1971. This source was found to be turning on and off 1,000 times every second. The origin, which we call Cygnus X1, is quite modest. Regardless of what caused the flicker, information about when to turn on and off can only travel across Cygnus X1 as fast as the speed of light, approximately 300,000 kilometers per second. Therefore, the maximum width of Cygnus X1 can be no more than 300 kilometers. Something on the order of the size of an asteroid shines as a brilliant source of X-rays that can be seen from interstellar distances. What is it trying to say? Cygnus X1 is located in the exact same region of the sky as a hot blue supergiant star. This star, which shines in visible light, reveals that it has a massively close but unseen companion that pulls it gravitationally in one direction at first, and then in the other. Cyg X1 is located in the exact same location. It is estimated that the mass of the companion is approximately 10 times that of the Sun. Identifying the companion inferred in visible light with the source detected in X-ray light is tempting because the supergiant is an unlikely source of X-rays. But this identification must be corrected. A black hole is the only possible explanation for an invisible object that weighs 10 times as much as the Sun and can be compressed into a volume no larger than an asteroid. The X-rays may be produced by friction in the disk of gas and dust that has accreted around Cygnus X1 due to its supergiant companion. The stars V861 Scorpii, GX3394, SS423 and Circinus X2 are all candidates for the role of black hole in their respective systems. The remnant of a supernova known as Cassiopeia A can be found in the constellation Cassiopeia. Its light should have arrived on Earth in the 17th century when there were a lot of astronomers. But the explosion was not reported by anyone. It is possible that, as I.S. Shklovsky hypothesized, a hidden black hole there consumed the exploding stellar core and put out the fires of the supernova. The shards and pieces of data that may be the spoor or the trail of the fabled black hole can be checked using space-based telescopes. These telescopes are how this can be accomplished. Consideration of the curvature of space can be of assistance in developing an understanding of black holes. Imagine a two-dimensional flat surface, flexible and lined like a piece of graph paper made of rubber. When we drop a relatively light object, the surface will deform and become puckered. The marble's motion around the pucker can be compared to the orbit of a planet around the Sun. Einstein is credited with providing us with this interpretation, which describes gravity as a distortion in the space fabric. Using this as an example, we can see how the presence of mass can distort space into a third dimension of the physical world. Imagine that we are located in a three-dimensional universe that is locally warped into a fourth physical dimension that we cannot perceive directly due to the presence of matter. The severity of the pucker, distortion, or warp in space increases in proportion to the magnitude of the local mass, which determines the strength of the local gravity. According to this illustration, a black hole is comparable to a bottomless pit. What exactly takes place if you go under? Because all of your mechanical and biological clocks would have stopped. Falling in would take infinite time when viewed from the outside. However, when viewed from your perspective, it would appear that all of your clocks are operating normally. If there was some way for you to survive the gravitational tides and the radiation flux, and if the black hole was rotating, which is a likely assumption, then it is possible that you could emerge in another part of space-time, somewhere else in space, some other time. Wormholes in space, similar to the ones found in apples, have been given serious consideration, even though their existence has not been established. Would it be possible for gravity tunnels to serve as an interstellar or intergalactic subway, making it possible for us to travel to previously inaccessible locations much more quickly than we could have done using more traditional methods? Are there any possibilities that black holes could act as time machines, taking us to the far past or future? The fact that ideas of this nature are being debated, even in a semi-serious manner, demonstrates how absurd the universe may be. In the most profound sense, we can be considered children of the universe. Please picture yourself standing in the middle of a cloudless summer day with your arms stretched before you and think about how dangerous it is to look directly at the sun. We can sense its power even from 93 million miles, 150 million kilometers. What sensations would we experience if we were to stand on its bubbling, self-illuminating surface or be submerged in its core of nuclear fire? The sun keeps us warm and enables us to eat and see. It brought forth life on Earth. Its might is incomprehensible to human experience. The dawn is greeted by the joyful chirping of various species of birds. Even single-celled organisms can navigate towards sources of light. Our ancestors were not naive, as evidenced by their worship of the sun. Despite this, the sun is a fairly average, even unremarkable star. Does it not make sense to revere the sun and the stars if we must worship a power greater than ourselves? An element of wonder can be found dormant within every astronomical investigation. In some cases, it is buried so deeply that the investigator is oblivious that it even exists. The galaxy is an uncharted continent teeming with strange beings of stellar dimensions waiting to be discovered. During our preliminary exploration, we came across some of the locals and took some of their measurements. A few of them are familiar to us in some ways. Others are strange in ways that surpass even our most unrestrained imaginations. But this is just the beginning of our investigation into the area. Discoveries made in the past have led researchers to believe that many of the galactic continent's most fascinating inhabitants are still undiscovered. Planets, globular clusters, and Magellanic clouds with stars in orbit around them are all almost certain to be found near the galaxy. The Milky Way is also in the vicinity. Such worlds would provide a breathtaking view of the Milky Way as it rose into view. The Milky Way is an enormous spiral form that is made up of 400 billion stellar inhabitants, collapsing gas clouds, condensing planetary systems, luminous supergiants, stable middle-aged stars, red giants, white dwarfs, planetary nebulae, novae, supernovae, neutron stars, and black holes. It would be obvious from such a world, just as it is starting to become obvious from our own, how the profound connection between life and the cosmos determines our matter and form and a significant portion of our personalities.
The night sky is dominated by darkness. Across the sky, many glittering sparks drift over our heads. We notice their beauty, but not much else. These dazzling pinpoints are not visible to our eyes. Observe, they are true to nature. They are mysteries to our eyes. Since Galileo's time, humanity has sought to move beyond the scope of biology. Telescopes have opened the heavens to earth, revealed the far reaches of the universe, and revealed galaxies cloaked in darkness. Hubble has achieved more than any other telescope to bring home the wonder and reality of the universe. Hubble was launched in 1990 by NASA and ESA. It orbits Earth 350 miles, or 569 kilometers above its surface. Due to its position, it can circle free of Earth's atmosphere, which distorts and blocks light from space. Ground-based telescopes are unable to match Hubble's pristine views. Every 97 minutes, the telescope whirls around the Earth collecting light, much more light than our eyes can see alone. From the nature of storms on Jupiter to the distant galaxies of the universe, this light can reveal everything. Hubble sees structure where we see light points. Hubble sees detail where we see the haze. While we see darkness, Hubble sees the faint glow of the early universe. Astronomers have uncovered some of the most fascinating cosmic discoveries of our time thanks to Hubble's explorations and a host of new questions and puzzles that will be explored by future telescopes to push back the darkness. The cosmos. There are many puzzles in a universe. There are times when the things we cannot see are more important than what we can see. We use the visible to piece together the great mysteries of the invisible. Take the behavior of matter around black holes, for example. The mysterious, still unexplained phenomenon of dark energy is revealed by distant stellar explosions. The age of the universe is estimated by studying distant stars. Cosmology is the study of the universe's structure and context. We study how the universe functions as a whole, how it is currently and will be in the future, and how things within it form. Cosmology is a little like being inside a building, examining the switches and outlets we can see on the surface to determine the wiring inside. Space is a vacuum, but its objects are part of a larger structure, and astronomers must understand this structure's physics before understanding how the features function. Looking out at space is like looking back in time. Our location receives light from the farthest objects in the universe that left those objects billions of years ago, so we see them as they were then. How do we see these farthest objects when we capture their light? Most distant galaxies are more minor, irregular, and lack clearly defined shapes. Hubble could see these distant galaxies before any other telescope. After observing a nearly empty patch of sky for 10 days, astronomers turned Hubble on what appeared to be a roughly bare patch of sky. The team was taking a risk. Most Hubble observations take only hours, and the time was better used on less speculative projects. Hubble might not have been able to see the objects the astronomers hoped to find, because they were too faint or too small. The search yielded the now famous Hubble Deep Field image, containing 3,000 galaxies, large and small, amorphous and shaped, burning in the depths of space. Astronaut Hubble looks back in time. The farther Hubble gazes into space, the farther it gazes back in time. Recent surveys, such as Hubble's Ultra Deep Field, HUDF, and the Great Observatory's Origins Deep Survey, GOODS, provide images of vast collections of galaxies, including some that date back to when the universe's time was less than 1 billion years old. The Hubble Space Telescope teamed up with other observatories in the following years to study small patches of the sky in high-resolution, long exposures and multiple wavelengths. This chart shows Hubble's most significant deep sky surveys and their covered regions. We can follow the evolution of the universe with images. The most distant parts of the visible universe are littered with tiny red dots, the shapeless building blocks of galaxies whose light has been stretched by the expanding universe into an infrared glow. As we move closer, we see galaxies colliding and merging, increasing growth. Further away, we see versions of the large, stately galaxies we know today. Seeing how galaxies have evolved can show how the universe we know today evolved from a uniform void to an uneven universe ready for stars and galaxies to form. Furthermore, the differences in these galaxies allow us to learn about the first stages of the universe, the part we can't see. There was already some structure when the galaxies formed, or the spread of matter would have been even. In contrast, we see the coalescing of groups of importance, small pieces that began, collided, and merged. This Cepheid variable star in galaxy M100 doubles in brightness during each pulsation. We are being beamed down from the sky with the answers to the universe's age. We know the universe has been expanding since the Big Bang. So, if we can measure its size and rate of expansion, we can calculate its age. There is more to it than you might think. All estimates are based on the brightness of objects, since you can't extend a ruler to the stars. Cepheid variable stars are a particular type of pulsating star whose brightness cycles indicate their inherent brightness. Observers find Cepheid variable stars in galaxies by comparing their intelligence with how faint they appear due to their tremendous distances, to determine the distance to those galaxies. It's like judging a car's distance from you by judging the brightness of its headlights on a dark street. Cepheid variable stars enable astronomers to measure distances in space. Discover how pulsating stars serve as yardsticks for measuring the universe. Cepheid variables have been found in galaxies as distant as NGC 4603, 108 million light-years away. Their stars appear faint from Earth. It is complicated to distinguish the characteristics of the Cepheids found in NGC 4603. Cepheids were used to determine the distance to the galaxy. Up until Hubble, astronomers could only narrow the universe's age down to 10 to 20 billion years, a measurement with 10 billion years of error. Hubble conducted a comprehensive study of 31 Cepheid variable stars, determining the current expansion rate and narrowing the universe's age down to its most precise point. In combination with measurements by other observatories, observations of Cepheid variable stars in galaxies like NGC 4603 led to the estimate of 13.7 billion years old. With Hubble's observations, the universe's age changed from a vast range of possibilities to a precise number. It isn't just a matter of curiosity to know the universe's age. Having a timescale for the development of stars and galaxies will help refine our models of how the universe and everything in it formed. Numerous elements of cosmology were shaped by the actual age of the universe. Star and galaxy formation timelines required a period. Previous problems with the universe's age range have included things like stars thought to be older than the universe. We can now determine everything from the time needed for stars to die to how long it takes to produce elements such as carbon, nitrogen, and oxygen, the ingredients we need to survive. A watershed epoch is shown on each side. From the Big Bang to the present, it represents the universe's evolution over 13.7 billion years. As a result of reionization, the light from the first stars burned off a fog of cold hydrogen. A later epoch quasar pumped enough ultraviolet light to reionize the primordial helium with the black hole-powered cores of active galaxies. Radio telescopes were first used to study some familiar cosmic objects, including the remains of supernovae, distant galaxies, and influential areas of star formation. The quasars in these images appear to emanate from one galaxy, left, and two galaxies colliding, right. there are 1.5 billion and 1.6 billion light-years between the galaxies respectively. The entity that appeared to be a star appeared to be nothing more than a light point. As quasars are so far away and their size is so tiny, about the size of our solar system, the fact that we can see them with a telescope makes them among the most luminous objects in the universe. As Hubble proved with its high resolution, there was actually a galaxy hidden behind the glare of the quasar. He contributed to the quasar mystery. The surrounding regions of a supermassive black hole heats up and releases enormous energy and light, creating a quasar. As a result of multiple galactic mergers, Hubble found quasars in the centers of galaxies colliding or brushing up against one another and in elliptical galaxies. Quasars may be lit up by these interactions and fed by the central black hole. Observations by Hubble have also led to the discovery that these brilliant galactic centers are powered by giant black holes. Quasars weren't the only ones involved. According to Hubble, almost all galaxies with bright active centers have supermassive black holes feeding on the galaxy's matter. Additionally, the mass of a black hole is closely related to the mass of the bulge of stars forming the center of the universe, indicating that the formation of a galaxy is closely related to that of its black hole. The study of these monstrous black holes raises many questions about the formation of galaxies and the structure of the universe. Why do some regions form galaxies with massive black holes and others include rather ordinary galaxies? Why does the black hole phenomenon exist over such a wide range of sizes, from giant black holes in galaxies to tiny black holes a few times the size of our Sun? Is the formation of quasars just a stage in constructing supermassive black holes? The universe began with a bang and has been expanding since then, increasing the distance between galaxies with time. For many years, astronomers contemplating the death of the universe considered two main scenarios. Either the universe would keep expanding forever, the galaxies gradually drifting apart, or it would stop growing and collapse in a big crunch. In the late 20th century, astronomers believed the universe would expand forever at a constantly decreasing speed, coasting like a car out of gas, but never totally losing momentum. They began determining the rate of expansion. The brilliant stellar explosions known as supernovae could also be used to determine the distances to galaxies, just as they were for Cepheid variable stars. However, supernovae can measure distances even farther than Cepheids because of their incredible brightness. Astronomers used Hubble's clear vision to find the very distant supernovae needed to calculate the universe's expansion rate. Hubble's observations, however, upended the conventional wisdom. The universe wasn't slowing down. A study of the properties of the supernovae Hubble had imaged revealed that the universe was expanding faster and faster as if it were being propelled. Understanding what is causing this acceleration will take time, since it doesn't seem to be a part of the glowing matter we see. How could this be? Scientists have no idea. A previously unknown dark energy might be the cause, but humans are only just beginning to understand the mysteries of this field. We must develop tests for a phenomenon invisible to us to describe and define dark energy until it is as clear as the stars in our own backyard. For now, Hubble continues to study the supernovae that might hold the key to unraveling this mystery. Dark energy's discovery. Known as Type 1a supernovae, certain exploding stars constantly emit the same amount of light. As a result, their brightness is nearly the same. Type 1a supernovae vary in brightness because some are closer to us and others farther away. By comparing the apparent intelligence of the supernovae with their actual brightness, astronomers can calculate the distances to the supernovae. The distance to the galaxies where the supernovae occurred is also indicated. Astronomers believed the universe's expansion would slow down as the distances to faraway galaxies increased. Cosmologists can measure the universe's expansion rate at different times in the past based on the brightness of Type 1a supernovae. Hubble found that the most distant supernovae were dimmer than they should have been, indicating that they and their galaxies were farther away. This contradicted the hypothesis that the universe expanded constantly or slowed down over time. Only if the universe was growing faster could they make sense of their space. Scientists involved won the 2011 Nobel Prize for Physics for their discovery. The science of the galaxy. Galaxies are islands of activity in a sea of emptiness, where the action takes place in space. We will never be able to travel far enough to see our Milky Way galaxy from the outside, composed of 100 billion to 400 billion stars. While we can observe the activity within our own galaxy and the interactions between galaxies far away, we can also watch the activity within our own galaxy. Hubble helped identify the sources of the universe's most powerful explosions, studied how galaxies formed, and studied stars near the end of their lives. The universe is revealed in its most precise and visible form by our observations of galaxies. Through the study of galaxies, we can observe the dynamics of the cosmos and how things form and change. We observe dominant galaxies feeding off their surroundings and stars, created under the influence of galactic gravitational forces, and puzzle over the varied shapes galaxies take. The study of galaxies past and present is essential to understanding the forces that shape our existence. The minor solar system resides within a universe. The United States Air Force deployed a series of satellites to monitor gamma rays in the 1960s. After signing the Nuclear Test Ban Treaty, the United States wanted to watch for the telltale radiation emitted by nuclear blasts. The satellites immediately began detecting gamma-ray events, but the study ruled out the possibility of bombs. In reality, there was no connection between the bursts and Earth. Scientists further investigated and slowly realized they were witnessing explosions with the power of 10 million billion suns per day, emanating from seemingly random points in the cosmos. Until then, the universe's most violent explosions had gone undetected. Gamma rays. What are they? Gamma ray burst 971214. This galaxy, located 12 billion light-years from Earth, gave off a gamma ray burst in 1998 that was brighter than the entire universe for a few seconds. A release of energy of such a rapid and enormous magnitude had never been seen by astronomers before. The extreme events that produce gamma rays and why we look for them are explained by scientists. The gamma ray burst of 080319b. During a powerful gamma ray burst in 2008, this single object was as bright as 10 million galaxies for nearly 1 minute. The observations followed up on the mystery and concluded that the shots came from supernovae, explosions of massive stars that can produce a black hole or neutron star. Nevertheless, not all supernovae had gamma-ray bursts. What was the actual cause? Observations by Hubble have revealed that many gamma-ray eruptions originate in bright star-forming regions with stars with low metal content. Currently, scientists know there are at least 2 kinds of gamma-ray bursts. There may be a difference between the process of creating a supernova from a star that has lots of metal and one with little. Stars with low metal content are thought to produce black holes when they die, while stars with high metal content form neutron stars instead. Gamma-ray bursts are often black hole birth announcements if that's true. Gamma-ray bursts add another piece to the puzzle of supernovae. Because supernovae are one of the few methods astronomers have for measuring vast distances in space, understanding these titanic explosions is key to understanding the universe. Witnessing the explosion in action can help us determine how it happened. A neutron star is surrounded by gas and dust, all that's left after a supernova explosion. The neutron star N49 emitted a tremendous gamma-ray burst a decade before this observation. Tracing the history of the galaxy. Gravitational pull can cause galaxies to collide and merge. Galaxies crashed more frequently in the early universe than today, and astronomers believe that these collisions are necessary for galaxies to grow and evolve. It is thought that our own Milky Way galaxy, along with Andromeda, has increased in size by absorbing smaller nearby galaxies. We can test this hypothesis by studying the ages, arrangements, compositions, and speeds of stars in a galaxy. The simulation shows an entire galaxy collision sequence and compares the different stages of collision to those observed by Hubble in various galaxy pairs. A combination of simulations and high-resolution observations can help us to better understand these titanic crashes. Observations of 300,000 stars, young and old, in Andromeda's halo by Hubble. During Hubble's time, he observed the halo of the Andromeda Galaxy, a region of stars located beyond the central galactic disk. Andromeda is the nearest large galaxy to our Milky Way, and while it has been observed from the ground frequently, Hubble's resolution allows it to be seen at an individual star level. Because halo stars develop early during galaxy formation, astronomers expected Andromeda's stars to be old. However, they found that the stars in the galaxy's outer regions range from around 13 billion to 6 billion years old. Andromeda would have eaten the smaller galaxies, bringing them into the Andromeda halo and making them their own stars. Based on Hubble's observations, all large galaxies have experienced galaxy mergers and interactions throughout history. Scientists have known for years that the Milky Way and Andromeda are headed toward one another, but it is still an open debate whether they will collide, brush against one another, or miss one another. One day, we'll be able to see that for ourselves. Hubble has revealed that the Milky Way and the Andromeda Galaxy are directly colliding. The two mammoth galaxies will collide in 4 billion years, spinning together in a slow, massive dance, eventually combining into a single universe. The sideways motion of the Andromeda Galaxy was observed by astronomers over 5 to 7 years. Using Hubble observations, scientists predict the future of the Milky Way and Andromeda galaxies. Based on computer simulations, the two galaxies are expected to collide in 4 billion years. Earth and its companion planets will not be affected by the collision, as the Sun is flung into a new region of the galaxy. The distance between stars is so great that there is little chance of stars striking each other when galaxies collide. Stars that are dying. A planetary nebula is a unique and beautiful formation formed by gas heated by radiation from a white dwarf. Over about 30,000 years, mid-sized stars like our Sun eject their outer layers of gas into space, leaving behind their